application of origin destination modeling to predict ridership in buses and other vehicles. And in the far left, you'll see the application of GIS to optimize bus routes and also pick the right locations using operations research tools for stops. Many of you have traveled through the San Francisco airport before, and that entire complex is now managed with GIS, including all the rooms and walking times from gate to gate and so on. But speaking about time, the upper left-hand slide is interesting because it shows real-time traffic monitoring. Increasingly, this is a pattern going on in various regional and national agencies showing real-time geography. Engineering and public works management organizations are embracing the power of GIS to do their applications at many scales. I'd like to draw here your attention to the map in the center by Tetra Tech, which is a pipeline, showing a pipeline across Pennsylvania being constructed. What they applied is the web map pad pipelines, not the exact location, but the approximate location, which is helping excavate and understand the grid underground. Water and wastewater management agencies around the world are using GIS for asset management, things like being able to support service orders or manage inspections. Look at the one on the left. It's looking at the analytics. It's making a map showing age of the network, analyzing, again, where investments should be made. But here, my favorite is up in the upper right. It's showing not a real time, but looking over the last quarter at sewer conditions and how they changed almost at a glance. In other words, summarizing all of the asset information and its management. Utility energies, electricity and gas, are likewise using GIS for traditional applications like asset management and vegetation management, and increasingly for outage management, like this interesting map in the center showing the outage of the Colonial Pipeline gas network in the southeast as a result of the cyber terrorism activities. But in almost every utility that I'm talking with these days, they're moving over to renewable energy. They're hunting for the right locations for solar and for wind production and applying GIS to manage their farms in a whole new way. Similarly, in telecommunications, both traditional networks, wireline or 4G, is being managed extensively with GIS, but also the next generation of telecommunication, 5G, like this beautiful example in Sydney showing siting of tower to support using viewshed, pick the right location for these towers. And in Albuquerque, they're doing network planning. And our national government here in the US is using it to assess and model the coverage of broadband for the entire country. This is a very important topic because it identifies those areas where we have the potential of a digital divide, those populations that are being left behind because they're not connected to the web with powerful enough network. Our cities, our countries, our nation, our world is safer because of GIS. In the law enforcement areas, they are looking at past historic crime rates to see pattern and allocate resources accordingly. They're also increasingly looking at real-time information, doing crime monitoring. They're looking at everything from school threats in local geographies all the way to monitoring our global security risk. And EMS organizations and fire organizations are not only picking the right locations for their facilities, like based on drive times, but they're also addressing major and significant issues like the opioid crisis here in the United States, being able to respond more effectively. In the field of disaster preparedness and response, likewise, GIS has had a long history. These examples show some of the modern stuff that's going on. I'm fond of this one in the Congo done by Kokusai Kogyo, looking at ground deformation near a volcano. But whether it's fire real-time or fire assessments of risk, or doing damage assessments, and in flooding, and in severe weather, GIS is playing a very significant and major force. Now, The lower right shows, again, Kokusai Kogyo in Japan simulating the Fukushima earthquake that had happened a few years ago. And in this simulation, they're developing methods to be able to apply very quickly what might happen in other places in Japan and around the world. In 2020, the US Census carried out their centennial count of population. And GIS was central for this, not simply in making the maps, which are shown here, but also in actually structuring and running the census. It's based on geography, of course. And they were able to maintain with dashboards the completeness of their count as they carried it out. Now that the census is done, America is doing redistricting, which are political redistricts for congressional members. And GIS is again playing a significant role. I'll call your attention here to the map on the far right and the lower, which is illustrating population migration to Libya from across Africa. Libya is kind of a gateway into Europe for migrants, and these maps are quite extraordinary. Your work in social equity, particularly in the last year, is striking. You are studying the lingering effects of redlining, or de facto redlining still existing in Detroit. You're looking at accessibility, for example, accessibility to health facilities, or the relationship between poverty and access to legal resources, or in your planning work, looking at trails and equity planning and park accessibility relative to equity, creating understanding and creating what I see in the future, a more equitably and balanced population. COVID has affected nearly all of us. And last week, we passed this mark of 4 million people on the planet have died as a result of this horrible disease. Your work has contributed here because it's shown the world what's going on. The great work by Johns Hopkins University keeps track even today and has made over 2 trillion maps. Not only are we better informed of what the status is, but as the interesting visualization in the center shows, we've been able to look at patterns. This is showing the dynamics of what happened in Central Europe, or Europe, during the winter months during the disease. And your applications in site selection for vaccination, or return to office management, or even look at the interesting map in Liberia where they mapped in great detail every case and set up quarantine zones to shut the pandemic down, and it worked. GIS continues to grow and be hugely beneficial in both business analysis and economic development. These examples show it. Optimizing delivery routes, cutting carbon. Picking the right locations to avoid multi-hazard insurance, like in Japan. Picking the right sites, picking the right territories. All of these are very powerful, not just in business, but increasingly being used in government to target economic development sectors of various types. Imagery and remote sensing of many different types is increasingly infiltrating, impacting, benefiting the GIS workflows that many of you do, whether it's vegetation health from recently collected drone imagery or forest inventories at a massive scale, like at the US Forest Service. Over on the far right, you'll notice this intriguing map to look into the ground and understand pipe deficiency. And another one like that is the satellite-derived bathymetry map. And then, I like this slide very much because your work is showing a complete gamut, including surveillance of illegal fishing to protect the Galapagos, for example, and modeling snow depth and runoff. These are hugely beneficial dimensions of remote sensing that are affecting GIS and geography in general. These maps show a collection of just beautiful cartography. And I picked these myself. I just found them very interesting. The warming of the Arctic by the Woodville Climate Research Center, or these maps of Mars and the terrain surfaces. And look at this interesting one about picking suitable landing sites for the Mars lander. We'll come back to that later in this session with a presentation from JPL. The hiking map atlas I'm very fond of This company in Austria has been in existence for 250 years, and they now have a completely automated GIS-based atlas generation activity. And over in the far left, we can look at a zoning map that was made for colorblind populations. It's an interesting palette that is available now that we can apply in various sorts of settings. All of these maps that I've been showing you, these maps, but also all of the work that I've shared in the last few minutes, have interesting stories associated with it. I absolutely sense that I grew as I read these stories. I understand better the kind of footprint, the magnitude of the work that you are up to. Each year, we select out of our 350,000 customers around the world, a small group of people, less than 150, to receive what we call a Special Achievement in GIS Award, or a SAG Award. These are the ones that were selected this year in the United States, and these are the ones that were selected around the world. These organizations distinguish themselves by really doing fantastic things. They organized all the data. They built the right applications. They organized the right institutional settings for their work. And normally, I would have them all stand up if we were all together in an audience and we could acknowledge them in the right way. I won't be able to do that obviously today, but I do want to send a warm message to all of you in these organizations, how very proud I am of your work, but also just you should feel very proud and special for doing the kinds of things you're doing. Each year, we also select several of our users for very distinguished acknowledgement. The first one this year is the Making a Difference Award, which is going to Nespresso. This is a division of Nestle. And this organization is amazing because it's working with over 140,000 farmers, small farmers, scattered through 20 countries, helping them in sustainability farming. They have over 400 staff working with these farmers. Well, I don't want to speak all day about them, but I'm very, very excited about them. I'd just like to share this short video and then introduce you to Jan DiPietro.
Que se despierten todas las mañanas tomándose el mejor café del mundo y que estén totalmente tranquilos de que ese café proviene de un equipo atrás de cafeteros, de un proyecto de agrónomos que están en pro de la calidad, pero siendo muy responsables siempre con las comunidades, con las familias, con los trabajadores, con el agua, con la tierra, con los árboles. Queremos apostarle a reducir la huella de carbono que se puede producir por una taza de Nespresso, mantener la calidad del agua, tratar de descontaminar el máximo lo que se puede y cuidar los suelos, ¿sí? Y la estructura ecológica principal de la región cafetera.
La aplicación de siembra en el modelo agroforestal, porque le está garantizando al caficultor que va a tener una sombra adecuada para el proceso de calidad de su propio café.
Somos responsables de que la cuenca siga floreciendo agua, siga progresando, siga produciendo café, el café que ustedes se toman, el café Nespresso AAA.
Dear Jack, dear GIS community, greetings from Switzerland. I'm Jan, and on behalf of Nespresso and all the teams involved, I want to thank you for this incredible award. Innovation and sustainability are deeply anchored in Nespresso DNA. So it's no wonder that we started to use ArcGIS to support our journey towards positive impact. We use ArcGIS in many fields of work within the Nespresso AAA program, climate actions such as agroforestry, and more recently for COVID-19 response in support of partners and farmers. Climate change is clearly the greatest threat of the 21st century, and coffee is no exception. We will only be able to meet the challenge with a clear action plan and the efficient technologies to bring it to life.
We are really pleased to receive this award, recognizing our work and vision on sustainability. Of course, we could not be at this level without strong partnership and specifically Esri along the way. We are currently finalizing our sustainability strategy and vision for 2030. And as we will address and continue to address the key biggest challenges on sustainability, such as climate change, farmers' livelihood, circularity, or carbon neutrality, digitalization and geospatial analysis in particular will be key for us in the implementation of this strategy. We know many challenges are ahead of us. Businesses must be part of the solution, and Nespresso will continue to focus on being a force for good, to preserve our planet and to improve the livelihood of our farmers and the communities. Thank you again for this reward, and take care.
It is extraordinary work, and I think all of you would agree, this kind of footprint is giving us a model for the entire world about working diligently at creating a more sustainable planet. Our second special award this year is being given to LOGIC. This is the Louisville Jefferson County Information Consortium. This has been going on for 35 years. It was started in part by Kurt Bynum, who is still there. He's still the GIS manager. They have 1,300 different databases that they maintain. They have thousands of applications that support water and sewer and urban planning and law enforcement and citizen engagement. It's a real enterprise system with the city and the county and lots of volunteers. Accepting this year's prize is actually the Mayor Fisher, Greg Fisher from the city of Louisville. So Greg.
Hello, everybody. Louisville prides itself as a city where innovation is driven by community collaboration. Our Logic GIS represents a successful 30-year partnership that has changed how we conduct our community's business and serve and inform the residents of our great city. Logic is our shared warehouse of all manner of spatial data about our community. I want to thank our Louisville Metro government team members who work directly with Logic, the Jefferson County Property Valuation Administrator, the Louisville Water Company, and the Metropolitan Sewer District for enthusiastically backing the idea of collaboration to help our community. I also want to thank Kurt Bynum, Director of Logic, and his team for delivering on this critical resource. Most recently, we used Logic to monitor and report the impacts of the COVID-19 pandemic in our community. Logic also has been a valuable asset in our important work of advancing racial equity and economic development through the creation of a large and growing gallery of interactive web maps, dashboards, and story maps to inform our citizens and share our wealth of spatial information about our community. Our goal has always been for Logic to serve as a model for GIS collaboration, organization, governance, funding, and resource sharing. So on behalf of all of our partners, professional GIS staff, and our growing user community, we are proud to accept this Enterprise GIS Award. Great job, everybody. Thank you.
Well, thank you, Mr. Mayor. That's great. And the little short summary gives you some glimpse of just how, the reason why I picked this organization. It's a geospatially literate community. The third award this year is actually my award. It's the President's Award. And this year we're giving it to the University of Michigan. University of Michigan is a very large, over 50,000 student campus. Actually, it has 3 campuses. And they're being given this award for a whole bunch of reasons. Peter Koop, who is the lead GIS person on campus, has brought GIS to the entire campus. It's opened up the eyes of many departments, and they're doing not only simple GIS access to every student, but they're also going deep in some of the best work that I've ever seen. I'm particularly fond of Peter because not only is he a beacon of how to do university-wide enterprise implementation, but he also shares. He criticizes us, makes us better, but he also shares to educators around the world about how to set this up, how to make this thing come alive. So, Peter, could you say a couple words for us, please?
Thank you, Jack. It is truly an honor to have our work geo-enabling our university recognized with the President's Award. Over 7,000 people use GIS across our institution, and that community continues to grow year over year at an ever-accelerating pace. Our goal to empower everyone with everything GIS began with the introduction of ArcGIS Online. The software as a service model enabled us to greatly expand the reach of GIS beyond the traditional desktop server world of the past, with minimal effort and to all disciplines. Today, most units on campus have some faculty or staff using GIS, while nearly all degree programs include students who have used some form of GIS during their time at the U. On behalf of the University of Michigan and my fellow GIS advocates joining me today, thank you again, Jack, for honoring our work with your award.
Thank you again, Peter. It's just amazing. And I want to say, all of us appreciate the great work and leadership that you're providing. I'd next like to move on to the theme of this year's conference, GIS Creating a Sustainable Future. This is a strong vision, and part of the vision was inspired by a recent book that I read by Mario Palma, who is one of the founders of INEGI, which is the large statistical and science and mapping organizations in Mexico. He said the following in his book: lack of understanding of our reality is one of the greatest risks our society is facing. And I think all of us in the GIS community, all of us in the world community can understand this. He also later said in his book, our future depends upon creating and applying that understanding. And these were the beacons that started INEGI, but they're also, for me, they speak to me. These words speak to me because they really are a purposeful way of describing our work, creating and applying understanding. Our world is a complex and highly interdependent ecosystem that's rapidly changing and evolving. The world we live in is actually not well known. It's fragile. It's rich in biodiversity, which is disappearing at an alarming rate. It's also increasingly dominated by human activities. And geologists are beginning to call this the Anthropocene epoch, that epoch where humans absolutely dominate the life and the history, the life, the future of our world. Today, our world is being challenged because us as humans are living recklessly and unsustainably. And this is threatening our future. Human-induced climate changes and overpopulation are resulting in interconnected patterns of change, steep declines in biodiversity, and many other factors. We read about them, scientists tell us about them almost every day. Clearly, for me, personally, for me, it speaks that we collectively, we as a general human population, but also we as GIS users, are collectively responsible for its future. And it could go many ways. Creating a sustainable future, which I believe is possible, will require that we dramatically change our priorities. I believe in this strongly, about making a major commitment to life and our future. And we must act now in order to achieve this. There are many things to do, like restoring nature, improving business efficiencies, reducing pollution, consuming less, implementing sustainable land use patterns, and many, many more. Applying our best science and our best technology and our best creative thinking will clearly be necessary. And I can't help but think and know that geographic thinking is going to be essential in this. Sustainability requires that we see the world as one single ecosystem. Geography, the science of our world, provides the science and the language to be able to do this. It helps us organize and integrate all the factors, environmental factors like biodiversity and ecosystem services, and integrate them with economic systems, spatially, seeing their connections. It allows us to integrate them with social factors, and the maps that you shared, that I shared about your work a few minutes ago, are the evidence of this. It not only organizes and integrates all the factors, It also illuminates patterns and relationships and helps us discover things. It provides us a framework for understanding and applying our knowledge. I like to call this the geographic approach. The geographic approach is a way of thinking and problem solving that integrates geographic science and information into how we understand and manage our planet. And Mario Palma would clearly understand that. It's a holistic approach. It brings sciences together. It's integrated. It supports and is enriched by spatial understanding, and it is also collaborative. The idea is supporting multiple objective solution creating, inclusive and multidisciplinary in its nature. And the great hope, the great vision, is that this will impact virtually every sector of our society going forward. This approach is familiar to many of you here in the audience. Geoanalytics, creating insights and understanding. Geovisualization, a language like through maps and visualization for communicating the content of our world and the context of our world. Geodesign, designing sustainable and inclusive futures. Geocollaboration, engaging all the stakeholders, and geoaccounting, being able to account for all the factors, setting up measures that are not just economic driven, but are driven in a mixed way, balanced way. And this geoscience and understanding can support our future. It can support our planning, our decision making, our engineering, our operations, how we manage our individual organizations, and how we manage the world. These are all critical. And I appreciate the good work that you are already doing. Clearly, GIS enables the geographic approach. The very tools that you use for measuring and visualizing and analyzing and making predictions, doing planning, making decision makings, all that work that you do is a kind of framework and a process for applying geographic knowledge, this integrative knowledge widely. And as I already said, you're already doing this. You are applying the geographic approach and creating so many solutions for a sustainable future. You are protecting biodiversity. You are reducing the use of precious resources. You're optimizing logistics. You are managing sustainable agriculture and forests. The examples from, for example, the great coffee growers are proof of this. However, clearly, we need to scale up our collective efforts exponentially. GIS technology can help us. It's not the only thing, but it can help us. And it is advancing rapidly. It's integrating many new innovations, helping us reach this kind of scale. This will be essential. Things like cloud computing, advanced analytics, the integration of imagery and remote sensing, interactive mapping, 3D visualization. Remote sensing is just a piece of it, but it's a major and significant part. Opening up access to this through the multitude of apps. All of this will help us scale up our collective efforts. GIS is also increasingly becoming interconnected, creating what I like to refer to as geospatial infrastructure. We're connecting our systems, and this in turn is helping us collaborate. It's helping us share. It's transforming workflows and decision-making at many scales. Geospatial infrastructure actually is, and I'm seeing this live in different organizations like Louisville, for example, it's actually transforming organizations. It's creating a whole new kind of intelligent infrastructure, not just digital infrastructure, not just water infrastructure, sewer infrastructure, or road infrastructure. It's creating a new kind of infrastructure for organizing and making distributed data that we collect available. As a basis for this, it's shared geospatial services organized through portals for discovery and access by apps that now support all types of users. This is an exciting time because this infrastructure, and I'm watching it closely, and so are you, is expanding really quickly. It's supporting not only local applications, shared information and so on, but also global applications with millions of users and tens of millions of shared data sets and services that are being made available in this way. It's making billions of maps every day. And these billions of maps are reaching billions of people. They're changing how they think. It's creating a whole new kind of global information system. You've heard me before talk about a nervous system for our planet. My sense is this infrastructure is creating a nervous system for sustainability. I'd like to talk about some of the details of this nervous system. First, geospatial infrastructure is integrating all kinds of data. It can now integrate all types of tabular data and map data and imagery data. It can integrate real-time data and abstract them into these web maps and layers and scenes that we're finding so dramatically useful, so that apps of many types can use them. Geospatial infrastructure delivers powerful apps, not just for GIS users in desktops and so on, but these apps are going to scale with massive mobile deployments for collecting data and also disseminating data. And also the pervasiveness of web apps is just unbelievable. Literally trillions of maps being looked at around the world. And my big hope is that this will continue to expand as it has in the last couple of years, enveloping and bringing us together as a society. Some more details. This geospatial environment, these geospatial capabilities are becoming embedded in other large IT enterprise systems. Our colleagues in other companies like Microsoft and IBM and Salesforce and Amazon and on, Autodesk, are putting maps and geospatial information into their apps. And that is, in turn, changing how they do engineering and CRM. And yeah, well, you can just look at it. It's really integrating geospatial thinking and geographic thinking into the apps that non-GIS professionals use across the organizations. And complementing this is the enrichment that's happening as a result of advanced GIS analytics. This is allowing us to see new things, create new insights with predictive modeling or the ability to analyze spatial temporal information together, the ingestion of real-time information, and the simple tools to be able to interactively do visual spatial analytics. These are powerful. And then enriching it further is GeoAI, machine learning, and so on. And the ability now to store imagery in the cloud and perform advanced raster analytics. And finally, big data, the ability to integrate and pull on and create understanding from these massive data sets. I want to talk about a couple of these. Big data integration is going to open our eyes. It's going to let us see new things, relationships we never understood before. The ability to access these massive data collections from transactional systems and imagery and link them to the very same tools that you are using will create new forms of understanding. Imagery and remote sensing is one category of that big data, and it is enriching GIS, as we already saw in the examples that you shared, all the way from simple image-based maps for thematic underlays to oriented imagery, integration of motion imagery, dynamic image processing, point cloud visualization, and as I mentioned before, GeoAI and machine learning, which is allowing us to pull off the image feature information that enriches our GIS. All of this imagery data is increasingly being used in raster analytics and modeling. And increasingly that's being put into the cloud. We'll talk more about that together. Bringing all of these sources of data together and being able to integrate into your work these timely information sets. Well, I have been talking a bit about the nature of the geospatial infrastructure. I'd like to shift for a couple of minutes to hearing from the U.S. Forest Service. Actually, the U.S. Forest Service has been my customer now for 51 years. It's quite extraordinary that they are now, the chief of the Forest Service is going to share with us some of the great work they are doing at scale, bringing a lot of this information together. So, Vicki Christensen, can you start it off for us, please?
The mission of the United States Forest Service is to sustain the health, diversity, and productivity of the nation's forests and grasslands for the benefit of future and current generations. And the purpose of our stewardship work is supporting nature in sustaining life. And to advance our mission and to serve our purpose, we balance the short-term and the long-term needs of people and nature by working collaboratively with communities and partners, by delivering world-class science, technology, and land management, and by providing access and resources and experiences that promote economic, ecological, and social vitality, and by connecting people to the land and to one another. And one of our key values is grounding our decision-making in authoritative science, inasmuch as the agency and other forest managers across the country are facing difficult choices and opportunities about carbon management, addressing environmental justice, and supporting a resurgent economy. Our research and development branch is actively supplying essential data, information, and knowledge to inform decision makers and the public. You know, Congress charged our Forest Inventory and Analysis Program, FIA, to improve our use and integration of advanced remote sensing technologies. And to fulfill this request, our R&D unit and our CIO and Esri are engaged in a critical partnership in developing the next generation of information products designed to inform today and tomorrow's policy and management decisions regarding our nation's forests. So let me pass this over to our great FIA team, who will share the details of their work and recent successes.
Hi, I'm Hobie Perry, and I'm joined today by my colleagues Ty Wilson and Chris Oswalt. FIA collects measurements of trees and other attributes on a network of over 350,000 plots. Each plot has a footprint a little smaller than a football field. We have plots from Palau to the Virgin Islands, and let's take a look at Wisconsin. You'll see we sample national forests. We sample state forest lands. We sample tribal lands. We sample lands managed by county and local government. And all those plots not in any colored polygon are the observations we collect on private lands. We monitor all of America's forests to facilitate shared landscape scale stewardship. Now we know we can't measure everything. The Southern Appalachians highlight the incredible variation in land use that occurs between the plot observations. We also know that remotely sensed imagery alone can't match the richness of data captured by boots on the ground. So we created Big Map, our cloud computing solution optimized and tuned to leverage the parallelization and mass storage required for raster processing at scale. We fused thousands of Landsat scenes with hundreds of thousands of plots, ultimately processing tens of trillions of pixels in the cloud, all in a matter of days. This map of forest type groups is just one example of the authoritative, science-based output we are now publishing. Layers like this help us understand the variation and complexity of the forest resource. For example, we know that different forest types, shown here in Northern California, have different sensitivities and responses to wildland fire. Naturally, we make this content available to you, along with our agency colleagues. We're publishing it in the Forest Service ArcGIS Online organization, the Living Atlas, and open data portals. We support planning and decision-making with a seamless workflow from data generation to discovery, consumption, and application. Another example is this map of predominant major forest carbon pools. Management actions will differ for landscapes dominated by live biomass in green, a dead biomass in purple, or soil carbon in brown. And maps like these give us the ability to populate spatially explicit tools that may be integrated into conservation planning to support carbon management, wildlife stewardship, watershed restoration, and other environmental services. But I'm getting ahead of myself because I suspect you're interested in how this actually happens. So let me introduce Ty to explain more.
I'm going to take you on a quick tour highlighting some of the science behind our Big Map project. In order to tackle complex, multidimensional raster analysis problems, we leveraged the versatility of ArcGIS with Python and its numerous machine learning packages to build custom algorithms modeling the relationship between satellite imagery and forest characteristics we measure. By tracking changes over time for each pixel in a satellite image, we can monitor seasonality in vegetation. This provides information about the amount of live vegetation, timing of bud break and leaf fall, and length of the growing season. From this, we can infer the presence of different types of forest, composition of tree species, and overall forest structure. One of the techniques used for analyzing these time series is harmonic regression. It quantifies the shape of a profile as a Fourier series, allowing us to characterize not only the average vegetation condition, but also how those conditions change over the course of the year. These coefficients describing seasonal changes in vegetation, along with auxiliary data like climate and topography, are powerful features for modeling forests. Through ecological ordination techniques, these predictors can be combined with response data collected on forest inventory plots to order tree species along environmental gradients. The location of plots in this feature space can be used with the k-nearest neighbors algorithm, which works by assigning to every pixel a bucket of plots based on their proximity as measured in the feature space. The contents of each bucket represent a group of records stored in FIA's database from which we can make pixel-level predictions, quantify uncertainty, and map a variety of forest attributes. This multispectral image combines three variables: stocking, age, and height. The pink in the southeastern U.S. shows the moderate height and stocking levels of the young forests of the nation's wood basket. Our plans for the future include analyzing snapshots from the past, using both imagery and plot measurements from earlier time periods to map changes over time, such as this map showing losses in forest carbon between 2005 and 2015 in Wisconsin due to major disturbances like wildfires and tornadoes. Next, Chris will show you how these services are being used today and how you can access them yourself.
BigMap is our end-to-end solution to integrate the latest in ArcGIS system, multiple programming languages, and state-of-the-art statistical tools to create information products for a wide spectrum of users. We are excited to share with you our vision of using these services today and in the future. Droughts are having huge impacts on forests and woodlands, and agency scientists are already using BigMap results, like this forest type group, to make drought model projections available widely. Examining drought exposure from recent years. The area in brown around the Central Valley in California shows significant droughts during this time. Projecting forward to 2040, drought exposure shifts from Central California to the Southern Rockies. Let's take a look at how you might use our new authoritative content for a different problem. Recently, we were asked to help identify landscapes that represented opportunities for planting and increasing sequestration of carbon in trees. And to do that, let's take advantage of our FIA stocking percentage layer, which can be viewed as representing where additional capacity might be located. And let's focus on the Pacific Northwest. And add data to a suitability model, FIA stocking and site class productivity, wildfire hazard potential from our Missoula Fire Lab, and pest and pathogen threats from our Forest Health Protection Program. We are looking for areas where planting opportunities exist without significant threats. The results, highlighted in purples, are areas where threats are low, productivity is high, and forests are not fully stocked. Now, this demonstration suggests a lot of opportunities might exist in Western Oregon and Western Washington. These could be important areas to realize shared stewardship, to implement climate mitigation, or restoration plans. And that was 2 examples of how you might consume these services in your own analyses using notebooks, geoprocessing tools, raster functions, and more. Today, we are excited to announce the release of our new hub, the FIA Geospatial Showcase, hosting all of the content we have shown today and more. Our hub represents a meeting place where we're sharing our best science and data in order to facilitate collaboration and empower your efforts to create a sustainable future. We will regularly add new content eventually publishing other information products derived from our database. With consistent science-based information from FIA,
Well, first started with engaging citizens and cities. It's all about organizing initiatives and then organizing the teams and organizing their activities. But this is now, especially in the last year, expanded to organizing professional relationships between users of different types. This technology and the organizational strength of the people behind it is fostering many new types of geo-collaboration. And I love that concept because it's essential to make the concepts of geospatial infrastructure work. I'll summarize what I've been talking about. Our world is being challenged on many fronts, and we will increasingly need to be responsible for its future. Part of this presentation is about getting us even conscious about it among ourselves. The geographic approach and geospatial infrastructure, this rapidly expanding new pattern, is going to provide us with the science and also the practical means, the essential means to be able to make this work. But they're not going to be enough. You and your work are going to be essential, providing leadership in your own organization, carrying out problem solving, the kind of things you already do, but thinking larger, thinking holistically. My place in my organization, my organization's place in the world, promoting our best tools and methods and thinking, being able to communicate clearly and effectively, and most of all, collaborating with other kinds of organizations, exchanging ideas, which I really wish we could be doing here together physically. This informal communication is so very important. Also, for me personally, I feel like I'm all in. I'm going all in. And I really want to encourage you to go all in. Act with urgency. These are the times where we really have to get it together and move at many different scales. I'd next like to move on in my presentation to talk about our work, the work that we do to support your work. And that's exactly how we see it. ArcGIS is our essential technology that we continue to evolve. And I'll go deep into what we're doing and have been doing in the last year in that environment. The vision of ArcGIS is to create a complete, comprehensive geospatial platform that supports multiple communities. The GIS community, of course, but also the mapping and location analytics communities, and also support geo-enabled systems, which are specialized technologies for specialized workflows. We do this in an open and developer-friendly environment with SaaS and software, and most recently, platform as a service. I'll talk more about that in just a moment. ArcGIS supports three fundamental types of systems, but they're all integrated into one technology. Systems of record for transactional data management, systems of analytics for creating insights into how geography is interconnected and works, systems of engagement through apps and maps that connect populations to the organization's work, communicate, and so on. ArcGIS is an integrated system. It brings many components together and works actually and has been engineered to work as a single system, supporting many kinds of applications and people. It, as a technology, is what is enabling and fueling this geospatial infrastructure pattern. ArcGIS users are increasingly leveraging the cloud. They're extending their system and strengthening their capabilities by deploying in clouds like the ArcGIS Enterprise, but also leveraging SaaS resources from the cloud like content or analytics in the cloud, or I'll be talking about a number of these things in a few minutes. Our pattern here is ArcGIS Online. The ArcGIS platform is open and it's interoperable. We support and leverage multiple initiatives to make this happen, supporting, of course, all the good work done by the standards organizations, OGC and others. We also have architected the system to be an open architecture with open APIs and open data so that it can help our user a broader frame of other IT systems. We have been working during the last year on enhancing capabilities. They're advancing. Over the next few minutes, I'm going to be sharing a bit about each of these different activities that we're working on. But these are just kind of a preview for what's going to be shown in the next couple of days in various workshops. Lots of new innovations, specialized applications in many frames. I'll start this presentation by updating you on ArcGIS's content. ArcGIS content is integrated in part of the fundamental system, and it's really ready-to-use content. Thousands of layers that cover the Earth and also are curated by us from public sources made available so that they are literally, again, GIS ready. Look at the list on the right. These are some of the new initiatives to be able to take the NGDA data sets from the US federal government, sometimes called A16, and make them openly available for download and services for your application. And it just goes on. But one of the big ones I want you to notice, the new content that we created in the last year, which is a land cover map for the entire planet. These data sets are for global applications, certainly, but also they are of the nature of being very detailed in many geographies that can be applied for your work. Let me go on to this global land cover 2020 data set. This is high resolution imagery, the Sentinel imagery from the European satellite, which has been classified into basic land cover. And this is open data now available to all of you as services or downloads. And we built this in collaboration over the last several years with the National Geographic Society and Impact Observatory, and also Microsoft Corporation and their planetary computer. Powerful, exciting. Well, let me go on to desktop mapping and cartography. Here, we've been making improved tools and improvements to our tools to support advanced workflows in the desktop environment of ArcGIS Pro. We've added new things. We've certainly achieved parity with the ArcMap technology of the previous era, but also we have advanced new things, introduced new kinds of cartographic tools for advancing cartographic science. And there'll be lots of sessions on cartography here at the conference in the next few days. In the field of interactive web mapping, we have also made a lot of new improvements. The first word that I chose here is fast, because the performance of being able to do interactive mapping has, again, dramatically increased. And that's enabled things like data-driven exploration of maps. Look at the upper left. See, I'm moving back and forth this little chart, and we're seeing all of the counties in the United States visualized dynamically as we explore the information. That's a new pattern for maps. It's the idea that mapping is an interactive environment. Some of the improvements are that we introduced a new map viewer for both ArcGIS Online and the enterprise technology. And you can look through the list, you can find your favorite things. Mine happens to be sketching, the ability to sketch on top of a web map and then share it with my colleagues. Instant apps are a brand new thing that were introduced this year. They allow us to quickly transform any web map, 2D or 3D map, into an app. And we support about a dozen of these apps. You can just take your map, associate it with this app, and boom, you've got an app to go. And there's many more coming. For some of you, you'll remember the word configurable apps. This is kind of the next gigantic step forward of configurable apps. You can build these independently, but you can also create them right inside of the map viewer. For many of you, dashboards are almost an essential element now. I see them in almost every agency that I go to because they provide dynamic, real-time visualization about any subject. Well, for every subject, dashboards have meaning and have been embraced by our users to be able to provide at-a-glance information. We continue working, and what's coming is a new table visualization and the ability to have dashboards natively implemented on your mobile device. That means that people can look at their little favorite dashboards anywhere, anytime, and on any device. Story maps are, again, one of these enormously popular applications. They're opening up geographic storytelling for all of us. Everybody has a story, and they're telling it like crazy with story maps. Millions of these have been published, thousands of new ones introduced every day. My good friend Jim Fallows calls this geojournalism, the ability to author a story and make it available dramatically, dynamically, digitally, covering a lot of populations. The innovations here have been better, simple drawing tools and the ability to collect multiple story maps together into collections, so I can publish like a story book for a particular community. These are getting easier, and the story map role last year opened up story map telling in a very affordable way to entire enterprises, and we're going to continue on that journey of making this more available and easier to use by everyone. Embedded mapping is an idea that I talked about earlier, the idea of embedding our mapping and our tools inside of other organizations' apps. And this is about embedding ArcMaps into other products, like all the Microsoft 365 products or the Autodesk tools for engineers, or into the Adobe products, or into Salesforce and Amazon and SaaS and IBM and others. My sense is that this is going to be continuing to expand your reach, the reach of GIS, bringing easy map making inside of other technologies. Well, I think that has the potential of really making transformational impacts. Our work in interactive visual analytics is largely organized in a product we call ArcGIS Insights. And this is a very easy to learn tool that works in both web and desktop environments. It allows people to access lots of different data around their organization and engineer access, and then explore the data visually, spatially, and then do analytics and interactive reporting on that data set. Very popular set of tools that are rapidly expanding. Speaking about spatial analytics, for many of you, it's the heart and soul of what you do. It's all about solving problems and advancing science in multiple ways. This year, we've introduced 90 new tools and algorithms. They're shown partly in this visual display. New tools for AI and machine learning and big data analytics, scripting, data engineering, and so on. Again, I invite you to the workshops because very powerful things have been introduced that will change the fundamental methods of certain sorts of workflows dramatically. I'm particularly fond of the AI and machine learning and deep learning activities that are going on. At Esri, we're beginning to call this GeoAI, and we have very consciously engineered these capabilities directly inside of all of the different parts of the system, into Pro, into Enterprise, into Online, so you can accomplish multiple things within the technologies that you know and work with every day. But we've also integrated this platform technology with open science ecosystem of dozens of other technologies that are also traveling along in the world of GeoAI. These tools are being used rapidly by our users to automate what they're doing and also just approach their problem solving smarter. Look at the examples in the upper right. I'll just call out one because I love it, which is the ability to do feature extraction off of imagery, creating actual feature layers and change layers automatically. Now, imagery and remote sensing, as I mentioned earlier, is becoming very important in the GIS community. And we have implemented a complete library of technology, in fact, a complete system, an integrated system for doing these 4 major activities: the management of imagery and its dissemination, the ability to make maps automatically, the ability to visualize and explore information, and also the ability to do analytics. And these little blue lists are just a few of the hundreds of capabilities that actually exist for doing it. But that's some of the work that we've done in the last year. Of this list, my favorite is the idea that we can actually load our imagery up into ArcGIS Online now and host it in a SaaS environment. Now, I'd like to talk about this in a little more detail. Image hosting and analysis in the cloud. This means as an extension to ArcGIS Online, I can actually upload my own imagery into ArcGIS Online. I can do raster analytics in ArcGIS Online or image processing in ArcGIS Online. And I can serve it out as image services, visualization services, integratable directly into the other work that I'm doing. This enables not only a handful of images to be processed in this way, but also massive scalability, like we saw with the Forest Service a few minutes ago. Imagery for ArcGIS Online is best if you seen if you actually see it. So Yoon and Kate are going to give a series of demonstrations that will help you understand in a simple way how powerful this will be for you.
Today, I'd like to share with you an exciting new product, ArcGIS Image for ArcGIS Online. This new offering allows users to host, manage, visualize, analyze, share, and collaborate imagery content all within ArcGIS Online as a software as a service. To demonstrate this, we'll explore the country of Grenada, located in the West Indies in the Caribbean Sea. Grenada is currently working on updating its GIS with new content, such as aerial imagery, elevation layers, and LiDAR data. Using ArcGIS Image for ArcGIS Online, now we can easily identify this quarry next to the stadium. Let's switch back to natural color. Now that we have our imagery data hosted in the cloud, we can perform additional feature extraction to build our foundational data layers. Digitizing features like this used to be a tedious task that took long hours of manual labor. Now we can expedite and automate this process by leveraging deep learning. ArcGIS Image for ArcGIS Online comes with a collection of raster analysis tools, which includes object detection. From this tool, we can use either a tiled or dynamic imagery layer as our input and select the model. Training and curating a model can be a challenging task, especially if you've never done it before. The Living Atlas provides a library of deep learning models that work seamlessly within ArcGIS Online. You can access these models that vary from extracting features like building footprints, classifying land cover, and many more. With the building footprint extraction model selected, we can now run the tool and get our results for the entire island. Here are the results from some of the deep learning packages done in less than a day. 55,000 building footprints, roads across the island, and a complete land cover classification layer. These are just some of the capabilities available in ArcGIS Image for ArcGIS Online. To take a deeper dive with more advanced raster analytics, I'd like to hand it over to my colleague, Kate Hess.
Now that Yoon has created foundational GIS layers for the country and hosted them in the cloud, I can easily access the data remotely. I'll tackle our next challenge using the power of raster analytics in ArcGIS Online. Grenada has rugged topography and faces frequent tropical storms. As a result, they regularly experience landslides, which can damage homes and businesses, disrupt transportation, and even lead to injuries and death. Let's identify infrastructure that may be at risk by using a process model to proactively locate areas susceptible to landslides. We'll perform this analysis using tiled imagery layers hosted in ArcGIS Online, including our land cover classified from imagery, the digital terrain model, the soil types, and the distance to river features. We're going to calculate landslide susceptibility from these layers using raster functions, all within the map viewer in ArcGIS Online. The Analysis tab gives me access to the raster function editor, which we'll use to create our image analysis process model. Here, I have access to more than 150 raster functions out of the box, including mathematical operators, geometric functions, and radiometric functions. These can be chained together to create new raster function templates for more complex operations, like my landslide susceptibility workflow. This processing chain takes in the 4 layers in our map and normalizes them to a common value range, then takes a weighted sum to identify the areas susceptible to landslides. Let's zoom in to evaluate a preview of our results. Previewing the analysis before running the model allows us to gauge if the result looks reasonable, or if we need to make adjustments to our input variables or to the weighting in our raster function. In the preview, we can see in red the areas at high risk, and the areas least likely to see a landslide are in dark green. When we're happy with our model, we can run our final analysis to get a persisted product. This analysis in ArcGIS Online takes only 1 minute and 30 seconds, so let's jump ahead to the output. Now we can see the areas with high susceptibility to landslides for the entire island. Let's bring this output layer into a 3D scene so we can visually explore the relationship between landslide risk and elevation. In 3D, I can clearly see how slope steepness relates to landslide susceptibility. Let's get a better understanding of what infrastructure may be at risk by bringing in the building footprints and roads that Yoon extracted from imagery. These layers are easily accessible to us since they're hosted in our organization in ArcGIS Online. In 2D, we can clearly see that this building falls within a high-risk area. But now in 3D, my attention is also drawn to this road, which falls within an orange area, but would be impassable if there were any significant landslide above it on the hillside. This is just the beginning of what we can do with hosted imagery layers and deep learning models in ArcGIS Image for ArcGIS Online. All of this was created in the cloud, so we didn't need to set up any infrastructure to run our analysis. We can also use point cloud data and ArcGIS Pro to bring our buildings into 3D. This gives us additional context for the building on the slope, as we can now see its height and shape, and how much of the structure is built on the hillside. With the additional capabilities of ArcGIS, we can continue to build out our countrywide database and foundational GIS, including bringing in LiDAR data to see our vegetation and power lines. We now have a 3D base map for the entire country. As a result, we have a building inventory for census planning. With the additional data layers, we can have an approach to natural disaster response that is more data-driven. And urban development, like here in St. George, can be intentionally planned and sustainable. All these capabilities, hosting imagery, deep learning models to extract features, and sophisticated raster analytics, are now available in the cloud.
Thanks very much, Kate, and also thank you, Yoon, for introducing this very powerful technology. And I think you can now see why I'm so excited about being able to put imagery in the cloud and allow these massively scalable capabilities be put in the hands of virtually every user. Drone mapping is another dimension of what we are doing with imagery. We support two fundamental technologies: site scan, which is cloud processing, and drone to map, which is desktop technology for planning and managing and collecting imagery and then processing it. This is what we are beginning to call reality capture. It is a mission that results in things like point clouds or DSMs or multispectral thermal emissions, lots of data sets that are directly usable by our users. For some users, they wish to do this at scale. So we introduced late last year a new technology called SURE for ArcGIS. This is about reality capture in an automated, like a factory, the capturing of this data, the processing of this data, and the ability to create 3D data products and maps. This is very, very attractive to large mapping agencies or to aerial survey companies who wish to automate and transform how they do digital photogrammetry. I'd like to show you how this works. You can see the textured meshes on the right in the city of Boston. It can now be integrated and enrich 3D systems of record, like the 3D buildings that's shown on the left. Many of you have these 3D systems of record that you're updating feature by feature. But by being able to integrate the two together, I can create really a marvelous 3D visualization experience. This is an example in Frankfurt, Germany, where an aerial photography mission was processed simply in a few hours to create this beautiful pictorial description of the city. And I can interact with this, of course. It's a beautiful visualization. But what you don't know is behind those, let's call them 3D pictures, are the actual 3D features. So I can interact with the features. I can color them. I can color the mesh. Like in this case with zoning. Well, the little video here speaks for itself. You get the idea. I see a new generation of 3D GIS as a result of these meshes being captured and being able to be integrated into our 3D systems. Our work in 3D visualization and analysis is fundamentally advancing GIS. It's not just about meshes, but also we've been working on the integration of game engine technologies to support immersive experiences. We continue working on tools for doing 3D web editing, both of meshes, but also of individual features. We've done extensive work in the integration of BIM models. We started in a great partnership with Autodesk Corporation, and we've extended this technology to include open BIM models or IFC integration. And we're also working actively on the ability to integrate these 3D BIM models right into our feature databases as a long transaction, and lots of other things, like being able to interactively do view sheds or cross sections or elevation profiles of various types. I'd like to share with you particularly the next chapter in our GIS and BIM integration. We're doing this closely with Autodesk Corporation, linking our systems with their systems and workflows. Now, ArcGIS GeoBIM, a new product which will come out in the fall, is able to dynamically link ArcGIS features to documents within the Autodesk Construction Cloud and BIM 360 environment. That means I can point at a feature in a 2D or 3D scene and automatically bring up next to it, dynamically bring up the document. And we have engineered this in such a way that this dynamic relationship can be the platform for creating a whole new class of apps. This will enable new kinds of collaboration, bringing the engineering and construction community closer with the GIS community and vice versa. Our 3D capabilities in ArcGIS are integrated across the entire ArcGIS system, and they enrich all types of experiences in the desktop, in the mobile environment, and also on the web. These experiences are part of a larger system, a complete 3D GIS system of record, a kind of living digital twin. Another dimension of our work is integrating real-time visualization and analytics into a GIS. This is about integrating sensors, the IoT, directly into the GIS, and we have two solutions to do that. The one is the Geo Event Server, which is an extension to the actual enterprise software. The other one is a new capability called Velocity, which allows these kinds of functions to occur inside of the ArcGIS online cloud. This is all about ingesting real-time data and visualizing it and analyzing it and bringing it right into dynamic applications of all types. For many of you, data management and editing is the center focus of your work. And here, our activities include continuing our support for all the leading data management technologies in the cloud and on premises, but also reaching forward into the future. We're integrating ArcGIS with these cloud data warehouses to enrich and do big data kinds of operations. We're continuing our support to advance industry data models, services-based models like parcels and utility networks and so on. And we've also made improvements in the geodatabase and performance and a variety of other things. Finally, we continue to work on improving our editing tools, new QA/QC tools, new integration of 3D features and meshes that I talked about earlier. And moreover, just this steady march of improving performance and scalability and usability all around. In the field, ArcGIS supports a series of field apps for both operations and data collection. The biggest innovation that we introduced last year was the ArcGIS Field Maps app. This actually brought together many individual apps' capabilities for collecting data, updating data in the field, tracking where you are, and being able to access services-based visualization tools. It also introduced the ability to do markups on top of maps and share them. ArcGIS supports a series of specialized data collection tools like Survey 123 and Quick Data Capture. And also, it locationally enables other aspects of field work like with Tracker and Navigator and Workforce. All of these come together around the system to be able to provide operational awareness for people in the office who are tracking their people in the field. App builders are making it easy for our users to build their own apps. This is an environment where there's no code or low code app development. You simply take widgets and build web apps with the web app builder, which has resulted in millions of apps being built, and also the experience builder, which is the next generation of the web app builder, which is more optimized for mobile environments and also has better mapping. For those users who wish to build native mobile apps, we also have a technology known as the App Studio that allows you to build fantastic iOS or Android or Windows environments. And all of these app builders are available to all of our users. The result has been kind of an explosion of custom apps all over the world. ArcGIS supports strong developer capabilities. These are APIs and SDKs for automating and extending ArcGIS on one hand, but also creating whole new apps. Things like the Python API are useful for being able to build scripts and notebooks for automating work. Tools like the Pro add-ins with the Pro SDK and Enterprise SDK allows us to extend basically functionality. In the area of creating apps, our runtime SDKs allow users to create device-specific apps. And you'll see later today the ability to embed these runtime SDKs inside of game engines, which open up a whole interesting world of gaming as it relates to GIS information. Or perhaps our most popular API is the JavaScript API, and this has resulted in millions of web apps. Earlier this year, we introduced a new library of tools, open source APIs like Open Layers, Leaflet, and more. I'd like to take just a moment about the JavaScript mapping API, which is really continuing to advance at a very fast rate. Faster performance, data-driven visualization, new tools and widgets and workflows, more 3D capabilities, and especially client-side analytics that you saw in a few examples I shared a few moments ago. ArcGIS Platform is a brand new technology we released earlier this year. This is about developer-focused mapping and location services, and it's still delivered as PaaS. It's delivered in a consumption-based business model, which supports non-GIS developers and also the embedding of location services capabilities from the cloud into enterprise systems. Ladies and gentlemen, we're going to take a few minutes break, enjoy a mind rest with music and visualizations by Kevin Eubanks. Many of you know Kevin because he comes to our users conference regularly. He's a world-famous jazz musician, but he loves geography and he loves nature. And well, I love him. He's just an amazing man. This will be followed by a series of capability demonstrations hosted by Madeline that'll take you through feature function demonstrations of the great capabilities that I talked about in the last few minutes. Kevin?
I hope you all enjoyed the inspirational music from Kevin Eubanks and the stunning nature visuals. I'm Madeline Shoren from Esri's Geo Experience Center. Next, we want to continue to share how GIS is creating a more sustainable future as we highlight a series of presentations that illustrate new and innovative approaches and capabilities of the ArcGIS system. Let's visit southwestern Colorado and the beautiful Telluride ski resort. To manage their complex operations, the team at Telluride uses ArcGIS Online's cloud capabilities to build a digital twin of their mountain. So let's hear from Brandon Green, the Director of Snowmaking and Capital, and Matt Tarkington, GIS Analyst and Drone Operator.
Welcome to the Telluride Ski Resort. This is our office. Today we're excited to give you an inside look on how we use Cloud GIS to manage our mountain every day. So here in Telluride, our mountain ops teams collectively manage roughly 2,500 acres of terrain on both private and Forest Service lands. In the summer, this includes golf, hiking, biking, and zip lines, but in the winter, we're best known for our incredible world-class skiing. Our number one goal is to always deliver the best guest experience, while at the same time, never sacrificing safety, maximizing efficiency, and being good stewards of our land. Our typical winter ski season runs from Thanksgiving to Easter, but our operations to support that window of opportunity are year-round. What most visitors to Telluride don't ever see are the people, time, and assets that go into making skiing on these mountains a reality. If we do it right, most people never see or even think about what's hidden below the snowpack, inside the pump houses and motor rooms, or what's happening out on the mountain after dark. GIS helps us track, maintain, and organize our assets, then visualize and leverage that information into our everyday logistics and long-term planning.
Our small GIS team here in Telluride are providing a cloud-based geospatial infrastructure, or digital twin, that enables on-mountain staff, dispatchers, managers, and execs to have access to the same real-time information they need to make rapid, informed decisions. For example, our snowmaking crews use field maps and dashboards to keep track of snowmaking infrastructure and share information in real time. Ski Patrol uses surveys and dashboards to report on avalanches, manage explosives inventory, investigate accidents, and monitor weather patterns. Dispatch utilizes dashboards to supervise open and closed terrain and get an overall view of our mountain operations. I'm most excited about taking real-time data from all of our sensors and disparate systems and make them readily available in a suite of common applications. Really, we are one big 24/7 operation. Most staff work their entire shift out on the mountain. Easy access from the cloud to mobile devices is essential for the success of our mountain operations. Complex terrain and elevation are major factors in everything we do. The amount of energy it takes to move equipment up, down, and across the mountain drives our economics and our decision-making. Over the last year, we've expanded our drone collection and mapping efforts, creating maps and scenes that help us understand and convey every detail of the mountain.
But our biggest challenge, by far, is snow. Getting a snowpack to the proper depth, width, and location is something we just cannot schedule with Mother Nature. So we continuously innovate when it comes to snowmaking and integrating real-time GIS to provide the best possible skiable surface to our guests every day, every season, year after year. And it's our digital twin that helps us do that. We can now look to the future and plan our long-term sustainability so that we use the least amount of natural resources moving forward. Now, while Matt and I would like to share more with you on how we're preparing for this winter season by integrating real-time GIS, advancing our drone operations, and improving our snowmaking, we're going to have to let our friends at Esri do that because we have to check in on the progress of our latest automation project. So the next time you're thinking of heading up to the mountains, remember, you're always welcome here at the office.
Thanks, Brendan and Matt. A small team leverage a Cloud GIS implementation pattern, and a fast-moving mobile workforce is enabled. This story really illustrates the value of real-time information for rapid decision-making. So let's fast forward to the winter ski season, where Suzanne Foss, the ArcGIS Velocity product manager, will share how Telluride is advancing the real-time capabilities for fast decision-making and improved safety.
I'm really excited to show you all some of the ways we're collaborating to bring real-time geospatial awareness to operations at Telluride for the upcoming winter season. What we're looking at here is a dashboard with the kinds of real-time information that come from Telluride's operational systems. There's a wide range of equipment, assets, and staff that support commercial operations and resources management at this massive facility. For example, the chairlift system reports information on dozens of kinds of telemetry. And it's important for the team to understand immediately if there's been a fault in the system, because most faults cause the chairlift to stop moving. Understanding the type of fault and getting that information to the right mechanic as soon as possible is essential to get visitors moving again. The team also monitors information from the water pump system that supports snowmaking operations. The water pump houses provide information on flow, pressure, and allows the team to understand how much water is getting to the snow guns. Telluride has close to 400 snow guns, and understanding if they're online and running as expected is critical for optimizing field maintenance and reducing costs. Now, in addition to all these mechanical assets, Telluride is also working on enabling the tracking of key personnel. Most staff out on the mountain carry a radio that reports their location every few seconds. And going forward, Telluride is looking to map this radio data and begin to track certain types of personnel, like ski school instructors, ski patrol, and maintenance crews. And staff on fleet vehicles are also equipped with GPS units. This includes vehicles like snowmobiles and snowcats. We're currently working with Telluride to bring all these different data streams into a comprehensive, dynamic view of their facility, using the SaaS-based, real-time capabilities of ArcGIS Velocity. Real-time data from operational and asset tracking systems can be ingested with ArcGIS Velocity using feeds. Feeds enable you to connect ArcGIS directly to IoT systems, like cloud platforms, web and messaging brokers, and data providers. Creating a feed is easy. You choose the type of connector, connect to your data stream, and configure your data model. Feeds are continuous cloud-hosted service that ingests data and light up your maps with streaming information. And we're working with Telluride to implement feeds for all these different data streams that they want to monitor. Real-time data ingestion and visualization is an important part of geospatial infrastructure and for Telluride's vision of a digital twin of their mountain. But situational awareness goes far beyond just looking at a live map. The team also wants to identify incidents automatically and drive alerts to the people that need to know. For example, they want to ensure a safe working environment for staff that are out doing different jobs on the mountain, who are often in different vehicles. Staff in snowcats that are out grooming snow on the slopes often have limited visibility due to terrain, weather, and the fact that they often work at night. So they may not always be aware of who's close by, like staff on snowmobiles that can be moving very quickly. What the team wants to do is identify incidents when snowcat operators and staff on snowmobiles are too close to each other. And what's even more powerful about these streaming data feeds is that they can be leveraged in real-time analytics to perform geofencing, incident detection, and drive alerts. This real-time analytic takes the feeds of both the snowmobiles and the snowcats and geofences them against each other to identify locations where they're within a given proximity. Dynamic geofencing like this is a new beta capability in ArcGIS Velocity's latest release, allowing you to perform spatial enrichment, joins, and distance calculations between two streaming data feeds in real time. So let's see how this dynamic geofencing is applied in this use case. First, for each snowmobile position that comes in, the point is enriched with a grid cell from an overall hexagon grid surface across all traversable areas of the mountain. This is over 120,000 polygons, representing areas that are trails or non-forested locations. And for each of these individual grid cells, the area within 250 feet was also pre-generated. This represents the area that a snowmobile could actually reach from any given location. And this traversable area analysis was done because a simple distance calculation between two assets can report that they're close to each other, even if they're actually separated by a barrier. Like in this case, these two assets are separated by a tree line. So in the real-time analytic, each snowmobile position is first enriched with and then transformed into its traversable area, which are the areas shown here in orange. These are then used as a dynamic geofence against the position of the snowcats. If any snowcat is found to be in the traversable area of any snowmobile, an incident link is created, and an alert can be sent to both operators, giving them a heads up to slow down and look out for each other. In order to run an efficient and world-class facility, Telluride has to manage a wide range of assets and equipment and ensure a safe environment for field operations. With the SaaS-based feeds and analytics in ArcGIS, data from disparate systems can be seamlessly integrated into your geospatial infrastructure and provide real-time insights that operators have never had before.
Thanks, Suzanne. Implementation of ArcGIS Velocity, integration with sensors, snowmaking equipment, and personnel tracking, that's GIS expanding out into the many dimensions of their business. But let's fast forward through time again, switching to drones, to see the benefits that Telluride is achieving using SiteScan for ArcGIS as they fly over the steep terrain above town.
Hi, I'm Jeremiah Johnson, an imagery solutions architect here at Esri. And I'd like to talk about SiteScan for ArcGIS, our end-to-end drone solution, and how Telluride Ski Resort is using drones and some of the features that we've been working on over the past year. Telluride's drones are valuable tools for inspecting and modeling the mountain where it's difficult or impossible to reach due to the elevation changes and terrain that Telluride is known for. When building a digital twin of such a complex terrain, it is important to pre-plan the flights before going out into the field. These polygons represent sections of the mountain that were pre-planned based on the elevation, flight time, and line of sight requirements of the drone. This map is saved in ArcGIS Online, which means it's accessible in the field for drone operators using the Field Maps app on their mobile device. The flight crew can also use the Field Maps app to navigate to the designated drone takeoff locations on the mountain. What's great is that this map is also available in the SiteScan flight planning app. Drone operators can verify the area they're supposed to map and view the flight in 3D to confirm altitude and line of sight compliance in the field. Using a 3D terrain service, SiteScan generates a terrain following algorithm that ensures that the drone maintains a constant altitude above ground. This not only maintains compliance with regulations, but also ensures that each image has a consistent resolution over the ground. This creates a better quality data set once processed. SiteScan has another new feature that's valuable for flight planning, Corridor Scan, a unique flight mode that makes it extremely simple to create efficient, automated flights over a corridor with a fixed width and multiple vertices. Creating a corridor flight plan is as easy as selecting a corridor width, then dragging new vertices over the proposed corridor. This corridor scan flight mode, combined with a terrain follow functionality, is perfect for mapping trails, roads, pipelines, power lines, or any other linear feature. Telluride accomplishes mapping the mountain using personnel with a fleet of drones that map the mountain section by section. Each flight is automatically uploaded to SiteScan and our brand new fleet management dashboard available to administrators. Inside of fleet management, administrators can view drone maintenance logs and registration, pilot currency, and all the flight history for the organization. As the flights are completed, the photos are uploaded to the SiteScan cloud for processing. The resulting orthomosaic is incredibly detailed. This is due to the high-resolution drone imagery. Each orthomosaic can be placed on a single map where it is put together like a jigsaw puzzle. A fundamental enhancement to the power of SiteScan is the incorporation of the Shore processing engine for high-quality, scalable reality capture. Now, in addition to the high-resolution orthomosaic digital surface models and point clouds, SiteScan creates a beautiful 3D mesh that can be analyzed directly within SiteScan or published to ArcGIS Pro, ArcGIS Online, or in an enterprise portal. This 3D scene of the mountain was created from nearly 100 drone flights and over 15,000 images to create a single 3D mesh that covers the entire ski area. Leveraging the scalable i3s format, the entire ski area can be brought in and the dataset performs well in the browser and on mobile devices. This is a complete, accurate digital twin of the mountain. Its resolution is high enough that one can zoom into the beautiful mountain village, view Telluride's famous gondola station, and its journey to St. Sophia Station, and fly to Palmyra Peak, the highest point of the ski area, where we can zoom in to the details of the rock face. These are just some of the exciting new features of SiteScan for ArcGIS. SiteScan enables a new level of reality capture workflow that allows users to digitize their environment and enhance their system of record using drone technology.
Thanks, Jeremiah. It's so interesting to see how Telluride is using drones, building their digital twin and using high-resolution orthomosaics and 3D meshes as the foundation. Reality capture extends what's possible with 3D GIS, and that's the perfect segue to the next presentation that I'm personally excited to share. There are many ways that reality capture can extend 3D GIS, providing comprehensive data sets to perform advanced analysis. At Telluride, one way they're using reality capture is to calculate snow volumes, modernizing workflows to save time and money. Telluride, like many ski resorts, uses snowmaking to supplement the natural snow, improving the reliability of snow cover. This is a 3D mesh of the Misty Maiden ski area near Mountain Village and the designated snowmaking areas. Snowmaking forces water and pressurized air through a snow gun, producing concentrated areas of snow to be redistributed. The goal is to have 2 feet of snowpack over the summer terrain. We worked with the team at Telluride to develop this custom application that calculates snow volume, so the snowmakers know where they are in the snowmaking process. The blue areas show where snow can be cut to fill in the red areas where more snow is needed. This analysis was conducted using 2 digital elevation models, one showing the winter output and the other showing the ideal snow surface of 2 feet snowpack. The analysis can be rerun, this time using a new surface that shows 4 feet snowpack. And now the red areas will require almost 6,000 cubic yards of snow to meet the 4-foot goal, which is available based on the calculation. By utilizing the drone imagery captured in the winter, the team at Telluride is able to ensure that snow is made in the right place at the right time with the right volume, maximizing efficiency and minimizing cost. But let's switch gears and leave Telluride, flying to the San Bernardino International Airport, where they're also flying drones at their new UAS center. This view is quite the opposite of the mountains of Telluride, showing critical infrastructure. Here we can see miles of concrete taxiways and runways that need to be evaluated regularly for safety. Historically, this has been done in person, requiring hundreds of hours of on-the-ground survey work. But today, we can apply drones and artificial intelligence algorithms to expedite this process. These tools use AI and deep learning to identify pavement failures, quickly examining the runways and taxiways for cracks. Here we can see the output of the deep learning model, which identified cracking in between the slabs that's built into the concrete. It also picked up on some early cracking, so the repair process can begin as soon as possible. By identifying these cracks in their early stages, using drone operations and AI tools, the cost of repair can be dramatically reduced and safety enhanced. Switching gears, let's travel to the Netherlands and look at another example of reality capture, this time exploring a new development in the town of Almere. This is a 3D mesh of the area, created from hundreds of images collected by Caval 10. At 3 centimeters resolution, we can see incredible detail, including the sand dunes that the development is built on. The detail is exciting, but it's made even more powerful by using underlying GIS attributes to make it completely interactive. Clicking in the scene, for example, identifies the roads and parking spaces in the 3D mesh. Or we can quickly identify individual characteristics of buildings in the scene. We can also start to add in additional layers for information for more enhanced visualization. For example, adding in a living atlas layer from the Netherlands that shows traffic signs, or a 3D polygon to illustrate flood risk for sea level rise of 2 meters. Integrated 3D GIS combines meshes and features to quickly build a visually immersive experience, so we can travel to places like Almere virtually. Our last example takes us to San Francisco, where Esri partner Voxel created a beautiful 3D mesh of the city. With 3D GIS, a snapshot of reality is at our fingertips, giving us the opportunity to explore entire cities from anywhere in the world. This mesh has been brought in to ArcGIS Urban, one of our geo-enabled systems, to provide context for urban planning. ArcGIS Urban streamlines the development review process by providing a shared view of activity across the city. Here we can see hundreds of projects that are currently active, overlaid on top of the mesh as a contextual base map. A major construction project that's currently underway is at 10 South Van Ness Avenue. Using ArcGIS Urban, we can visualize the proposed development in the context of the city and use spatial analysis tools to evaluate it. The latest release of ArcGIS Urban comes with a new shadow analysis tool, so we can quickly calculate shadow duration for anywhere in the city. Hovering over the analysis results, we can see the total time each individual area is in shadow. And as powerful as this visualization is, we can take it even further and get a view of the city from inside a new condo. This is now an immersive experience, creating an extended reality using the 3D mesh. Here, we can see the Transamerica Pyramid, and looking out the window, we can see Leavenworth Street. This is what reality looks like from inside a building that only exists in augmented reality. We can quickly swap out San Francisco for a 3D mesh of Denver, created by our partner Aerometrics. So we can imagine virtual cities all over the world. Whether you're a city planner, an architect, or even a movie studio, ArcGIS generated 3D meshes create immersive virtual experiences. We hope you've enjoyed this quick tour of reality capture, real-time analytics, drones, and cloud GIS. Thank you.
I'd like to now shift gears for a moment and talk about the fundamental ArcGIS products. These are the vessels within which all this capability gets realized. As most of you know, ArcGIS is an integrated series of components, servers, desktops, apps, solutions, and so on. And I'm going to go through them systematically, and then we'll see some demonstrations of what's happened. Let's start with ArcGIS Pro. ArcGIS Pro is all about advanced mapping, visualization, editing, and analytics. And we've again introduced a whole new series of capabilities. But we also listened to your requests and feedback from last year, which said, focus on performance, focus on quality, focus on usability. And we did that, but we also continued our march to add new capabilities, things like floor awareness or big data collections. And again, in the workshops, you'll see a lot of this material exposed. And there's yet again more coming. ArcGIS Pro has many extensions. These extensions extend the fundamental capability with rich analytics and tools for data management and tools for production, mapping, and charting. And again, there'll be specialized workshops on each of these. The second big technology of the family is the ArcGIS Enterprise. And this is about GIS infrastructure for your organization. It's all the tools for data management and mapping and analytics and collaboration of multiple types. This enterprise technology runs in public and private clouds, of course, and also for on-prem deployments. Lots of new things actually occurred here in the last year, some dramatically large advances, but I'll just hit on a couple. You've been asking for better distributed collaboration, like two-way synchronizations between different systems, updating a map in one system and having it send a little updatogram over to another one and automatically update, and many others. What's coming next is our support for enterprise in the cloud, and also the integration of our technology to these big data warehouses that I mentioned earlier in my talk. But I'd like to focus especially on a huge advancement which happened with this latest release, which is Kubernetes support. ArcGIS on Kubernetes is the implementation of ArcGIS in a cloud-native architecture. And for some of you, you'll be enormously interested in this when I tell you about it. Others will continue using Linux or Windows for the implementation. But cloud-native architecture means that we take a piece of software like Enterprise and we divide it up into a series of microservices. These are the little things that the software does. And you can deploy these on different computers within the overall cloud environment. This means I can really scale out the technology to deal with very large number of users or very high amounts of computation. This is not for everyone, but it is for organizations who are using Kubernetes and want to take advantage of this scalability. It's supported on AWS and on Azure, and also for users that use the IBM Red Hat OpenShift environment. The third capability or part of the ArcGIS system is the ArcGIS Online environment. And this is a massive global system for mapping and analytics, all in a SaaS environment. There are actually over 10 million users now that subscribe to this, and they're making millions and millions of data sets available for use by others. Trillions of maps actually get made out of this environment. And we're continuing to work hard on many fronts. I've already covered a lot of the new and improved capabilities in this system, like the new map viewer and charting and a bunch of others. Again, I invite you to the workshops here because you'll be able to be engaged and share what you're thinking about our work, and also share your feedback on our plans going forward. The ArcGIS Online environment has a number of extensions. One of my favorites I've already talked about is ArcGIS Hub. This is about supporting engagements with other citizens or with other organizations. Organization collaboration is supported with these tools. And I'll just underline this point that it's about organizing things. It's about organizing initiatives in an organization for collaboration or whatever. It's about organizing people, and it's also about organizing activities. Lots of neat workshops on this environment as well. ArcGIS solutions are a different kind of product. They lay on top of the other products. They're industry-specific maps and apps that are pre-configured. You simply download them and implement them into your systems, and you're ready to go for a whole new series of applications. They're extensive. They're transforming local governments quickly. We use this kind of pattern for the COVID response, where people were setting up dashboards very quickly. But in emergency response and utilities and so on, they're very easy now to deploy, and they're also completely supported just like our other software products. And the best part for many of you will be that they are free. They're freely disseminated, and they're helping organizations really realize huge value right away. We're now going to pause for a moment and see some amazing demonstrations of all these products that I've been talking about. That's going to be led by Madeline and Akita, showing the feature functions of how these capabilities are showing up in different products. So, Madeline?
Thanks, Jack. The latest release of ArcGIS Pro focuses on performance and productivity improvements, in addition to new capabilities. Let's take a quick tour of some of the new features in ArcGIS Pro, starting with cartography enhancements. This is Esri's world imagery from the Living Atlas that many of us use daily. Because imagery is typically gathered at midday to reduce shadows, the texture of the terrain is lost. But ArcGIS Pro now includes new cartographic enhancements and blending tools, so we can quickly blend this hillshade with the imagery to give it more definition, so now the terrain really shines through. Blending can be used with other features as well. This layer shows California fire perimeters spanning over 100 years, with many of the boundaries overlapping each other. With this new cartographic capability, the features can be blended to understand areas of high fire occurrence, amplifying color intensity as the features overlap. So the highest incident areas are visualized in this bright orange. And finally, an overlay mode can be used to bring these two layers together, combining the fire perimeter data with the underlying terrain to create one beautiful map. Another exciting new feature is the ability to change selection symbology. With many overlapping boundaries and polygons, the default outline symbol can make it difficult to interpret the selection. By updating the selection symbology to a hatched fill, the selection set is much easier to see. So far, we've seen some of the new visual enhancements in ArcGIS Pro. But let me show you an improvement to the overall user experience that'll really help boost your productivity: command search. Now you can find any tool or feature in ArcGIS Pro with this simple search at the top of the ribbon. For example, I can quickly find the Append tool so we can add 2020 fire data to our project. And here's another time saver. Now you can copy the Python command directly from the tool without even having to run it first. But let's switch gears and talk about a large fire that occurred outside of Yosemite National Park in 2013, the Rim Fire. One of the things that fire impacts most is land cover. So let's calculate the land cover change from the year before the fire to the year after using the new change detection wizard. The change detection wizard helps guide the workflow so we can conduct this analysis easily. Here we'll add in our land cover data and clip it to the fire boundary. And now we're ready to run the tool. The Rim Fire was a high-intensity fire that dramatically changed the landscape. Selecting the output of the tool, we can see that much of the area changed from evergreen forest to grassland and herbaceous land cover. To close out this section, let me show you two more updates to ArcGIS Pro, starting with symbology. Here we can see Yosemite National Park's trailheads and trail system data overlaid on top of the Rim Fire boundary, but the trailhead symbol colors don't quite match the rest of the map. ArcGIS Pro comes with a few updates to symbology. For example, we now have Pantone colors to ensure consistency while printing. But my favorite enhancement is the new eyedropper tool, which lets me interactively select any color from the map so we can quickly update our trailhead symbols. And finally, selecting anywhere in the rimfire boundary, new and improved pop-ups help us understand more about the fire itself. These pop-ups have the ability to split elements horizontally and vertically and use HTML for customization. They can also display 360-degree images, creating an immersive experience directly inside the ArcGIS Pro interface. This was a quick tour of some of the new visualization and productivity enhancements in ArcGIS Pro. Now I'm going to hand it over to my colleague Ankita to talk about and share another set of exciting capabilities called data engineering.
Thanks, Madeline. In ArcGIS Pro, we have added a new experience to help make your data analysis ready. This experience is called data engineering, and it will streamline your data preparation tasks by visualizing, exploring, cleaning, and transforming your data. Let me show you a few capabilities of the new data engineering view. This is the US county-level unemployment data for April of this year. I can right-click this layer and open the data engineering view. On the left, I see a list of all the fields this layer contains and their different data types. To dive deeper, I can select these fields, drag and drop them to the right, and click Calculate. We now see these powerful chart previews for each field and their summary statistics like minimum, maximum, standard deviation, all the way up to sophisticated statistics like skewness and kurtosis. These statistics help me understand the data. For example, the average unemployment rate is 4.9%. Over 9 million people are currently affected by unemployment. And the presence of outliers show me that some counties are suffering more than others. To visualize this data spatially, I will use the Update Symbology button. This button dynamically updates the map symbology for each field and helps me visualize spatial patterns. For example, we see stronger spatial patterns of unemployment rates in the western and southern parts of the country. I can also look at the predominant industry in each county. Another quick way to visualize your data is through charts. The Create Chart button automatically creates a bar chart for a categorical field like state name. I can select any state, for example, Nebraska, and click Calculate to see the unemployment statistics for just Nebraska. This visual and interactive interface helps me quickly understand my data, saving time and hundreds of clicks. Data engineering also includes a subset of geoprocessing tools to clean, construct, integrate, and format the data. Here are 3 examples. First, I want to show the Fill Missing Value tool. Here I have 14 counties with missing unemployment rates. I can right-click, select, and locate these missing values on the map. These are the independent cities in Virginia, and these missing values could be a result of upstream data processing. I can fix it using the Fill Missing Value tool. I'll fill in the tool parameters and run the tool. The tool estimates the missing unemployment rates using the values from the neighboring counties. And once completed, the new fields get added in the list with no missing values. The next 2 tools I'm going to show you will help you prepare your data for advanced analytics. For example, if I see a field that looks highly skewed, all I need to do is right-click and open the Transform Field tool. Here, I'm using a Box-Cox transformation, but there are many other transformation and inverse transformation methods available in the tool. And once completed, my data is now normally distributed, which is a requirement for many regression analyses. Next, I want to talk about dimension reduction. To train a machine learning model, we need more data, and with more data comes more complexity. For example, I have these 15 different age variables. I can select them and create a scatterplot matrix to find relationships between them. Here I see that some of my variables are highly correlated, which can impact modeling and prediction. I can fix it using the new dimension reduction tool. I'll reduce these 15 fields into fewer components whilst maintaining data variability. Using principal component analysis for dimension reduction is a very common data engineering step, and this is now built into the software. And without writing any code, I have reduced these 15 fields into 4 components that I can use to train my model. With the advancement in spatial analysis and machine learning, data engineering is more important now than ever before. And these are just a few examples of how this new data engineering view can help streamline data preparation and make it analysis ready. To close out our section, Madeline is going to show us what's new in ArcGIS Pro 3D editing.
Thanks, Ankita. Let's walk through some of the new 3D editing enhancements in ArcGIS Pro. This is a 3D mesh of the city of Munich. Captured in autumn, the beautiful colors of the changing leaves really pop out. 3D meshes are used throughout the ArcGIS system. So let's make some edits to this mesh to explore a proposed development of a new building. The first thing we want to do is grade the construction site to make room for the new development. Selecting the mesh layer, we'll add a mesh modification to replace an underlying 3D polygon. Now that the area is flat, we can add in a 3D model of the new development to explore in the context of the city. This is a 3D object feature layer that was created with Autodesk's Maya. With ArcGIS Pro, we can bring in a simple 3D model like this one, or a more detailed model like BIM. And while the building itself is a powerful visualization, let's add in some additional features like solar panels on the roof using the new Array tool. The Array tool quickly distributes additional features by adding in columns and rows that duplicate the original feature. So with just a few clicks, we've created our new solar panels. The last thing that we want to do is inspect underlying utilities so we can connect the proposed development to existing infrastructure. First, we'll expose what's below the surface so we can get a look at some of the underground utilities that are currently running through the street. And now we can add in a new fire hydrant and connect it to an existing water line. The new 3D grid feature helps guide our edits. And the vertical line capability lets us quickly illustrate how the fire hydrant will connect to the water main, simply snapping the edit into place. All of these enhancements and many more are available for you to use today in the latest release of ArcGIS Pro. We can't wait to see how you incorporate them into your daily work. Now I'm going to hand it over to my colleague Kenyon Wilker, who's going to show you what's new in ArcGIS Online.
Hi, I'm Kenyon Wilker, and today I'm excited to share updates to 4 areas in ArcGIS Online. ArcGIS Online is Esri's SaaS solution for organizations that need to create, share, and explore maps, data, and apps to help solve geospatial problems. Many of us begin our data discovery and exploration in web maps. And I'm excited to share that the next generation map viewer is now in general availability and can be set as your default viewer. Let's use it to explore some enhancements to web mapping. Blending is one of the most exciting capabilities in the new map viewer and across ArcGIS. It takes the capabilities of top-tier graphic design tools and makes them directly available as cartographic visualizations. Here, we have world hillshade with demographics data on top of it. Normally, we use transparency to show these layers together, losing some of our color in the process. But now, we can use the multiply blend mode to easily fuse topography into our map, while keeping the informative colors of our demographics data. We can also use blending to further engage our viewers by focusing our map. In this case, we have a population density raster that shows more precisely where people live. We can use the destination in blend mode to show only where our demographics data overlaps with our population density raster, deepening our understanding of these demographics. Performance enhancements in the map viewer enable us to easily symbolize and dynamically explore our data. Here, I've symbolized thousands of census tracts by the percentage of the population that are renting. Using the range slider, the map gives us feedback, enabling us to explore our data dynamically. Now, let's explore charting in the new map viewer. You can create a variety of charts, including histograms, bar charts, and scatter plots. I've created a scatter plot to continue to explore our renting data along with the millennial population in the US. Notice that the chart automatically picks up my map's colors. On the bottom right, we have several outline tracks. Selecting them on the chart also highlights them on the map. And zooming in on some, the map continuously updates my symbology, enabling me to continue to explore this data dynamically. Next, let's explore what's new with configurable applications. With the recent update to ArcGIS Online, you can now create applications directly from the new map viewer. Let's create an instant app. And we'll use the minimalist template. Instant apps are a type of configurable application that enable you to go from map to app in a consistent and quick manner. In the application's express setup, we'll start by verifying the map and title, selecting our widgets, previewing the application on a variety of screen sizes, before publishing the application. You can see that we've quickly created an application with an intuitive and engaging user experience, where we can continue to explore demographics across the US. Next, let's look at what's new in dashboards, a configurable application that enables you to monitor and explore your data. Here, we have a dashboard showing outages across the US national power grid with PENS data from our partner GridMetrics. The GridMetrics PENS data is monitoring the health of the US national grid by watching the telecommunications network to see when and where it loses power, like here outside of Houston, Texas. And since dashboards are built off the JavaScript 4.x API, we can interact with advanced functionality authored in the new map viewer, including dynamically filtering clusters like these power grid outages, along with their dynamic labels. Next, let's look at another recent enhancement in dashboards, support for Arcade. Within a dashboard, we can use Arcade to extend functionality, enabling us to automate additional feature-driven visualizations and calculate attributes on the fly. Selecting an outage in Wayne County, Michigan, I see the list informs me what time the outage started at, but I also want to understand what the current duration of the outage is. To do that, we'll go into our list and add an Arcade expression that calculates the duration of the outage by subtracting its start time from the current time. The expression also highlights recent large outages. Another recent enhancement to dashboards is keyword search and multiple filter reset. Searching for Wayne County, Michigan, the Arcade expression informs me of our recent outages, and I can see our new duration attribute in the list, letting me understand the current time that the power's been out. Selecting one of the new outages, we can even view critical infrastructure like assisted living facilities in its immediate vicinity. And finally, one of the premier capabilities of ArcGIS Online is access to the Living Atlas, with thousands of authoritative layers and applications. Some of the most recently updated or added features include updated base maps, like new localized languages and stylized base maps, updated multispectral imagery, including new Sentinel-2 releases for land cover classification, updated population demographics, including the most recent ACS statistics, and even ready-to-use deep learning packages, like this one for Sentinel-2 land cover classification. Let's explore another new data collection in the Living Atlas, the National Geospatial Data Asset Portfolio, also known as A16 layers. We've worked with the US federal government to make these available through a centralized set of resources. They're a collection of authoritative, ready-for-use datasets that include high-resolution imagery, critical infrastructure, congressional districts, and more, that are updated regularly and available for anyone to display, use, or download. Next, let's check out an exciting new enhancement to one of our most popular base maps, OpenStreetMap, which is often a great source of foundational information in many places around the world. And nowhere is this type of support more important than rural or isolated places, like this mining town in the outback of Western Australia, Kalgoorlie. Zooming in on the town center, we can see that only the main part of the town has been fully mapped on the classic OpenStreetMap. But now, Esri includes the daylight distribution as the default OpenStreetMap base map, enhancing the great work of the OSM community with the help of Microsoft's MS Building Footprint AI model for additional geographic validation and levels of detail. ArcGIS Online is constantly growing and evolving, adding new capabilities and information with every release. When we bring all these capabilities together, we can create insightful and engaging applications like this one that uses cartographic blending, data from the Living Atlas, and the JavaScript 4.x API to display US ship traffic over the past 3 years. This is just a piece of all the new capabilities in ArcGIS Online available to you now. And I encourage you to try out these features and more to explore your data and solve geospatial problems. And now, I'll turn it over to my colleagues, Philip Peedy and Mark Carlson, to share some exciting news about the next evolution of ArcGIS Enterprise.
Welcome to our Network Operations Center, where we can monitor the resources that power many of our ArcGIS Enterprise deployments. I'm Philip Peedy, and I'm the lead product manager for ArcGIS Enterprise.
And I'm Mark Carlson. I'm a system architect, and I often use system monitors like these to help maintain the health of large ArcGIS systems and verify that services are within their service level agreement.
We want to talk to you today about a game-changing new deployment option for ArcGIS Enterprise. Some of you will be ready and interested in this today, and for the rest of you, this is a heads up, because this technology is likely to be of interest to you as well in the years to come. We've been hearing from many of you that you're increasingly setting up larger and more complex deployments of ArcGIS Enterprise to power an expanded number of workflows within your organizations. As Mark alluded to, the systems are getting bigger and more challenging every year. So let me introduce you to ArcGIS Enterprise on Kubernetes. It's a new deployment option for ArcGIS Enterprise, in addition to our existing offerings on Windows and Linux. It's fully cloud native, with a microservices architecture that provides inherent high availability without any additional configuration. For those of you already comfortable with modern cloud patterns, it built upon the same IT standards that you use in the rest of your organization so that you can reuse that experience and knowledge. And it runs equally well both in the public cloud and in your own private cloud environments behind your firewall. Building upon the industry standard and open source Kubernetes framework, you get the benefit of a simplified deployment experience as well as dramatically simplified upgrades. So let's take a look at how this can be of benefit.
During last year's spike in wildfires, I was hosting this wildfire feature service, and the demand of the service exceeded what we were expecting. So I had to add multiple machines to respond to the increased demand. Let me show you how ArcGIS Enterprise on Kubernetes can expedite this type of work. Here is the new manager interface. From here, I can see an overview of the logs, data stores, and even the service pods. Now, a pod is a deployable object inside of Kubernetes that contains microservices. And we can also view services by selecting services on the left. Let's view my wildfire feature service by selecting on the hosted folder. And then let's select my feature service. From here, I can see the overview status and more. I can also see how many pods are running for my feature service. And when I need to modify the resources available, I simply click on the Settings tab to view and edit the resources that have been prescribed. And instead of having to add entire servers to distribute the increased load, I can simply increase the amount of CPU and memory. It's that easy to increase the resources available to a service. And I don't have to install any new software or do any other type of server configurations. And for our end users, ArcGIS Enterprise Portal looks and feels the same. We still have all the same tabs like Home, Gallery, Map, and others. So let's navigate to my content. Here I can see the items that I have published to ArcGIS Enterprise. And I can find my wildfire feature service that I published with ArcGIS Pro in my wildfire folder. And as you can see, it looks and feels the same. So let's have some fun with this feature service and see how well it scales when we place additional load on this service. For this service, I've created a Grafana dashboard that's a live view into my Kubernetes cluster. And it displays the network traffic, the number of pods available to my feature server, and the percentage of CPU usage. I have also configured ArcGIS Monitor to alert me when the response time of the service exceeds 1 second. And as we can see in the monitor dashboard, we are well below my threshold, and there are currently no alerts. So let's place some additional load on our feature service. And at first, the feature server is able to handle the requests, but then it starts to get overwhelmed, as seen in the increased CPU usage. And when the response time of the service exceeds 1 second per our service level agreement, ArcGIS Monitor will also alert me of this increased load, as seen in the monitor dashboard. So let's add some additional pods to our feature server directly from the Settings tab of ArcGIS Enterprise Manager. Now, we are manually increasing the pod limit to 4, and with a little bit of scripting, this could also very easily be automated. And looking back at my Grafana dashboard, we can watch the number of pods increase to the number we just set for our feature server. And as these pods come online, the load from my wildfire feature server will begin to be distributed among them. And we can verify that our response time is now less than 1 second by viewing the metrics in the monitor dashboard. Not only can I scale efficiently, I can also leverage the cloud-native patterns for deploying, updating, and upgrading ArcGIS Enterprise. ArcGIS Enterprise on Kubernetes works with modern DevOps patterns for deployments. The automated deployment and preset architecture profiles simplifies my work and makes my deployments reproducible. I can use the same script for the dev, stage, and production environments, saving me a lot of time. All I have to do is edit the properties file for both the deployment and configuration scripts to have a fully automated experience. And for updates and upgrades, simply navigate to the Update section of ArcGIS Enterprise Manager to view and apply the available updates and upgrades. Whether you're updating or upgrading, it's an automated process in Kubernetes.
So let's take a look at how these updates work behind the scenes. When updating or upgrading to a new version, we apply a number of techniques to reduce downtime and interruptions. And we do so smartly based on the type of microservice that's being updated within the system. One technique is the use of rolling updates, where we gradually roll in the new version as we roll out the old. This pattern is used for stateless parts of the system, where the old and the updated processes can coexist. This ensures a seamless update with no visible impact to end users, and the ability to validate that the update has succeeded before phasing out the old pods. The second technique uses what's known as a blue-green approach for upgrading, where the new and the updated microservice is created next to the existing one before then switching over to the new one with a virtual flip of the switch once it's ready. This is done for stateful parts of the system, where the old and the updated parts of the software shouldn't be running concurrently. Both of these techniques are used automatically by the update process as appropriate, and are entirely seamless to both administrators and end users. And the part that I like is that it minimizes any interruptions on my production machines and ensures confidence in the system for my users. To summarize, this is an exciting new deployment option that sits alongside ArcGIS Enterprise on Windows and Linux. ArcGIS Enterprise on Kubernetes provides you great new capabilities for designing, setting up, and maintaining highly available deployments with a minimum of administrative work. If you've already adopted a modern cloud strategy based on Kubernetes, this is designed for you. If you're not quite ready to take on Kubernetes and the change that it brings, don't worry. If you decide to go in this direction in the future, we'll be ready for you. Next, let's go out into the field and see what's new with ArcGIS field maps.
Hi, my name's Eric Wagner, and I'm a solution engineer on the water utilities team. Efficiency and accuracy are critical to effectively coordinating operations at utilities every day. To do this, you're probably using many of our current apps, like ArcGIS Quick Capture, Survey 123, and more to complete your work in the field. But you've asked us to combine many of these great apps into one. So in addition to those other apps you already use, I want to introduce Esri's newest mobile app, ArcGIS Field Maps. In its first release, it will combine the editing capabilities of Collector with the viewing and location tracking functions of Explorer and Tracker. Today I'm at a construction site doing some asset collection. Let's see how field maps can help me get my work done. Viewing and understanding the specific details about all of your utilities assets is critical to daily operations. For example, I can look up additional information about this valve at the end of the street. I can also take a look into its historic maintenance records as well, and in particular, see the work that was done last January. Field Maps also allows for the use of high accuracy GNSS receivers to collect newly installed assets, like this valve. With 2 taps, the location is recorded. Now information about the valve needs to be entered. Field Maps allows collected asset information to be placed into logical groups to simplify data entry. When combined with default values and drop-down lists, data collection is faster and easier. I'll set this valve type to gate and submit this feature. Snapping also ensures the proper placement of new features that I need to collect as well. I'll add a main segment to connect this newly collected valve to the other valve at the end of the street. Now I need to record some information about it. One of the exciting new features about field maps is the addition of smart forms. This functionality only shows fields that need to be completed for this new feature based on my inputs. Right now, I can only see general details, but when I set the main type to distribution main, an entire section with additional fields is now visible and already filled in with default values. Time is saved when I only see the appropriate fields as I collect data. Existing assets can be updated as well, and smart forms can make this process more accurate too. The yellow valve at the end of the street needs to have its status updated from open to closed due to construction in the area. I can tap on this valve, select it, and begin editing it to change its present status from open to close, and I'll see that a new notes field is now present to me. I can even fill this out using voice recognition software. Valve closed due to ongoing construction. And I'll submit these changes. The valve is now red for others to see that it's been closed, and the notes are there to explain to others why the status has been changed. I can also share information using markups. Notes can be added to the map for others to understand conditions on the job site. Due to active construction on the houses behind me, I can't GPS newly installed water laterals. So here, I'll add a markup to this location, and I'll add a note to it saying that construction is in progress and submit it. As you've seen, Field Maps allows data to be viewed and collected in the field, but it also lets users share their locations with managers throughout the day to improve coordination between field crews. I can turn on Tracker by tapping on the top of the screen and flipping the switch next to Track My Location. And if I want to see those tracks from throughout the day, I can turn this layer on in the map as well. ArcGIS Field Maps allowed me to more efficiently and accurately view, collect, and share data, all from one application. But what does it look like to coordinate an entire team of field workers? Let's go back into the office and take a look. No matter which apps you use out in the field, your crews and assets can be visualized in an ArcGIS dashboard. This increases coordination at organizations of any size through a common operating picture. Dashboards allow managers to make informed decisions with real-time data. Here, I can see information about my assets, field crews, and open work orders. Scrolling through my list, I can see we have a main break, which requires an immediate response. Since I know the locations of all of my field crews, I'm able to determine who's closest to this incident. And it's Jay, who's about a mile away, so I'll reach out to him first. And if additional support is needed, I see that I can reach out to Matt as well. As this situation unfolds, understanding all of my nearby assets, such as service connections or fire hydrants, begins to paint a valuable picture of what might be impacted when this leak is isolated. You don't get to choose when emergencies happen, but by having the right technology in the field and in the office allows you to respond with coordinated operations with time and efficiency. Now let's continue our journey and learn about the new features of ArcGIS Story Maps with Jennifer Bell and Ashley Dew.
Hi, I'm Jennifer Bell, and I'm the product manager for ArcGIS Story Maps. Today, we'll share some enhancements with Story Maps, both new and familiar. Organizations and authors like you are creating thousands of stories every day, with narratives ranging from climate change to racial equity to sustainability. Let me show you an example of one of these stories. I'll turn on autoplay to get an overview. This is a story about tree shade equity. Leaders from the city, community organizations, and universities are coming together to address the distribution of tree cover across Los Angeles. This immersive combination of text and media, including detailed images, informative maps, and engaging videos, bring life and meaningful context to your work, leading to understanding, which can bring an embrace of community and the possibility of change. Visualizing tree canopy with web maps like this one helps display tree shade inequities, especially across LA's diverse communities. Here, we see a contrast in tree canopy between neighborhoods. Story maps provide historical context for your narratives by visualizing timelines that help readers understand the history of the impacts felt today. And leaders can track progress and gather insights to improve their communities through embedded dashboards, surveys, and much more. Story maps combine text, maps, and media to help deepen the inherent value and power of any story. Now let's take a deeper dive into the new storytelling capabilities. And who better to show you than Ashley Dew, product engineer on the Story Maps team.
There are many exciting releases in Story Maps, capabilities you've been asking for. I'll share a few of them while we edit this story together. The first new capability I'd like to show you is the image gallery. It lets you quickly batch upload photos from your computer and easily rearrange them the way you want. Image Gallery combines your images into an attractive collage. We now get a glimpse into the work communities are doing to improve shade, like planting trees, In this sidecar, we've added an audio block to add a more human element to your story. Let's give it a listen.
Like many U.S. cities, Los Angeles is fighting to overcome the effects of urban heat islands and how they're impacting communities.
Another exciting feature is map actions. This web map highlights the striking differences in land temperature around LA. You can add map action buttons like these to navigate the map or turn layers on and off automatically. This creates a kind of map choreography. Here we have South Central LA with hotter temperatures compared to nearby areas like Beverly Hills or Bel Air that are significantly cooler. The next newest feature I want to show you is the timeline block. The timeline below allows you to visualize a sequence of key dates and events, showing how leaders in LA are addressing change across the city. We'll add one more event to highlight what organizations are doing today, with a title, description, and an image. Creating a timeline is that easy. Next, I want to show you a new enhancement with the swipe tool. As always, you can swipe a map to compare different layers, like tree canopy here on the left and building cover here on the right. And now, you can use the swipe tool to compare different images. Both of these are from neighborhoods in Los Angeles, one with dense tree cover and another with much fewer trees. And you can always leverage your GIS work through embedded apps, like your dashboards. This dashboard is used to track the progress of the City of LA's goal to increase tree canopy 50% by 2028. You can also embed your surveys, like this one, that helps gather community data on the impacts of shade. Lastly, I want to share with you some new ways that you can use a map tour. A map tour is an interactive way to showcase a set of related places. In addition to manually creating them, you can batch upload images or connect to a feature layer, plotting locations on a map in seconds. In this example, we've connected to our survey data to show responses, like Gerald, who wants clean air for his family, or Keisha, who's concerned about her grandmother walking in the hot sun. To finish this story, you can add helpful resource cards like these that show the ongoing work towards a more equitable and sustainable future. Next, I'll send it back to Jennifer, who will share 2 more additional capabilities on how to take your stories to the next level: themes and collections.
Consistent design, whether it's for your organization, campaign, or a specific initiative, strengthens your stories. This story uses the default Summit theme, and there are many other out-of-the-box themes to choose from. Let's apply a custom theme that speaks to our environment and to our community. We instantly see the environmental theme applied throughout the story in its background color, its fonts, its buttons, and much more. Here's how we create a theme using the new Theme Builder. Changing the main background color immediately sets a new tone for your story. Let's add a beige background, a dark green accent color, and hints of green and brown for the text. To provide a unique look for your story, there are hundreds of fonts to choose from. The Theme Builder also includes styles for your buttons, quotes, links, and separators. Let's apply this same image for our logo. I'll add a logo link and alternative text to ensure accessibility. You can share your theme with your organization for a consistent look and feel across all stories. Lastly, I'll share some exciting capabilities with collections. When you're working on a project, you often have lots of supporting work. Now you can bundle and share all of your work into a collection. You can add your stories, your apps like dashboards, insights, and surveys, and files. Collections are an excellent way to create your portfolio, bundle your newsletter, or give an interactive presentation. Let's apply the new magazine layout, which gives select items a nice spotlight, and we'll preview the collection. When we open this item, it takes us to a web map. Here, we're presented with a series of tabs to access every item in your collection, which helps readers easily explore and understand your work. Your work is crucial for real change, and ArcGIS Story Maps provides meaningful context your readers need. We're excited to see the impact your engaging stories have on your communities and in the world. Now, before we hear more from Jack, let's listen again to the moving music of Kevin Eubanks, followed by 2 new product demonstrations.
Thank you, Kevin, for joining us again at this year's user conference. So far, we've covered a lot of product technology updates earlier today. Let's continue with the next segment, where we'll take a deeper look at 2 new products we're developing, ArcGIS GeoBIM and the ArcGIS Maps SDK for game engines. Up first, GeoBIM.
Hello, my name is Anthony Renteria, and I'm the product manager for ArcGIS GeoBIM. As many of you know, building sustainable infrastructure is a complicated process. Critical data supporting project development is often hosted across multiple systems, making access to information difficult for decision makers. ArcGIS GeoBIM can help with that. GeoBIM links projects and workflows by interconnecting ArcGIS with the Autodesk Construction Cloud. You can create GeoBIM projects that link ArcGIS features to Autodesk records, which supports integrated visualization and querying, and improves project delivery. So let me show you an example of this complexity on a light rail project for infrastructure in the greater Denver area. Typically, GIS is used in the early assessments of how developments like this will be affected by the built and natural environment. And then, as we see in the Autodesk Construction Cloud, as we move into design and construction, the building information modeling process is introduced. Asset models and files are stored here and built collaboratively. Autodesk Construction Cloud manages engineering plans like you're seeing here that will be useful into the construction phase for contract documentation, but also to track issues for design and construction that will encompass quality, safety, and engineering specifications. Now, what we're seeing here are 2 distinct and separate worlds. So let me show you how ArcGIS GeoBIM brings these 2 together in a single app. What you're seeing here is, on the left, our GIS, which includes a base map, our infrastructure layers, and our building scene layers. And I've highlighted the rooftop AC unit equipment. And now on the right, what you're seeing is our Autodesk Revit model of this mechanical system to show the full route of the ductwork and engineering specifications. GIS and BIM are shown side by side to help with critical coordination of these detailed systems. And we can also do this for Autodesk Civil 3D models and AutoCAD files. When I select my rail feature, I can open up my link and begin to see this work in progress infrastructure drawing that we can share and collaborate around for the full project team. Now through GeoBIM, we're bringing this wealth of BIM and GIS together to improve coordination across the full project team. So let me show you how we can quickly link GIS and BIM in the GeoBIM Project Manager. First, by creating my account connection into the Autodesk Cloud. Next, I'll head to the Tools page, where I can automatically create links between my GIS and BIM. As I select my engineering documents and issues and click Run, GeoBIM will begin to search into my Autodesk project folder and begin to create boundary features that link back to the original BIM items. Now, this link information is useful, so let me show you how you can create our apps from this. Within the apps page, we can create various applications, including those for documentation review, site context evaluation, and design and construction coordination. But finally, let me show you my issues dashboard, which will be useful for project managers and executives who need to understand and monitor project progress. We can also understand where these issues are occurring across the project. And provide transparency into the overall project process for everyone. As you can see, ArcGIS GeoBIM will provide a foundation for your projects. Whether you're in an AC firm or owner-operator, you can simplify team collaboration and put your projects on the map.
We believe that GeoBIM will bring the engineering, design, and GIS communities together. Our next topic includes GIS and immersive experiences like AR, VR, XR, and gaming engines. In fact, you've already seen a few examples, powered by the new ArcGIS Maps SDK for game engines. Here to share more is Adrian Mariot, the project lead for the Maps SDK.
Thank you, Madeline. Game engines are the perfect tools for creating visually impactful, cost-effective, immersive experiences. The need for photorealistic experiences in many industries means that game engines are being used today for creating more than just games or movies. They're used, for example, in military simulation, in urban scenario, or in management of natural resources. The ArcGIS Maps SDK for Unity and ArcGIS Maps SDK for Unreal Engines are two new products currently in beta on their way to join the Esri family. With these plugins, you'll be able to access the ArcGIS system from the two most prominent game engines on the market. Here, we're using the ArcGIS Maps SDK to stream those base maps from ArcGIS Online into the game engines and display them on the globe. Thanks to our partnerships with Epic Games and Unity, you can now build experiences in these game engines that can transport you all around the world. For example, here, we're flying through the Himalayas to get a good view of Mount Everest. So we are looking at our image and elevation layers displayed in the game engine environment. But we can also add our 3D GIS content. Now, we're going to travel to the city of Bendigo in Australia and appreciate the incredible data created by our partner, Areometrics. The details look amazing, even at the street level. Look at this pillar in front of the art theater, next to the historic fire station. The Maps SDKs make it simple to add these types of layers to the scene, and the development environment removes the complexity of dealing with large data sets and different levels of details. We are now looking at the courthouse right next to the visitor center. We'll pass quickly all the shops on Williamson streets, and the one on Hargreave Mall. We're now on the street that feels a little bit closed in. With game engines, you can import content from other applications. Here, we've created an urban planning scenario using ArcGIS CityEngine, procedural building rules, and David Wesselman complete street rules. You can see how this design fits with the rest of the city. It feels now much more open and really enjoyable to just walk around. You could use this immersive experience to present to the city what the future of that city block might look like. With CityEngine SDK, you can procedurally generate data directly inside the game engines. You can start with an empty parcel and just add a CityEngine rules to it. Then, game engines will generate the building procedurally with the streets. You can also change the rules parameters, like the setbacks here, or the numbers of floors, directly, and see it happening directly on the game engine. Now, let's add some vegetation and street light to our experience, coming from the Game Engine's asset libraries. Look at those beautiful trees swinging in the wind. We now have a really beautiful looking digital twin of what that city block might look like in the future. Next, let's talk about the biggest advantages of using game engines. And those are visual effects and animations. This is how you can add another dimension to your experience. Look at this beautiful sunset, for example. You can see the light interacting with the tree leaf. Now the street light turns on at dusk, and you can look at the stars. We even just saw the moon. We can even change this sunny day into a thunderstorm. Particle systems are a key component of visual effects. Game engines provide easy-to-use tools to be able to create and control those particle systems. That's how artists can create effects like atmosphere, clouds, and rain. Not safe to have an umbrella anyway. Next, you can add and animate real-life characters into your scene. Having live character to your scene will really help everyone understand how the space will be used. Look at those people enjoying the outdoor cafe on a sunny afternoon. To bring more realism to our streets, what we need, of course, is cars. Cars' positions can be animated following a script or using real-world sensors. Oh, sorry, I need to move out of the way. Sorry. We've created this amazing immersive experience once, but we can deploy it to multiple devices. This one, of course, but also via headset, tablets, or phone. The simplicity of deployment is one of the reasons why virtual reality experiences are mostly built using game engines today. Let's talk about augmented reality now. I have now on my phone an application that allows me to look beneath the streets at the underground utilities. This is what we call real-life AR. Uh-oh, I think we're having a problem. Our newly designed cafe is on fire. Once again, we're using particle system to create this real-looking fire. And lastly, we can transition to this tabletop experience, giving us a top view of the city of Bendigo. Tabletop applications works as augmented reality on devices like phones or tablets, virtual reality on VR headsets, or mixed reality on devices like HoloLens. And they can all be powered with one single game engine project. They're good for situational awareness, advanced planning, and collaboration. Here, we're showing the position of the emergency responders on their way to the fire, represented by those red cones. We can also see the effect of the smoke on the city, depending on the wind direction and speed. And that was a quick tour of some of the things you can do when you bring GIS to the game engines using the ArcGIS Maps SDKs.
That was just a quick look at 2 new products we'll be releasing later this year. At this point, we're privileged to have a special guest from NASA's Jet Propulsion Laboratory to share a behind-the-scenes look at GIS that's truly out of this world. Without further ado, Dr. Fred Califf III.
Hi, I'm Dr. Fred Califf III from NASA's Jet Propulsion Laboratory, and today I'm going to talk about mapping Mars for rovers. As you can imagine, sending a rover to another planet is a big endeavor, and we want to have the most accurate maps as possible so we can find the scientifically interesting areas as well as areas that are very safe for the rover to land. So it can't just be done by one person. It requires a large team. So we have people from the U.S. Geological Survey that created our base maps, as well as people from JPL on the Terrain Relative Navigation team who took those base maps and provided corrections to the original data, such as the camera models and the instrument timings, as well as the people who helped find scientifically interesting areas and safe areas like the Council of Terrains, as well as people like myself who day-to-day make maps for both the science and engineering teams to keep track of where the rover is, where it's going to be, and all the science that it's done over the lifetime of its mission. So here's Earth. Looks familiar, right? You got the oceans, you have continents, you have ice at both the North and South Pole, and if you look close, you can see mountains and volcanoes and such. Mars is similar, but a little bit different, a lot drier. There's no liquid water on Mars currently because it dried out about 3 billion years ago. But you do see some evidence of water, such as the ice caps in North and South. It does get clouds, and you can also see things like mountains and volcanoes and valleys and places where we think water was in the past. So one of the exciting things about Mars is that 3 to 4 billion years ago, it was kind of like Earth. There was potentially an ocean, there was lakes, there was running water, and maybe, just maybe, the possibility of life on the surface, developing similar as Earth. Unfortunately, when we look at Earth 3 to 4 billion years ago, most of those rocks have been destroyed by plate tectonics. But on Mars, those rocks are almost completely preserved. So we go to Mars so we can see what Earth was like 3 to 4 billion years ago, as well as to answer one of these big questions: does life develop everywhere in the universe, or is Earth one of these only special places? So you saw that little white circle on that map. That's Jezero Crater. That's where we sent the Perseverance rover. And so here's a look at it a little bit closer. It's about 50 kilometers across. And that little blue grayish ellipse, that's where we wanted to land the rover, right near this river delta. So we think actually Jezero Crater was actually a lake, an ancient lake filled with water, and we see stream channels coming in and out, and that river delta where we're going to land that we think is the best place to look for past evidence of ancient life, ancient organics. So here's the Perseverance rover. It's about a SUV-sized vehicle, and it's composed of a variety of science instruments from a lot of different countries. For example, from Norway, we have the ground penetrating radar, RIMFAX. From France, we have the SuperCam instrument. And then we have instruments from the US like Pixel and Sherlock out on the arm, which will actually look for those organics within the rocks. We can also look at a 3D model of the rover. So here it is. And on the end of the turret, there's a bunch of instruments. We have Pixel and Sherlock and the coring drill, which actually take a piece of rock from the surface and put it into a tube for a future Mars sample return. We'll actually bring some of those rocks back in a future mission. We also have the MASS instrument where we have the science camera, MASSCAM Z, as well as that Cyclops-like eye SuperCam, which actually shoots a laser out to the rocks, vaporizes them, and then looks at the colors of that vapor to determine the chemistry and mineralogy. And so together, all these instruments make up the science package so we can investigate the science and the rocks on the surface. But we have to start with a map for the rover to land on, and for the scientists to investigate where's the best place to go. So we start by taking visible images from satellites in orbit around Mars, usually at 2 different angles, so we can create a stereo photo, so we can generate elevation models and slope maps and cost maps, so we can actually pretend to drive the rover over and see how long it will take to look at all the science areas. But so it's not only for safely landing on the surface, where are there big rocks or big hills and where can we go in between, but also being able to drive to these scientifically interesting areas and investigate the rocks that the science team is most interested in. So on a mission, we create a lot of maps. Everyone wants to know where's the rover now and where is it going. So we start with just maps of like a whole landing site. For in this example, a lot of maps from the Curiosity rover, the placement of different high-resolution images in the crater, maps of elevation and where the rover has gone and where it's been and where it's going to go. places where the rover had drilled into the surface and collected very high-resolution data sets in chemistry inside of its internal instruments. And just maps in general, keeping track of every rock that we've actually taken a picture of or shot with a laser or taken the arm out and put the instrument onto, as well as publications based on these scientific results so that we can share it with other scientists and the world. So Perseverance rover did something really special. Normally, our maps are used for landing in terms of a statistical sense, like this basic 25-kilometer area is safe to land in, but pretty much anywhere. However, Jezero was really special. Back on the Curiosity rover, Jezero Crater was deemed unlandable because with that landing system, it could not figure out what was safe and what was not within this landing ellipse. However, Perseverance has terrain relative navigation, which is a new technology where we actually carry maps on board for the first time on a spacecraft, and it uses those maps in real time as it's landing to figure out where it is as it's coming down onto the surface. So typically on Mars, we know where a spacecraft is within plus or minus 300 meters. Not safe enough to land in a very hazardous area like Jezero. So it takes pictures as it's coming down, and then it matches it up to this map, this visible map, and then it knows where the rover is within 5 meters, which is a huge improvement. And then it needs to decide where on the surface can we land, where is it safe. So also on board is the second map on the right, the hazards map, which shows safe areas to land in blue, as well as hazardous areas in red, big rocks, high hills, deep sand pits. And so you can see from that little white circle, that's where the rover landed. And you can, if you look really close, it's just a nice little light blue patch of safe area between two big red ones. So terrain relative navigation literally made this mission safe and success for years to come. So again, we take these maps from the engineering world into the science world. We use those elevation models to look at the geology both in 2D and 3D, as well as develop the geologic maps to show where the rocks are most interest to the science team, and can we visit them with the rover, and which rocks would we like to visit and collect samples from. But as you know, in the GIS world, we've gone from our static paper maps to fully interactive web-based maps, and we do the same thing both for our internal science team and engineering teams, as well as for all of you. So you can follow along at our NASA websites and watch the rover progress day to day and see where the helicopter is flown. And we really hope you join us in this adventure because every day is a new view on the planet of Mars. And thank you so much for having me.
Next, I'd like to take a few minutes and describe Esri's geo-enabled systems. These are about supporting with individual products focused workflows for indoors, for urban planning, for landscape planning, for business analysis, and most recently, emergency management and response. I'll start with indoors. This is a GIS for space and building management. It visualizes and analyzes all aspects of a building. It includes tools for being able to do data management about a building, and then organize and manage spaces, operations, and it even includes a series of apps for navigating inside of a building with indoor positioning technology. This is changing the way people see buildings. They're able to manage it more efficiently and more effectively. ArcGIS Urban is a 3D scenario planning system for both cities and regions. It's about geodesign in cities where you bring the data together, you do analytics like suitability analysis, and then interactively do scenario planning and quickly evaluate these alternative scenarios. This is exactly intuitively what you would imagine a city planner should do. Quickly, interactively, and with stakeholder engagement, evaluate technically different alternatives on to create a better future. We've been doing lots of new enhancements here. You can glance through this list. My favorite one is to be able to sketch buildings easily into the environment of urban so that I can quickly evaluate them. Similar to urban, the ArcGIS GeoPlanner is about geodesign for landscapes, and it follows a very similar pattern. You bring the data together, you do scenario planning, visualize and analyze the impacts of different landscape plans. Here I'm talking about like designing green infrastructure or being able to achieve the great goals of 30 by 30, saving 30% of the open space by year 2030. And I invite you again to go to these workshops. They're a lot of fun, and you'll learn a lot about being able to create a future which is more sustainable. ArcGIS Business Analyst is location-based market analysis and analytics. It comes with a huge library of geographic information and then has many tools for doing things like site suitability analysis, being able to do market research and infographics about geography. It's a huge benefit for businesses like Starbucks and Nike and Walgreens and hundreds of others like it. But it's also increasingly being used by government to be able to do economic evaluation and attract businesses to a community. ArcGIS Mission is a command and control system for tactical operations. What that means is like a fire or a search and rescue effort or a disaster response. It likewise brings the data together in a server environment and allows users to plan and execute and then see firsthand situation awareness of what's going on in the field. It consists of a series of applications both for managers of an operation, but also the first responders out in the field who are messaging back with peer-to-peer communication among themselves and with the headquarters office. Very fun technology. Well, some of you are asking what's next for Esri technology. And through the workshops, through the various sessions, you'll be hearing about what we're working on now. As some of you know, we have several thousand people in our R&D and development activities, and they are all very active in these sorts of topics. And they're so anxious not only to support you and please you, but also to hear your feedback about how we're doing in these areas. It helps them a lot, so please speak out and get engaged with them. We continue our incremental releases. This year, we're naming them the ArcGIS 2021 release with a series of dot releases for Pro and Enterprise. And we'll follow that nomenclature going into the future. We're definitely continuously improving our SaaS offerings and actually improving quality and performance in addition to these basic fundamental research efforts. I'd like to close with a couple of comments about the fact that we do more than software. We're all about helping you and develop your own skills. And we do that in a variety of ways. Of course, in real time, providing technical support with hundreds of people around the world that answer your questions and help you do your work better. But also through a large library of books, which we call the Esri Press, with over 150 publications and more coming, with podcasts, with Esri Press, with young professional networks, with well, a variety of resources. I'll just call your attention to the GIS Day coming up in November. It's an opportunity for all of you to participate in sharing your work. We also work on a progressive learning program. This is about building comprehensive skills for you. And we have hundreds of free courses that are available, large MOOCs, a new generation of learning methods called Learn ArcGIS. These are largely free. But we also have structured classes for web instruction, instructor-led courses, and an entire learning plan that I know thousands of you have registered into and stay current with our tools. Esri is all about serving you, and I say that very sincerely. We're advancing GIS and also the science that underpins GIS. We're very committed to strong engineering tools and embrace closely the whole science focus of our engineering efforts. We have an amazing team in this regard. Esri, I'd like to report back to you, is strong and healthy, and it continues to grow. One of our big missions is about promoting geography, if you haven't figured it out, geographic thinking, the geographic approach, and doing so at a global scale. And we like to do this collaboratively with you because I know it supports your work and it also supports the greater mission of creating a more sustainable world. Esri includes a small team of people who help respond to disasters. This means supporting our users in times of need. And we did a lot of this, of course, in COVID, but in hurricanes and fires, we collaborate with a number of other organizations, including our business partners and volunteer groups like GIS Core and Map Action, to bring resources together effectively to respond to efforts that are affecting our planet and affecting you. Esri also enjoys a very rich partner ecosystem with nearly 3,000 partners, some very large and also many of them smaller organizations that provide consulting services or build on our ecosystem. I'm very proud of them. Normally we'd all get together in a large auditorium section and you could visit with them. We'll be doing some of that live virtually this year. I invite all of you to get connected with these people. They're very powerful and very interesting. Esri also enjoys a series of special relationships. These are largely with NGOs or volunteer organizations. They partner with us and collaborate with us on shared missions and shared visions. Organizations like the National Geographic Society, Jane Goodall's group, the National Audubon Society, E.O. Wilson and their biodiversity work, the Nature Conservancy, and actually thousands others like them. We support them in missions like conservation, which is all about understanding and protecting nature. We provide our software without cost to these organizations. I think they're in the neighborhood of 12,000 groups that are supported by us directly or indirectly. We're also very interested in building the next generation of people, not only GIS professionals, through our programs with higher education, supporting almost 11,000 colleges and universities around the world. We also are looking even further out, building a geographically literate next generation of children. Over 350,000 children have been exposed, played with our tools through ArcGIS Online all around the world. We're partnered closely with the National Geographic Society in carrying this out, helping students everywhere acquire geospatial literacy and develop these kinds of skills that you as a community possess. I invite all of you to become a geo-mentor, adopt a teacher, adopt a school, get involved in this. It's very rich and very rewarding, I promise you. I'd like to close with a couple of final comments. I've shared my sense that our world is a single changing ecosystem. It's increasingly threatened by us, our human activities. We are clearly living beyond our means. To create a more sustainable world, we're going to have to take responsibility for its future, applying our best science, our best technology, and our best creativity. Your work is already demonstrating the power of what GIS and the geographic approach have to offer. You are creating integrated systems that work and support sustainable human activities everywhere around the globe. These are tremendous footprints, actually. Geospatial infrastructure is making our GIS more accessible and scalable. My big vision is that this will expand to reach every organization on the planet, becoming involved, creating a global information system for sustainability, a kind of nervous system for our planet. However, this sustainability challenge requires far more than technology. GIS professionals, and here I'd like to speak personally with you, are going to be essential. You need to provide the leadership, working together, doing all the necessary work, like chopping wood and hauling water. You know what I'm talking about. To apply this geographic approach at scale, this is what will be needed. Integrating geographic science and holistic thinking into virtually everything that humans do going forward, creating a sustainable future. Ladies and gentlemen, our old friend and colleague, E.O. Wilson, had this to say: we only have a short time to decide about our future. We're in a kind of race to save the living environment. And I take that personally, and I want you to as well. Last night, I wrote a few personal messages just for you. First, you're working in the coolest profession, and history will record how very meaningful your work is and has been to changing sustainability on the planet. And I know what you do. I know it's important. And I also see firsthand the power of this work. It's taking everything and putting it in context, visioning, seeing the future. I also want to say that I want to encourage you to share your work. I mean, it's very powerful when you do that. Other people learn from you. And this is the only way we're going to get to scale, actually. Share and communicate your work successfully to others, not only within our profession, but also beyond. People are interested. They trust you. They want to collaborate with you. And I'd also say, just personally, build strong professional collaborations. I'm sorry that we're not all together at this conference, because that's the place where we often find a new friend, where we begin this sharing and support network. And I want you, above all, to remember that your work does matter enormously. And also, just a few practical things. Build great maps, maps that tell stories, tell the important stories, because they open the eyes for others to really understand how just very important your work is. So finally, move rapidly. I mean, I love this field. I know you do as well. Move rapidly and urgently, because our world really needs it, because we need to create sustainable solutions, because time is running short. It's late in the day, but it's not dark yet. Okay, so I want to encourage all of you to own this and go with it. Thank you very much. Enjoy the rest of the conference. I'd like to invite you back for tomorrow morning's plenary. We have 4 really great people that are speaking from China about the oceans, about racial equity, about being able to develop a sustainable future in conserving open space and going for 30-30 programs. See you tomorrow.
systems, it's something that's really taken off. It's something that's really taken off, and its ability to take these nadir imagery and oblique imagery and generate all these products, including these 3D textured meshes like we saw. And then you can bring these meshes into your GIS where they're sort of like this foundational GIS layer. But then on top of that, you can place, you can drape, you can fuse these other GIS feature layers like points, lines, polygons, 3D objects. So they actually have attributes, they're transactionally updated. So this combination is sort of really like an intelligent base layer, right? You can touch on it, you can see what's there. You can also see it visually, very realistic. And then there's the rest of 3D GIS, and that itself has just grown, right? The visualization capabilities with are really amazing, like 3D symbols for points, for example. And then, of course, the interactive analytics powered by the GPU, like the shadow analysis that we saw during the plenary. And then also just the geoprocessing, standard analysis, all of it working on these new data types. So really, 3D GIS it's really coming together.
I think it is clear to everyone who watched the plenary this morning that our data isn't just 2D, it's 3D, it's 4D, it's multidimensional, it's spatiotemporal, it's real time. It's really, everything is changing, and the technology is there to help us take advantage of it. I do want to call out one thing which I think is really important, which is obviously we're drawn to the very new, exciting, new capabilities, new products, new technology. And of course, I love the new stuff too. But sometimes it's the little things that make the biggest difference, right? I mean, I use Pro every single day, and that Pro demo really stood out to me.
Yes.
It's those little things that are going to make my life easier, that make me so happy to see, and things like the command search, things like copying that Python code without having to run a tool, little stuff that makes a big difference. Of course, there was also the not so little introduction of the new data engineering experience, which I am biased is pretty amazing. I was very involved in the development of that work along with an amazing team, and I think people are going to really love being able to quickly and efficiently interact with their data, visualize it, explore it, and then clean it and prep it and get it ready for the fun stuff, the analysis.
Yeah, you know,
sure.
that bread and butter work that you talked about is just so important. If we were together in San Diego, those would be the big applause moments,
Yes,
right? Those productivity
definitely.
tools, the thing that just make the heart and soul of GIS better every day. And I really appreciate the work that all the dev teams are doing on that front. Now, what we'd like to do also is hear from the users. There was a lot of chatter, tweets, and other comments going on during the plenary. So we'd like to bring up some of the comments that we saw during the plenary and maybe talk about those for a minute. So here's one that stood out to me. There was a lot of commentary about the power of spatial analysis and different features and functions, and the Forest Service demo certainly knocked people's socks off. And Bonnie made this great comment about harmonic regression and how it's being used by the Forest Service. I love the call it my mic drop moment. So that one really jumped out to me.
Yeah, I loved that one also.
It's great.
I know here's another one where we've got folks really excited about things like that copy Python command. I knew people would be excited about the command search. I saw a lot of comments about that. There's just a lot of talk about Pro, and again, those little things that make a big difference.
So pivoting a little bit to the sort of the frontiers, we did talk about Kubernetes a little bit, and I loved this pair of comments. We had a user talking early on about needing to know more about Kubernetes, and then you can see here in his second tweet that as we went through it in more depth, he's starting to get very intrigued. And I think that speaks to the journey that people are on about understanding the next generation of IT. And then we had a whole bunch of other comments, and it was really honestly hard to capture them all because there's so many great things being talked about. But I know one of them was getting into collaboration with hubs, and it really gets into the area of system engagement. And I'd really be interested, Sud, in your reflection on that because it's such a big frontier.
Yeah, I think the system of engagement is a really huge and key aspect of GIS, right? You manage the data, you do your analysis, and then you disseminate that understanding that you've gained. And basically our system of engagement is, we have creators, we have builders, we have developers using GIS tools and GIS, technology to create these experiences for citizens and stakeholders. And, that engagement technology like Web App Builder or Experience Builder or Instant Apps, we saw that, during the plenary. And, it includes dashboards that have been really popular with our customers because they've been able to really represent what they are looking to do, right? So it requires lots of attention to detail, and the teams who work on these aspects really work really hard. And then there's the hub, which sort of takes that engagement to the next level, right? Like with respect to open data, with respect to initiatives that are focused on things like COVID response. And then also with respect to two-way engagement with the community, right? So the community themselves are participants in this process. So yeah, I mean, the system of engagement, including hubs, really big part of GIS. One of the 3 pillars. Yeah.
Well, one thing that comes to my mind is also story maps, and we saw some really great story maps demos.
Absolutely.
And as someone who's really involved in spatial data science, I often talk about that last 10%, that ability for us to tell our story, because it doesn't matter how great our analysis is, it doesn't matter how great the data we've collected is, if we aren't communicating it really effectively and it can't be used to make decisions, so kind of what's the point? And I think that we really saw that come through in the plenary today.
Absolutely.
So one of the great things about this event right now is we have users with us. And in fact, we have one of the best users in the world. Ray is on the other set. So Ray, are you around? Would you like to join us?
Yes, I am so excited to talk about the plenary. I really just sat and spent so much time listening, learning, taking notes down. And there are a couple things that really stood out to me. And they might seem simple to some of you guys because you're in and out of it day in and day out. But for me, the thing that I think really got me to take tons of notes was the global land cover map. I mean, this high resolution set of global land cover data. And that's something that, I geek out about stuff like that. I actually wrote a lot of my dissertation on the movement of wild animals and how we can understand their habitat needs better depending on the spatial resolution of the data we're using. So being able to see that we have this really fine scale information or fine spatial resolution information on the land cover all across the world means that other scientists, no matter where they're based, can understand the habitat needs as well as I can here somewhere in California. And that is advancing this conservation work so tremendously. I mean, I can't tell you, even 5 years ago, something like this could really blow our understanding of wildlife needs out of the water. So that was tremendous for me. I don't know if you guys also took a look at that.
Yeah, it's amazing. It's really great.
I think that's such a cool example, Ray, because it's, there's all of the work that went into creating that information product and all of the the really hardcore GIS work that went into creating it, and then all of the amazing GIS work that's going to happen using it as an input. It's amazing.
Yes, I was just about to say that. Exactly what you did. Because it's like you use GIS to create it, and then actually it is a foundational layer on which you do all of this modeling and analysis.
It's amazing.
It's true. It's true. Yeah. That was just so impressive to me. And, I just have to say, there's a lot of, wild animals out there who just use the landscape in a very coarse resolution. But there's also some that react to really fine scale changes in the environment. And now we can actually model that properly because these tools have been developed. So I could go on and on about this improvement, but it was so nice to see in the plenary. It really got me thinking. I have some students who are tuning in, so I hope that they were also checking it out. And then the other thing that I really wanted to just applaud was the Grenada example, so again, like the focus on the Caribbean, the focus on some environmental issues there, and the walking through of all the different modeling work in Grenada. They ended up making a risk map that showed us, risk of, I believe it was landslides across the island. And those types of risk maps are also used in a lot of my work with wildlife conservation and can be used for so many both environmental and social issues to really pinpoint geographic locations where there might be some extremes. And that was just wonderful to see. That's the type of work I do all the time, making maps of where different scenarios or even future scenarios, but even seeing where, you know, the land might fall off into the coast where it's unsafe to build housing, all of those kinds of things are really tied in. When we're making successful conservation plans, it needs to include, you know, social needs, infrastructure, etc. So that was a really, really great example, and I want to know if you guys also thought that was a winner.
Yeah, for sure. It's so powerful hearing you talk about it, Ray, because you're doing it in the field every day, and all of the things that we think about as a software company are coming to action in your hands. So thank you, and you represent all of the users who are watching today with this tremendous work.
It was like getting to sit backstage with Ray and watching you watch it. It felt kind of like I got to be in San Diego just to see a little glimmer of that excitement. So I feel pretty lucky about that.
Yeah, that familiar feeling. So, okay, I don't want to let you guys go quite yet. I would love if the three of you could, you know, if I could ask you guys to provide kind of a final comment. So when you saw the whole plenary put together, what does it mean to you in the big picture sense? You know, what's the big idea that you felt was conveyed here today?
Okay, well, I'll start, which is, and my quick comment is that I was left feeling like I have so much more to learn, right? I mean, it's one of the things I love about being in this field is that there's literally never going to be an end to what there is to learn, but I watch that and I work on the software, building it every day, and I was just, couldn't help but think, wow, I really need to take a step back and just, I have so much to learn, which is a really exciting place to be, I think.
Lifelong learning.
Yes, absolutely, yeah. What about you?
Yeah, like I think for me, the thing that you know comes through is like the integrative power of GIS, right? GIS is data-driven. It works with all of these types of data, and it lets you really do analyses and visualizations that combine all of them together. Like even in that Grenada demo, you know, we saw it starting off with imagery, deriving information from it, feature information, doing further analysis. Then it switched to 3D. We saw all of that in 3D. That's GIS, right? Like it's all together. It's not all segmented apart, right? Because these things are all related. And of course, in the world at large, these things are related. Then I think the other part is, you know, the ability to build. So there's GIS, like we just spoke of. But then on it, we build these focused solutions. And they actually just leverage the technological power of GIS, but to their users, they're solutions. And you know, ArcGIS Urban, for example, is one of them. And then I think, you know, the last thing is that, well, we were still able to only scratch the surface, and there is a lot that's been worked on. All of the teams are very excited. They're here to present their work, and you know, this is the week for it, so I just encourage you to go to the sessions, listen, and learn, and you know, share your feedback.
Thanks, Ed. I guess I'll just close with my reaction is I'm always struck by the power of GIS and its sort of impact at scale, bringing information to everyone, reaching far beyond the community of GIS users to make a positive difference. We've certainly seen that. And it's a privilege to be part of this community. And from all of us at Esri, we want to thank you. We appreciate being at your service and being able to support the important work that all of you do.
Yeah, thank you.
Thank you guys so much. This was awesome feedback. I can't wait for more of your feedback as the plenaries progress. And I'm back here with Nick, my buddy here, all things GIS. And Nick, you know, now that we're done with the plenaries, I hear that you are going to give us a little bit of a tour.
Yes.
Is there anything you want to discuss before then?
I think we're all set. Thank you so much. I'm glad you got so much out of the plenary. I think we all did.
Oh my gosh.
And it was like you know, like it was said, it was great to sit with you and watch you as a user. You know,
He means watch me geek out over all the new things.
We usually have, you know, 18,000 of you. We all just kind of, oh, Ray's really excited about this. So thank you very much.
Thank you.
What I'm going to get to now is some logistics, folks. We're going to talk about the platform. So if I'm going to give you a little tour for a few minutes. So we start with, of course, the homepage, which is where you experienced a bunch of things this morning. And there's, you know, we got our set of nav across the top. I'm not going to walk through all that. It's relatively straightforward. But there's a couple of areas I want to draw your attention to. So the first one is that very first jump, which is sessions. This is where you're going to get all of the content that you really, you know, when you come to San Diego, this is what you want. It's all those tech workshops. It's the SIGs. It's the thing you're going to a conference for. It's that education and learning. and importantly, it's getting your questions answered, because every one of those sessions, has a live team. They're there, they want to talk to you, they want to answer your questions. Again, just like we're in San Diego, trying to do the best for you. If we go to the next area, this is probably where you're going to spend most of your life this week. Is, if you select if you put an avatar in the system, you selected that, you're going to be into your account essentially. And the biggest thing here is your schedule. You can add all types of things to your schedule. Again, you're going to see those sessions, you add them to the schedule, you're going to have potentially meetings. You can launch everything from here. So what we've heard in kind of the testing of this is a lot of people are just going to kind of, their life is going to be on this page, and then they're going to just like jump off of here. So this is a great place for you to kind of coordinate your life. Now, a really important thing, and this is the most difficult thing in virtual for all of us that have been doing this for the past year and a half, it's connecting. So how are we going to connect to each other? Because like I said, we're here. We want to talk to you. We've got this messaging platform inside the system. You can schedule meetings with people. You can, basically with other attendees, with Esri staff, with our partners. And again, like I said, in those sessions, you're going to find the people that are making those presentations. They're here on the platform. They want to talk to you. This is the tab you're going to use to connect to those people, set up some time to chat. Furthermore, from an Esri staffing perspective, we have the virtual info desk. Here, we've got a set of Esri staff. If you're having any technical issues, issues trying to find content, because of course we have so much, trying to find individual people, who's the right person you should try to reach out to, this team will actually help you connect to the content and the people you need to talk to. We also, even though we're virtual, have this concept of joining in on the fun. So if you scroll down the home page, you're going to see this area that we've got 3 items that are called out. Of course, we've got the virtual run, walk, and bike. I'll talk a little bit more about that later. We have the map gallery, which has all of your content that you've submitted. We'll see the awards later during the conference. And then we have a new thing this year called UC GeoPros. Here what we're doing is trying to drive a little fun, a little gamification. You're going to earn some points, by going to sessions and favoriting different things and using the social networking activities with, chatting and things. And at the end of it, what we're going to do is we'll take the top 10 point scorers, and you're going to get an Esri swag bag, the kind of thing you'd pick up at the conference. One of the reasons you come to San Diego. Now, the last thing is we couldn't have a website without a map. We are Esri. So what I want to do is bring in Esri cartographer John Nelson, who's joining us from his headquarters in Michigan, which we have affectionately coined ShedX.
Hello, Nick.
And John, good to see you. It looks like you've actually given ShedX a bit of a makeover.
Hey, it's the same wooden box I'm always in, but this year I just turned the camera around and gave you guys the view that I normally have. You have something else to look at other than some pine.
Very kind. Very kind. So on the main homepage, we've got this cool, crazy globe thing going on. So first of all, what are we doing? Globes on websites? What? Talk to me here.
Imagine a world, where we can have a 3D web map. So the story is the team had designed the UC website, and there was a globe that was just an image. And James Hitchcock saw that and said, wait a second, why can't this be an interactive actual globe? And so, the ball started rolling, I suppose in a literal sense. We turned that into an interactive globe. We reached out to Raluca Nicola. Raluca is just a wonderful 3D designer. She's based in Zurich, Switzerland, and she designed this really kind of charming, papery, origami-style globe. And the thing I like about this aesthetic, which is called low poly, by the way, it's a low poly design aesthetic, is it makes this world look like a cute, charming little ball of fun. It's a spiky ball, and those spikes represent where people are tuning in from.
Yeah, so we're using some of the cartographic techniques with basically the extrusion out of the 3D world to show quantities. So talk a little bit about this this kind of low poly design thing.
Yeah, sure.
You know, what kind of like what like again like why did we pick it? I mean, it looks really cool. But if you don't mind giving us some background, it's kind of this. You know, what I'm thinking about is like we've got design, we've got cartography. They often meet to make beautiful things, and you know, kind of kind of how do we get here?
Yeah, sometimes it can be a lot of fun to view our world a little bit more abstractly than we typically do. You know, you might be accustomed to seeing a 3D globe on the web and it's using satellite imagery as the base map. But this is a more charming approach, and the tack that Raluca took makes it like an object of joy. It's this fun thing. We're all sharing the surface of it. You know, we're all kind of living in this little model, and we're seeing each other. And those, as you mentioned, those columns extruding out are the folks who are joining us this week. The folks who have registered. We've taken those cities, we've grouped the cities, and developer Jinan Zhang did an amazing job in implementing this and letting this data just come to life. And the cities, the users are grouped by their cities, you know, for privacy's sake. And then we just throw out a column based on how many there are. And I hope people just have some fun with it. Spin it around, look for yourself, you know, look for another area that you're interested in. But really, I want folks to have a sense for, we're all sharing this place, right? And we're all map nerds, and we're all just geeking out about the fact that we get to talk about maps for a living. How cool is that?
Absolutely. I mean, and so in one way, you know, coming from the design space of it, you know, there's always kind of the question, and you talked about kind of the object of joy of, you know, so you've got like what we have is this beautiful thing, and then of course there's all the science that we do and all the science our users do. Yes. And you know, you've got that, you know, I think what you're trying to say is you can look at a map, you can look at a globe, and you can understand like, well, so like this is for science, this is real, and versus something like this is actually art and it's playful, like you said, an object of joy. Yeah. And that we should know the difference between the two of them.
Yeah, sure. Now, if I was approaching this from the perspective of, well, we need to make a scientific visualization that shows the number of participants here so that people can get an immediate sense for, you know, very specific numbers and stuff, we would do something very different, quite different. It would be a 2D map, likely. You know, we wouldn't be using 3D extrusions, but the 3D extrusions are fun. So this is something that's supposed to be interesting and engaging, and it's not a scientific treatment of this phenomenon. It's a fun model of all of us together, all of us map nerds hanging out on the same paper mache world.
No, and it is a combination of like, hey, we're using the geocoding technology underneath, you know, so we're using real tech. Yeah, please.
Tell you about that. So Matthew Keeling and Mike Harriger worked together, and they took all of these wonderful map folks that were, you know, joined by this week, and they aggregated them to the city, and then they geocoded the city. And the global geocoding was well over 99%. And when they told me that, I was like,
wait, hang on, 99%.
That's what I said. Yeah, 99% for international work.
I mean, that's because global geocoding is such a complex problem. And I mean, so shout out to the geocoding team.
Absolutely. Yeah, absolutely. They did a great job. Yeah, it was very impressive. Geocoding to the city is a little bit more straightforward, but international, that's a tough nut to crack. Yeah. And nearly 100%. You just don't. It was a thrill. I love that.
No, that's great. So a couple of things before I let you go. We've got for everyone seeing the globe behind me. There's actually, do you want to talk about a little blog that you wrote about this?
There's globes all over the place, Nick.
I'm talking about, I know, but I'm talking about, like, you know, because, you know, from the one that's actually behind me.
That is a VR globe. It's all fake and digital, and it's green screen. No, I'm just kidding. That thing is real.
Come on.
That thing is the real deal. It was, you know, designed here at Esri and printed and sewn together and stitched together and assembled there in the new office building. And if you're curious about the process for like, how does a GIS get involved in making a 8.5 foot diameter globe, check out our blog post about that, which we just released this morning in the ArcGIS blog.
I can't wait to read it myself, John.
Yeah, get ready to live.
I will. The last thing, do you want to let folks know that we're actually going to see you a little later today?
Goodness, yes. So this is one of the many joys of being a map person is you get to hang out with other map people and talk about maps. So I'll have a very small segment with some really talented hosts of Mappy Hour. So coming up later on is Mappy Hour, where three wonderful colleagues of mine will get together and chat maps. We'll talk about maps from the gallery that our users have submitted. Beautiful work. You know, you could talk all day about the beautiful work submitted into the map gallery. There, you know, what's not to love about that? And we'll have some fun. I'll join for a couple of minutes about little tips and tricks, and we'll invite other folks in to talk about map making and give some professional advice, perhaps. But really, it's just a chance to have fun and nerd out together about maps.
It's going to be great. And yeah, and you guys will be here all 3 days.
Yep.
So later this afternoon, we'll see Ken, Edie, and Nate. And of course, John will be here, some other guests. So again, thank you so much, John. It was great talking to you.
Thank you, Nick.
Take care.
Yeah, enjoy. You're doing great. Have fun, everybody.
Yeah, so we got 4 p.m. Pacific time for that. Before we let you go to tech workshops, I just wanted to do a little bit of housekeeping. As we talked about, there are 220 of them. They are spread across 15 concurrent sessions. So you're going to put those on your schedule if you haven't already, and then you basically lay out what you want to do for the next couple of days. They all again live with Q&A with our presenters, and also if you can't attend a session, you're going to be able to get them on demand later on because a lot of things are going to be happening at the same time. So we know you can only watch so many things live. And what's going to happen here at UC Central Live is before we go into each tech workshop sequence, Ray or I are going to give you kind of an idea. If you don't know what you want to watch, we're going to give you some tips. Going into the next session, here's what you should really be looking at. So let's do that. So for the session coming right up, there's ArcGIS field maps and introduction. There's what's new in the Living Atlas, and we're going to meet those folks later this week. We've got an introduction to Pro. We've got spatial data science across the ArcGIS platform, and of course, always great for an introduction to ArcGIS Online if you're not using WebGIS. So with that, find your sessions, go to them, have fun. We'll be back here in an hour.
Enterprise. Next and how to get and then we're going to I'll show you some tips. Then flows that can be done through for your
So Power Automate, these allow you to automate kind of standard ArcGIS. To and from ArcGIS. And as Art's already mentioned, you can connect to that ArcGIS content using your ArcGIS identity or the API key. And now I'm going to pass it to Anthony to show us a demo of Power BI and Power Automate.
In the world of Power BI, performance and displaying items on the report page are crucial to effective reporting and making informed decisions. In our upcoming release for ArcGIS for Power BI, we are upgrading our visual using the latest JS API 4 technology. This is enabling us to use smarter and faster mapping capabilities throughout the visual. To show an example of this new visual, I'm using data from 311 calls in Chicago that are dealing with reports of bees from people throughout multiple neighborhoods. I'm going to add the latitude and longitude fields to the field wells. As you can see, we have tidied up the appearance and speed of adding data to the map. This also includes the visual smart mapping capabilities. When adding numeric values to the size and color field, we can see the map change in real time and help us make informed decisions about what is happening with the data. In addition to smart mapping capabilities, we have also introduced new ways to symbolize your data. Previously, we only had the options to allow 3 different shapes, but thanks to JS API 4, we can now use a wide variety of symbols from ArcGIS and incorporate them on the map. Let's set our points to look like bees. Next, we can add additional context to our points by adding data to the tooltip field wells. This will allow the pop-ups to display additional and relevant information to the report consumers who are viewing these reports. On the topic of tooltips, we now have better tooltip integration when adding a reference layer to the map. Let's add a layer to the map and look at the new tooltip experience. We can click on any one of the polygons and bring up its information. We can now see that the tooltips provide a better and richer experience when exploring the map. In previous versions of ArcGIS for Power BI, a report designer could drive visuals on the report page using the Power BI data layer. This data layer can come from many different sources. In this example, I'm using an Excel table that contains my data. As you can see, the visuals are updating when I choose locations on the map. I can also filter locations on the map using the graphs and charts. In addition to filtering the Power BI data using the selection tools, we can make use of a reference layer to select the Power BI data within a given boundary. In this example, I'm selecting different zip codes, which then filter the Power BI dataset. In version 2020.4, we can use ArcGIS for Power BI to create a layer join between your ArcGIS reference layer and non-spatial attributes in your dataset. If your Power BI data does not contain spatial information, such as addresses or coordinates, you can link data attributes from Power BI to those from a reference layer added from ArcGIS to provide deeper insight into your data. You can join the data layer and the reference layer by linking common attributes in each dataset. To use the layer join feature, ensure that the ArcGIS reference layer contains attributes that match those in the Power BI dataset. The name of the attribute does not have to be identical, but the data type must be the same. You join numbers to numbers, strings to strings, and so on. To start, add the ArcGIS for Power BI visual to the report page. You can use Power BI Desktop or Power BI Online to create the map-enabled report. You can perform this layer join both with and without Power BI data. Next, drag a non-spatial attribute from the Fields pane to the visual's join field well. You can add up to 5 attributes to this field. As a general note, if the map does not contain a data layer with spatial information, the map appears empty. Next, add a reference layer from ArcGIS to your map. Ensure that the reference layer you choose contains attributes that match those in your Power BI dataset. Each reference layer can have its own layer join. In the layer list, click Layer Options to view the context menu and click Layer Join. The Layer Join pane appears. The data attributes you picked in the Join field appear on the left, and attributes in the reference layer appear in a drop-down menu on the right. From the drop-down menu, choose the reference layer attribute that most closely matches the Power BI attribute. You must join at least one attribute to create a join. If you placed more than one attribute in the Join field well, use the drop-down menus to match each attribute. You can match up to 5 attributes for each reference layer. When you've matched all the attributes, click Create Join. As you select locations on the Join reference layer, Other visuals on the report with attributes that match those in the reference layer
but also
automatically
into the
If no match exists, a message appears stating that no results were found. You can also select items and other visuals on the report, and the map will immediately update to reflect those changes. When a reference layer has been joined to data attributes, a link icon appears in the layers entry in the layer list. You can change the settings for the layer join at any time. In the layer join pane, click Remove Join. You can drag a new field from your Power BI data into the join field well and match it with the corresponding attribute in the reference layer. You can also remove or select already existing attributes. Click Create Join, and the layer join will be updated with the new values. After you design a map-enabled report, you can use the Power BI Publish to Web feature to add it to a public website or blog article. You can also use the Power BI Publish to Web feature to embed it in a secure website or application outside the Power BI environment. Before you can publish the report to the web, run the Publish and Embed check on the Power BI visualization to ensure that all requirements are met. To check a map-enabled report for publishing or embedding, do the following. Create a report that contains an ArcGIS for Power BI map and save the report. With the ArcGIS for Power BI visual active, click Settings to view the settings pane. In the Embed and Publish check category, click Validate. The check verifies that all requirements for publishing and embedding the map have been met. These include the following. Power BI location data is in latitude and longitude coordinates. For publishing, the map must only contain publicly accessible layers from ArcGIS, and no layers contain secured or premium content. In embedded, you may need to sign into ArcGIS to view this content. Review the message that appears when the check completes. Layers that pass all requirements appear with a green checkmark. If an item does not meet the requirements, a red mark appears beside the item. Click Show Error Details to view information about the error. Correct errors in the map, save the report, and run the Embed and Publish check again. When the check completes successfully, a message appears stating that the map has passed and is ready to be published or embedded with the report. When you've created and checked your map-enabled report, publish it to the Power BI platform. In the Publish to Power BI pane, choose My Workspace and click Select. You may be prompted to replace an already existing report. When the report is successfully
If I tap the GPS banner, I can also find more information about my current location. If I have the license to start tracking, I can tap on Track My Location, and it will ask me how long I want tracking to be turned on. Maybe I'm going to be at this park location for, let's say, 8 hours. With this duration set, tracking will automatically turn off when I reach that 8-hour time mark. Location tracking is enabled on a map in the GPS details of the map, or from the specific My Tracks map card in the maps list. In April, we provided more opportunities to use location tracking within your organization. For example, the field worker user type now includes support for ArcGIS Tracker, so you can record and share your location without any additional cost. So I'll click out of the GPS details, and in the Overflow menu, I can access additional tools, such as bookmarks, legends, the ability to mark up the map, the ability to change the base map, and much more. So I'll tap the markup tool, and now I am in this mode where I could drop a marker and add an arrow to that marker. I can drag that arrow to the start point of the Cascade Canyon Trail, label it Trailhead, and I can also make a note as well. I can also sketch a circle around this area and fill it in with color. Then I can take this markup that I created and I can share it as a screenshot. I can take the markup itself and share it to a friend or someone else by email or back to my ArcGIS organization. They can open the markup inside of Field Maps or ArcGIS Pro and see the markup I placed on the map. Let's go back to the list of maps. I am going to tap on another map called the Washington Bridge Project map and open it. This map includes a lot of different utility information as part of the map, and it has been authored for a field data collection and asset inspection workflow. You can see in the bottom right corner there is a blue plus button that lets me collect data onto the map. Using this button, let's complete a data collection workflow. I will zoom into this area near the Washington Street Bridge, and I will press the blue plus button. Here I can see a list of different types of features I can capture. I am going to tap on Commercial Service Connection, and it's going to drop that point directly at the location on the map. I can update the location by moving the map around, and then tapping Update Point. From the sliding panel, I want to show you how to fill out the form. I can set the lifestyle status to abandoned. Additional fields appear that are organized into a group called Abandoned Service. Only when the life cycle is set as abandoned will this group show up. I can set whether the status is critical or not, and I will put it as unknown. We can also type in a note as well if we like. I will leave this required metered field empty and will press the submit button. Field Maps now has a new submit button experience. Now the submit button is always enabled. If required fields need to be filled out, a message will appear, like this one, and the fields will be highlighted in red so that you know what you need to do and fill out. So now I will go back into the form and fill in that missing required field. We don't really know if it is metered or not, so we will put it as unknown. Now that all required fields are filled out, I can finally submit my form. We have now created the new service endpoint. Tapping down below on the pop-up information, I can quickly get access to additional tools. I'm going to tap Collect here, and once again it shows me a list of the features I can capture. And this time I'm going to tap Commercial Services because I want to construct an underground line that we found as well. It sets the point to my current location, and as I move the map, it rubber bands a line that shows me where the next point will be dropped. If I move over to this valve location, I can snap directly to it. And that lets me define some connectivity between the line and other assets on the map. Tap Add Point to set that location, and once again I can fill out the smart form. I will set the status to abandoned, the asset type to cast iron, indicate we found it using a tracing wire, and then press Submit. I have just shown you in Field Maps how we can capture new information, both points and lines. Now I'm going to show you how to conduct an inspection workflow. I'm going to tap on this fire hydrant, and straight away you can see this custom pop-up that shows details about the hydrant. What's interesting about this pop-up is that if you look, it says that 4 maintenance inspections were completed. Now how do we know this information? We know this because we created this custom pop-up using the arcade expression language. We are able to go and use a concept called feature sets to navigate from the asset to related inspection records, and then find out how many were completed and display that directly in the custom pop-up. You can use the arcade expression language to provide this intelligence on any information you want to look at. Now, I'm going to tap on the relationship button and then add a new related record. I can now fill out the smart form. In this case, it includes several different groups. Information on inspectors themselves, information on the inspection that was completed, and I can collapse and open each group as well. There is also a conditional statement here, one that asks me if a hydrant flush was required, and if so, it shows additional fields. And you must fill out that flow rate field to submit the form. But that is only done when the field is visible. If it is not visible, it's not required. This was a quick glimpse of the ArcGIS Field Maps mobile application. We started with showing you a set map, both a read-only map and one used for data collection and inspection workflows. Those maps can be packaged for offline use, and you can open and use them when you don't have an internet connection. If a map supports data collection workflows, like the one that is currently open, you can complete those inspections and capture new data directly in the map. All of this you can do with the support of location tracking. Thank you, and back to you, Brent.
Thanks, Tamaya. That was an excellent demo. But now I'd like to change gears a little bit and focus on the other part of the Field Maps solution, and that is the Field Maps web component. Now, while the mobile component is really designed for the mobile worker, the Field Maps web component is designed and targeting GIS analysts, those who in their organization have to configure and deploy maps for the mobile workers. It's supported in ArcGIS Online and Enterprise 10.8.1. The create privilege is required to create new items in ArcGIS Online or Enterprise. But at this release, we also support maps that are shared in a shared update group. So it's not just maps you own. It can also be maps you're collaborating on and updating collaboratively within your organization using shared update groups. Some of the capabilities in the web app are the ability to configure map properties, the ability to configure a smart forms experience, as well as content such as layers, tables, and settings that will be turned on and off when the map is opened. There's also ability to manage the offline experience your mobile workers will encounter when they open the map, as well as a way to quickly share and deploy different maps. So drilling in a little bit on the map setting configuration aspect to the web app. Here you can configure which map tools will show up in the application and how those map tools will behave. So you can configure whether data collection, whether copying, whether edit multiple will be available as feature actions. Also a number of different collection settings. So you really have fine-grained control over how your mobile workers collect data, whether it be the location accuracy, the photo size they collect, snapping, averaging, streaming. A number of different parameters can be configured in the web app, and then your mobile worker doesn't have to worry about having to set all these parameters. The web map also allows you to configure and specify which feature templates should be used when collecting new features or adding existing features. You can think of a feature template as your data dictionary, which really controls how the data is collected, what symbol is used, what name, description, what sets of values are valid. The web application can be used to configure all this to really ensure that you get the best possible data coming in from your mobile workers. Now, Smart Forms is an exciting new feature that we've been putting a lot of our energy into, and it's really a new way to create and edit attributes in ArcGIS. Now, Smart Forms are included in the web map specification itself, so it's part of the web map, and it's supported in the map viewer as well as field maps. It really simplifies the field editing experience in a number of different ways. Now, I'm mentioning it in this section because really the design experience is completely housed in the web version of field maps. So this is where you design the experience you want your mobile workers to encounter in the field. Some key capabilities of field maps is the ability to use groups to organize different fields into different groupings, apply conditional visibility to fields, format the form and its fields, as well as qualify required or read-only fields so that you're not getting edits where you don't want them. A little bit on field formatting. You can use description text for each field, as well as a caption. Maybe it's a hint as to how to edit the data itself for your mobile workers. You can define a field as being read-only, so that can be used as a reference, maybe an in-service date. You don't want people editing that, in the field, but they might need it to get their job done in the field. So you can set that field to be read-only. You can also specify which fields in a form are required. And submissions will be blocked until those required fields have a valid value. Now, we support a number of different input types in SmartForms, and we're always adding new input types. So the switch input type, for example, was just added at this June release. But before that, we had a text box or a text area. We had a date time, a combo box, a barcode scanner. We're always adding new input types, which really come to life in the mobile data when they're configured within, or the mobile experience when they're configured in the web application. This really optimizes data entry. A little bit on grouping. A group has a display name as well as a description, which is often used to give a hint to the mobile worker how they should edit fields within those groups. By default, you can specify if the group is expanded or collapsed within the mobile application, but the mobile worker themselves can collapse or expand those groups to make editing simpler as well. One of the most powerful capabilities of SmartForms is conditional visibility. This is as simple as the visibility of a field being determined by the execution of a certain arcade expression. This arcade expression uses the arcade constraint profile, and it always evaluates to true or false. So you could see here, this will evaluate to true when the damage field is not equal to no damage. So in this case, you might want to enable certain fields that'll show when there is an actual damage value. A number of different offline capabilities that can be managed from the web app as well. So you can enable and disable offline mode, you can fix and diagnose map layer issues, and manage offline map areas, all from the web application. You can also control what types of data is delivered when a field worker takes some data offline, a mobile worker takes some data offline. All right, I'll throw it over to Damaya one more time so she could demo the Field Maps web application.
Thanks, Brent. Starting from the home page of my organization, I can open the Field Maps web app from the app launcher. Doing so will take me directly to the list of maps that I have authored. If I have lots of maps, I can click on the search button. This will filter the list of maps to ones that I'm interested in. If I type in Redlands, you can see it filters that list to just the Redlands campus indoors map. One of the interesting things you can do from the maps page is select an existing map and choose to hide it so it doesn't appear when you sign in and view the maps list. Another thing you can do here is duplicating a map to create a copy of it. I can also directly edit the sharing capabilities of the map and delete the map. Let's go ahead and open this Washington Bridge project map and examine some of the configuration capabilities. This is the map I showed in the mobile demo earlier, so we're going to touch on some of the content that I collected with, and I will show you how some of that came to life. So starting with the overview page, you can see the thumbnail of the map, and here is where you can also change it. Some other information you can view here is the map name, the summary of the map, whether it is available for use in the mobile app, what the offline capabilities of the map are and its offline status, and finally the sharing status of the map. Now let's take a look at the Content tab. The Content tab is where the structure and anatomy of our map lives. As you can see, there are quite a few editable layers within this map. Now we can dive into the data collection capabilities for these different layers. For example, I'll click on Service Connections. In the mobile demo, I showed you how I created a new abandoned service connection endpoint. In that demo, I clicked on Commercial and created a new endpoint that way. Well, say I wanted to reorder these different templates. Let's say most of what I'm doing in this project is commercial related. I will drag and drop the commercial feature template so it can be at the top. Now when I click on this specific feature template, There are additional things that I can do. I can duplicate the template, or I can delete it. Let's say I wanted to make a specific template for an abandoned commercial service endpoint. And in addition,
build structures and vegetation. And here we see the digital terrain model, or DTM, which represents the elevation of the area devoid of buildings and vegetation. We can also look at the site in 3D. This will give us a realistic view of the basin's shape and relief. We will now perform the storage capacity analysis using our rasters, and we will do that in ArcGIS Pro. We click the button Open in ArcGIS Pro. We are now in ArcGIS Pro, and all the layers that were in our Drone to Map project are present. We will perform the analysis using tools from the Special Analyst extension. For the data, we will focus on the DTM layer, which gives us precise terrain elevation information. First, we'll use the Fill tool. It will take the DTM raster, identify any depressions or sinks found in the terrain, and fill them up. It will then create a new terrain raster with all the sinks filled up. In the geoprocessing pane, we search for the Fill tool and open it. We choose the DTM as the input and type a name for the output. The new raster with the filled up sinks appears. We will now use a second tool, Cut Fill, that will compute the volume difference between the original DTM raster and the fill result raster. This will give us the volume of each sink. We search for Cut Fill and open the tool. We enter the DTM and fill result rasters as parameters, and we type an input name. The resulting raster shows all the sinks that were identified, symbolized in red. The largest one is the retention basin. The Cut Fill tool also provides an attribute table where information about every sink is listed, including their volume. We sort the table by the volume attribute. And the top row is our retention basin. Because of the way the Cut Fill tool works, the result is given to us as a negative number. So the volume is 5,343 cubic meters. We have now measured the volumetric capacity of the retention basin. Finally, we can also create a new layer containing a polygon derived from this raster. We'll use the Raster to Polygon tool. For the input, we choose the volume raster, and we type an output name. This new feature layer gives us the exact boundaries of the water basin.
ArcGIS Image for ArcGIS Online can be used for publishing imagery layers to ArcGIS Online and enabling powerful analytical tools in ArcGIS Online Map Viewer Classic. To begin the publishing process, from the Content view, click the Create button to open the Create options. If ArcGIS Image for ArcGIS Online is licensed and authorized, the option to create an imagery layer will appear. To continue the flooding analysis, you will now use ArcGIS Image for ArcGIS Online to create the other input data for your study. To begin the analysis, you will create a new imagery layer in ArcGIS Image for ArcGIS Online and use some of the new analytical tools to determine the areas that have been flooded. Click the imagery layer to start the publishing process. The first option to consider for the imagery layer is whether to create a tiled or dynamic layer. Both types of imagery layers can be used as input to raster analysis, but the key difference is how the imagery layers are rendered and processed. For tiled imagery layers, the processing and rendering is on the client side. For dynamic imagery layers, the processing and rendering is on the server side. For this image layer, we will create a dynamic imagery layer. The next option to consider is the layer configuration. We will choose the option to create one mosaic image to use the raster type for the sensor data. After reviewing the input data, we can use the Landsat 8 raster type. The next step is to choose the configuration for the imagery layer. Since we know the no data value is 0, we will specify it now to remove any no data pixels from the imagery layer. Since we are interested in using the raster bands for analysis in our study, we will choose the multispectral configuration. Next, we will browse to the input data folder. You could also drag and drop the individual rasters, but since all the Landsat data is already in one folder, we will use that. You will see the files chosen will appear in the dialog with a progress bar indicating the upload status. You can wait until all the datasets have been uploaded or continue. The update process will continue until completion before creating the imagery layer. Next, you will fill out the item details for the dynamic imagery layer. Be sure to add tags to allow for others to find your data. Once complete, the imagery layer will appear in the item details for the layer. In the item details page, there is information about the layer, including the image properties. Here you can see that the Landsat imagery layer includes 8 raster bands and a cell size of 30 meters. Now we will open the imagery layer in Mappy Hour Classic. The map will display the imagery layer at full extent, and the default band combination is natural color. The display of the imagery layer can be modified to change the band combination for a custom visualization. You can create a custom visualization by altering which bands appear in the display. With a combination of near-infrared, red, and green bands, the imagery layer will now be displayed in a color infrared visualization. After zooming in, you can see the reddish vegetation visible in the study area. In addition to modifying the band combination used to visualize the imagery layer, there are more tools to further your analysis. Within the raster analysis option with ArcGIS Image for ArcGIS Online, there are imagery analysis tools that can be used to process the imagery layer. Raster functions are also available to analyze your imagery layers. Click the Raster Functions button to open the Raster Function Template Editor. For this study, we are interested in the flooding area visible around the river. To reveal the flooded area better, we will use a raster function to create an index. The other input raster showing the area before the flood was processed with the MNDWI. So to create the comparison, you will use the same index. You will use the band arithmetic raster function to create the output.
for your ArcGIS Online organization. There's a pretty straightforward user interface for uploading your imagery and creating your own dynamic or tiled image services. There's a session image for ArcGIS Online at
There was a great question in here, and we saw a brief demo on it. And it's how do you bring in feature classes from a geodatabase into ArcGIS Online? Beforehand, there was a question asking about how you can upload your own data. If it's local, if it's a shape file, you put in a zip file. But in this case, if you have the data in your geodatabase, you can publish it. And we saw that in the demo. And there's a couple of different ways you can do that. In ArcGIS Pro, you can go to the Share tab, or you can right-click on the layer, and you can share that layer. And I'll also add that when you do share a layer, there's different types of layers that you can share them as, whether you want people to access the geometry of that feature, or if you just want to share that data as if it's a visualization only for quick rendering as well. There are a couple other questions that were alluding to that as well. That's a good question.
And then we had one, so you know, the question is, you know, I have I've made 3 maps from 1 layer, and I need to be able to update the points in the layer. It seems to only update the point in the map that I'm using. Is there a way to update the underlying data, to update it in all 3 maps automatically? I'm going to have to make some assumptions, for this particular question. I know it says point layer or shapefile. Yeah, I'm assuming that that we're talking about web layers or specifically feature layers in this instant. If that's correct, then when you move your point in 1 layer, the next time that you reopen if you move the point in 1 map, the next time you reopen another map or refresh that map, you should see the point move there as well. If you're using Map Viewer Classic, you can set the refresh interval, and that is an option that will be in Map Viewer in the latest iteration of Map Viewer. And there's also the opportunity to set the I'm looking for the document, the cache control. There we go. Sorry. So there's also the opportunity to set the cache control for a layer. I believe by default, it's usually about 30 seconds, but that will help consistently update that cache in your browser so that that layer will appear fresh.
There's another great question in here. Will the uploaded geodatabase retain all the symbology when uploaded to ArcGIS Online? And it's a good question. When you're comparing ArcGIS Pro and ArcGIS Online, ArcGIS Pro is a powerhouse, right? It's where you're going to do a lot of your spatial analyses and create high-end cartographic products. And ArcGIS Online and Map Viewer largely focuses on sharing and disseminating information and collecting information. And part of that is being hosted in a web browser. And so if you have a really custom symbology, complex symbology from ArcGIS Pro, and you publish that out to ArcGIS Online, it will probably have to downgrade to a simpler symbology just because we're asking a web browser to do something that a software application does. It's a good question. It's something to be aware of.
And then I have one, if a user has a feature layer or other content hosted on their account that's used by the organization, and that user leaves the company, does the admin just move the content to another user, or does the feature layer get deleted with the user? So there's a fail-safe in this, in that you will not be able to delete the member unless if they own data. So you do have to make a decision there, whether you want to transfer those to another user, transfer them to an admin. You will have to make a decision about where you would like that layer to live, before you'd be able to delete that user.
We have a great question that just came in. Does the map viewer use a standardized projection? If so, is it a good idea to project your layers to this projection? It's a good question. The default in standard projection for all of WebGIS and ArcGIS Online and Map Viewer is a WGS 1984 Web Mercator Auxiliary Sphere. And if you wanted to, you could publish your own base map in a different spatial reference and use it in your map viewer. But it is generally a good idea, whatever spatial reference you're going to stick with, whether it be that default WGS 84 or something else, that you do have your layers in that spatial reference as well. It's a good question.
And then I have one, it says, can I make dashboards with ArcGIS Online? Yes, you can. It's actually a pretty simple process. You can either start with a web map, or you can create a web map within when you start the dashboard. When you go into ArcGIS Online, if you go to the Content tab, you have the New Item button and the Create App button. If you click on the Create App button, there's an option right there to start a dashboard, and you can start creating and editing your dashboards as you see fit.
So we're taking a look at some of these other questions.
While you're doing that, Timothy, we can answer the. So there's a couple of folks who have asked about analysis in the new map viewer. So analysis is coming in the new map viewer. It looks like potentially with our Q4 update. That should be available. I know they've been consistently working on it, and I've seen the demos. It looks great. So, it's going to be a really powerful function as soon as it's added. So right now, for analysis, you would use the classic map viewer, and in a couple of months, you should be able to start migrating those workflows over to the new map viewer.
We have a good question in here. What is the storage capacity of ArcGIS Online? That's an interesting question because it's Esri servers that are hosting everything on ArcGIS Online. And so if you're thinking about capacity in that way, but in terms of how much data that you can have on your organization, on your ArcGIS Online organization, it's a pay-as-you-go method, right, Allison? The amount of storage or how much you consume is largely up to how many credits your organization has.
Exactly. So we had a question here. Can you take photos in the field apps and have them transfer to the web app? This is absolutely a workflow that we support. It depends a little bit on which web app we're thinking of. So when you attach, usually in the field, you would have a feature layer and you would enable attachments for that feature layer. Then you can attach those pictures to that feature layer and access your pictures along with the feature layer. So there's some web apps that support that workflow, pretty seamlessly, especially, in some of our field, our more field optimized web map templates that are available. So definitely a workflow that you can follow. I'm trying to think of a good help document, and I'll see if I can find one real quick that explains how you could make that web map pretty quickly and easily.
There's another great question in here about the new map viewer. And there's a great blog put out there called The Tale of Two ArcGIS Online Map Viewers. And it talks about the functionality between the two, but largely with the new map viewer, there's a lot of symbology options that are not present in Map Viewer Classic. Things like layer blending layers together cartographically, grouping layers together. You can label clusters. You can rotate the whole map even. That was another question. You can create charts. So there's a lot of features out there that are in the new map viewer that weren't in the Map Viewer Classic. All right, and that wraps up our time together. We want to thank you all for coming to our session, and we hope you enjoy the rest of the conference.
Submit things that you want us to build, and then the entire world, the entire community votes on it. So it's not just Pro, it's all of ArcGIS. Yes. But because I work very closely looking after ArcGIS Pro and Desktop, we focused on a few things in this poll for you to vote on of what you wanted us to build. And you can see that what you voted on, we actually built. So it's pretty simple. Yeah. You talk, we listen, and we try to build what you need.
And that was what was great is, Jim came on the show last year and said, look, this is real. If you folks vote on this, we'll do this. And here we are a year later, and we're we're coming for the congratulations. You did it.
Yeah.
And actually, do you want to kind of show for the folks that
what
didn't
you
see
voted
it or
on,
didn't vote? Yeah.
what the highest vote was show us how to build active definition queries. Here's ArcGIS Pro. You can assign definition queries to any layers in ArcGIS Pro in the contents pane, multiple layers, and we're assigning those query definitions to those layers. But actually, just imagine you have 100 layers and you want to find the 15 that you have active dev queries on. Well, that's where we put in a filter option, which is what you're seeing here. It says show active definition query, and then it shows you in the contents pane what's active. It's that simple, and it's really useful. You voted on it, we built it.
I mean, it's great, and it just, you know, like you talked about ideas. You know, we have this thing here at the conference. We listen to you. We don't always get it right, but we always listen. So we're going to do it again since we're here. We've got another poll for you. So let's bring that up.
Yeah, so this ideas in the Esri community online now, it's incredibly important. We have a monthly meeting where we dive in deep on these things. So what feature would you like us to see added to ArcGIS Pro? Improved data management capabilities in the Pro Catalog view. Many of you who over the years have used Arc Catalog, we've migrated that capability into the Catalog view in Pro. This is your metadata. This is you toggling between items, looking at full path names to folders, things of that nature. Enhanced enterprise data management workflows. This is really important for you building geodatabase schema, wanting to share that schema, wanting to look at reports for that schema, wanting to merge that schema. Sharing ArcGIS Pro projects through ArcGIS Enterprise. So ArcGIS Pro creates a project, you want to share it with someone in a very large enterprise, well, why not use the portal in ArcGIS Enterprise to do that sharing? Many of you have said that that's something that you would like. Simulation modeling, this was actually number 2 last year. This is bringing flood simulation, wind, noise modeling directly into ArcGIS Pro. And then data engineering. You know, the one thing we all have to do as GIS professionals is manage and know the quality of their data. And we saw that this morning in the plenary. You know, new text strings, and wouldn't it be cool to have a data health checker that actually scanned all of your data and told you, you know, how healthy your data was and where you might want to change it.
So, you know, this is what we've got for you. And right now, Jim actually has to go over to the other set. So I'm going to let him go. And he's got some great people he's going to introduce you to. And what we're doing is we're going to leave this up. We're going to play a little music for you because we know you've got to basically, you know, use the QR code, get your phone, got to do what you got to do to take the survey. This is the goal that we're is it truly drives the development team. So please take the time to vote until Jim gets set up for the next set. And again, he's going to introduce you to 2 pro team and a great conversation. Thanks.
Hi, everyone. We're on another set, and I am joined by Ankita and Susan. Ankita works in our spatial statistics team, and Susan works in our sharing team. So these are two folks that build the software. And what we do when we're building software is we're giving you an idea of what we're working on, and we do that in a roadmap. And for those of you that haven't looked at the ArcGIS Pro roadmap, there's, well, here it is, and you can search for it. And this gives us an idea of what we're building near term and mid-term and long term. For instance, upgrading Python environment when you install new software. Lots of you, work with multiple Python environments. Sharing projects in the enterprise. Working with Voxel Layer sharing, working with big data analytic warehouses and sharing that information. I intentionally said that word sharing several times because Susan actually runs the sharing team, and it's really cool to have her here. And also, all of you probably saw Ankita this morning demoing the data engineering tools, which are freaking awesome. I mean, that's so cool. But those tools were on the Pro roadmap also. If you would have been looking at the Pro roadmap last year. But we built them and the team shipped them, and you got to see them today, and you can enjoy them in the software. So what's really cool is you two represent 2 teams out of 55 teams that actually work on building new capability in ArcGIS Pro. And it takes a lot of collaboration to do what you do as product engineers. What are some of the things that really personify the collaboration between your teams internally, and then how you collaborate with our users externally? Maybe you guys could just share some of that, Ankita?
Sure. Specifically, my team, Spatial Statistics, is a big team, and we have awesome people. We have highly motivated software developers and product engineers working on making amazing software. So collaboration, as you said earlier, is a big key. And since we are all motivated, we kind of all have meetings, project meetings, to kind of have that collaboration going on. And also collaborating with users is so important as well, as you also mentioned that before. And let me give you an example of this data engineering project that we all saw this morning, and how collaborating with users was so important in that project, because we all knew getting your data ready before analysis is a step that takes 80% of your time. It's it's a very time-consuming process.
Yep.
And we were just wanting to make it really simple so that people can just focus on the work, the important work that they're doing in spatial analysis. So we reached out to many users, did one-on-one interviews with people who have been using software for a long time, or people who have been using software very recently, just to kind of get an understanding of the pain points or the challenges that they face when they make their data analysis ready. So we did interviews with them, and then we came back. We prototyped something based on the feedback, and here's the interesting part. We went back, but then it did not land well. We don't always get it right the first time, do we? We have to be willing to be agile, and we have to redo based upon users' input. That's why feedback is so important, because then we were able to really streamline what users really wanted us to make. Because that feedback was so important, and then it was gut-wrenching. We spent months prototyping it, but then at the same time, it was at the end of the day, we were able to make the software that would help them really achieve what they were looking for. And we did this internal holistic testing. This is a very interesting concept, as you know, Jim and Susan, that we bring people on campus this year, though virtually, and then they test the software and give us feedback even before that thing goes live in ArcGIS Pro.
With their own data.
Right.
And those are some hard conversations, actually. We learn a lot with you working, shoulder to shoulder in Redlands when we were able to do that, or even virtually. So yeah, those are hard things.
Yeah, but we got great feedback
Yeah,
in that
second
internal
time.
holistic, and I'm sure like Susan would have something to share, like how they collaborate with their teams and how they collaborate
Yeah,
with users. I'm excited to hear that.
Thanks, Ankita. So the amazing thing about Susan's team is when you press that button that says share, the magic that happens and the technology that actually spins under the covers, sharing from Pro, to other users and using Pro, or sharing to mobile devices, field apps, sharing to enterprise, sharing to online, sharing across all of our JS. Your team brings that to life.
Yeah, I mean, sharing is, like you said, a cross-product team. We're working with, ArcGIS Online, all the mobile apps teams, to make that magic happen when you press that share button. So we're hearing from feedback from users from all different angles, from different products, right? With Pro, when we are working on new development, we actually work with our early adopter community, which is this program for users to test out an early cut of Pro using their own data. We're getting feedback
And
from...
you get to work as technical support in the EAC community. So
Exactly.
That's cool.
Yeah, we're getting feedback from real user workflows, and it's really nice because we get to hear about whether or not our design works, or if it doesn't, we get the opportunity to fix it and redesign and revisit before we release the software.
That's right.
Yeah.
Because once we release that software, we can't take it back. It has to do what it needs to do to help out our users do their important jobs better.
Yeah. It's something else that we do that is my favorite is we do usability testing to test out our UI. Right. So we actually, we'll invite in users to test out our software and we'll record all of their clicks and interactions with the software. And for us as product engineers, it's like really eye-opening because we're staring at the software all day long.
Right.
But when we watch a user work through the software, it really helps us see where we can make things more intuitive.
Cool. Well, that's great. Thanks for sharing it. How's the poll coming, Nick?
Yeah, let's take a look, see what we have. Okay, looks like that improved data management capabilities in Pro Catalog really pulled it home. So it's kind of what we expected a little bit there, but no, it's great to see. So thank you, Jim. Thank you, Susan. Thank you, Ankita. It's great to hear you guys chat. Thank you to all our users for this poll. We are at time for the next check workshops. Some of them will work. We're not sure all of them will, but what you do need to know is later today, all of them will be online on demand. So if you can't get them live now, keep them in your schedule, find them later, and view them later. We'll see you next time.
Analytics as a SaaS. You are able to host, analyze, and stream your imagery and raster data via the cloud. Organizations are able to host and manage imagery in ArcGIS Online. It supports all forms of imagery and rasters, standard projections, and multiple metadata sensors and collection platforms. Host your own imagery or other partner content, whether it's satellite, aerial, drone, orthomosaics, terrain, multidimensional, and more. And to ensure your images are ready to use, the metadata associated with your imagery remains intact. With that imagery you've hosted, you have the ability to use image and raster analytics at scale for classification, multidimensional, and AI workflows. Users can perform image analysis in ArcGIS Online using more than 150 raster functions, more than 20 ready-to-use raster analytics tools, and pre-trained deep learning models. ArcGIS Image for ArcGIS Online can help organizations to assess suitability, which lets users detect variability across the Earth's surface, such as differences in terrain, elevation, land cover, and visibility. Detect change, where users can apply deep learning to streamline change detection workflows. Inspect assets, where organizations can upload images of assets and infrastructure, then apply image processing and analysis to evaluate the conditions of those assets. Monitor vegetation, which can help users examine multiband imagery to extract information about vegetation coverage. Trace water flow, which allows users to locate watersheds, which are areas that contribute water that flows downstream. And lastly, plan routes and networks by allowing users to analyze imagery to identify the optimal paths and connections between areas. For streaming, leverage ArcGIS dissemination capabilities to reach all your users and directly integrate imagery into your existing geospatial workflows. Stream imagery of large construction sites, cityscapes, and entire regions, as well as post-event imagery, rectified scenes, orthomosaics, elevation, multidimensional, or categorical rasters. You can also stream the results of your imagery analysis to your entire organization. Users can then access and stream the imagery and raster data in other applications, dashboards, story maps, and reports available in ArcGIS. So let's review what you can do with ArcGIS Image for ArcGIS Online. You can host your imagery in Esri's cloud, upload and share your imagery and raster collections in ArcGIS Online, making them accessible to those users who need it. But if your imagery data is already in the cloud, or you're looking to move your imagery data to the cloud, ArcGIS Image Dedicated would be a good option to explore. It has the same general capabilities as ArcGIS Image for ArcGIS Online, but it's for those organizations whose data is stored in AWS or Azure. ArcGIS Image for ArcGIS Online lets you create ready-to-use image services. Intelligent, tiled, and dynamic image services provide immediate pixel-based analysis capabilities in web and desktop applications. Extract insights from all kinds of imagery. Interpret and extract information from yours or other imagery and raster data sets. And lastly, share your imagery products. Quickly go from imagery to storytelling. Turn observations, analysis results, and subsets of dynamic or tiled imagery into interactive apps and dashboards anyone can understand. And with that, I will now turn it over to Jay, who will be talking about hosting imagery in ArcGIS Image for ArcGIS Online. Thank you.
Thanks, Jay, for the introduction of this new exciting product. Next, David and I will dive into the details of capabilities offered by ArcGIS Imagery for ArcGIS Online, starting from the ability to host imagery data. Once you sign up for ArcGIS Imagery for ArcGIS Online, you will have the ability to upload your imagery data from your local storage to ArcGIS Online's hosted data store and create hosted imagery layers. And there are two new types of imagery layers that is supported by ArcGIS Imagery for ArcGIS Online: the tile imagery layer and the dynamic imagery layer. Comparing to the traditional tile layer, which already exists in ArcGIS Online, and you may be familiar with, the two new imagery layers have many advantages. The traditional tile layer can only serve pre-computed static tiles, which is 1 or 3-band JPEG PNG files. It is commonly used as base map layer for fast visualization, but it also has obvious limitations, such as it cannot be used for analysis. In contrast, the new tile imagery layers while also serve static tiles, but it can also support multi-band imagery with more than 3 bands, at full pixel depths and even multi-dimensional raster data, which makes it fast for visualization and at the same time suitable for image analysis. This is achieved by automatically optimizing uploaded image data to a new tile format during the layer creation. And because of this optimized format, web client can also be enhanced to perform client-side rendering and the reprojection on this type of layer. And if you need additional functionality, such as server-side on-the-fly image processing and dynamic image mosaicing of image collections, then Dynamic Image Layer is your choice. Dynamic Image Layer is supported by the latest release of Image Server running in ArcGIS Online. It provides a powerful server-side processing capability and also put less load on the client. And because it's image service, same image service as in ArcGIS Enterprise, the layer is well supported by all ArcGIS applications. If you have existing tile image layer that you want to utilize the additional functionality of dynamic image layers, the tile image layer can also be republished as a new dynamic image layer item. With the built-in layer creation user experience, you have 4 different ways to create image layers with ArcGIS Imagery for ArcGIS Online. You can either upload a single image dataset and then publish that dataset as a single image layer, or if you have a collection of imagery layers, you can either decide to publish them separately as multiple imagery layer, or mosaic all of the imagery data together into a single image and publish the mosaic image as a single image layer. Or if you want to preserve the original data format of your uploaded data and take advantage of dynamic image layers, dynamic mosaicing capability, you can choose the image collection mode to create a dynamic image layer referencing the collection of image data. And ArcGIS Imagery for ArcGIS Online also support a variety of different type of image data formats. You can upload conventional image file formats such as TIFF, JPEG, PNGs, or you can create layers from scientific multidimensional data such as SDF, GRIB, or NetCDF. And we also support 30 different types of satellite data sensors and aerial sensors. As I mentioned earlier, when you decide to create image layers from a single image data, and the imagery data will be converted, and you have the option to choose either to use JPEG or lower compressions to compress your data. Or if you want to preserve the original upload imagery format, and you can choose the serve as image collection mode. There's also additional settings allow you to customize the metadata information of the image layers, such as pixel units, acquisition date, column map, attribute table, vertical coordinate system, etc. Now let's look at a quick demo on how easy you can bring your local imagery data to ArcGIS Online with our built-in Create Image Layer Wizard on the web. Once you sign into the organization with ArcGIS Imagery for ArcGIS Online enabled, and your user was also granted with necessary privilege to use the functionality, you can navigate to the content page and click on the new item options. In the pop-up new item dialog, you'll find imagery layer option becomes available. Click on image layer option will bring you to the create imagery layer wizard. The first page of the wizard will ask which type of imagery layer you want to create. You can either create tile, dynamic, or both from the uploaded imagery data. We already talked about the difference between the 2 types of layers. In this example, I'm going to go ahead and choose tile imagery layer. And the second page asks which mode you want to create your image layer. If you upload a single imagery, it's straightforward. You can just choose the one image mode, which will create one image layer from this single image, a single uploaded image. Or if you're uploading a collection of imagery, you can either choose to publish each imagery in the collection as separate layers, or you can mosaic all the imagery together to create a mosaic image and publish the mosaic imagery as the final tile imagery layer. I'm going to choose the one mosaic image mode and click on next. And now you go to, now it comes to the upload dialog where you can browse and or drag and drop imagery files from your local folder. In this example, I'm going to just upload 2 TIFF files. And once the files has been put into this upload dialog, it will start uploading. And on top of the upload dialog, you'll see the imagery type drop-down list. For the conventional file format, like what I was uploading here, choose the raster dataset data type is enough. If you're uploading scientific data or satellite or aerial camera data, you need to choose the data type appropriately. In addition to those, you can also choose the tile imagery layer data type, which can create a new tile image layer from existing one or many tile image layer that was created and owned by your user. And below the data type drop-down list, you can also find configure property options. Click on the button, it will bring up additional options you can configure during the layer creation process. For example, under General tab, I'm uploading the 2 TIFF file I'm uploading are actually color map image. I can choose my source type to thematic. I can also choose the compression method I want to use. For the color map image, low compression is enough. Or if you're uploading RGB natural color image, JPEG, to further compress the data and save the storage cost on the tile imagery layer. And because I have choose the source type as thematic, I have additional options where it allows me to specify additional color map input for the data I'm uploading. I can choose the color map file, and then there's other options you can configure, such as metadata information about the acquisition date of the data, band mappings, or spatial reference of the output layers, and the data and transformation you want to use if your input data is different from the target layers projections. And there's also additional processing options such as building footprint or define no data value for the pixels, for the imageries you're uploading. Once you finish configuring those options, click on apply. And then click on next. You can define the layer name and the tag to create the layer. And click on create, it will finish uploading and start converting the TIFF files to and mosaicing them together to this tile format, optimized tile format. Now let's look at what other options you have if you choose the dynamic imagery layers. If you choose the dynamic image layer on top of the 3 creation mode that is available under the tile image layer option, you also get the image collection mode. In this image collection mode, you can upload a collection of imagery data and then preserve its original format and create an image collection and publish the collection, publish the dynamic collection as the dynamic imagery layers. The upload dialog and data type drop-down list is the same as what we saw on the tile image layer options. And one thing to be noticed here is, say that if you're uploading satellite data, it is important to upload the entire folder contains the satellite scenes. By preserving the folder structure of the satellite scenes, you can create the layer successfully. And the rest is the same. You can define the layer name, assign a tag, and then create. This concludes my create imagery layer demo. Once you have the layer item created, specific to dynamic image layers, you'll find additional options under the items details page. For example, you can go to the settings tab of the item detail page and configure additional settings for the dynamic image layers. You can define the request size limitations, just like the settings available for the enterprise image server. You can also define additional processing function template attached to a specific dynamic image layer items. And for the dynamic image layer that is referencing an image collection, you also have access to additional post-processing tools under the image management tab. You can build footprint, build overviews, compute seam lines, color corrections, etc. These are specific tools that works on image collections. Now, once you have created imagery layers, the next thing is to talk about the enhancement we made on streaming or rendering the imagery layers. For tile image layer, our web client can support client-side rendering such as through projection, straight relief, and color map renders. We are continuing to expand our web API to support more client-side renders for super fast visualization. And as of today, the tile image layer is supported in the classic and new web map viewers, the scene viewers, and also ArcGIS Pro, but the version has to be 2.6 and up. And for the dynamic imagery layers, because it is actually image service behind the scene, one signature ability is to support the server-side on-the-fly processing, either through the built-in processing template or any processing raster function processing template that is shared in your organizations. And dynamic image layer is well supported in all ArcGIS applications, including our classic and new web map viewers, the scene viewers, all versions of ArcGIS desktop apps, such as ArcMap and ArcGIS Pro, and also in the runtime SDK. And besides the ability to support image collections, if dynamic image layer is created from a single imagery through the one mosaic mode or multiple layer mode or one image mode, it is also referencing the special tile format, and it can also support tile API for fast renderings. Now, next, I will hand it over to Dave, and he will show you some demos on fast streaming or rendering of imagery layers and some on-the-fly processing examples.
Thank you, Jay. Let's compare and contrast the streaming and rendering experience for the layer types you and Shay have been describing. To begin, let's consider the client-side rendering and visualization available with tiled imagery layers related to the Cameron Peak fire. Here, I have an Airbus Spot 7 scene, acquired last year on September 7th, about 3 weeks after the fire started. This fire was finally contained on December 2nd, but made its mark as the largest wildfire in Colorado history. This image is 60 kilometers wide, has 4 bands, and 16-bit pixel values as reflectance. Tiled imagery layers include all bands at the full pixel bit depth, which we can observe in the pop-up. Tiled imagery layers stream data to the client as CRF tiles containing all bands. Tiled imagery layers expose client-side rendering in the image display menu for compositing, stretching, and dynamic range. Changes are instantaneous and happening on the client side. Among the rendering options are RGB composite, stretch type, and gamma. Here, I have an elevation mosaic for the state of Colorado from USGS 1/3 arcsecond rasters, also as a tiled imagery layer. This elevation data aids in the understanding of fire progression and post-fire recovery efforts through its ability to provide slope, aspect, and terrain ruggedness. For terrain, there are additional rendering options, including shaded relief. Like the spot tiled imagery example, the rendering happens instantly on the client side. When working with a single band like terrain, the classify renderer is available, including the classification method, number of classes, and color ramp selector. It's important to address the unique visualization aspects associated with multidimensional raster data. Here I have a tiled imagery layer for surface weather and climatological summaries, or DAYMET, covering Colorado from January 1st of 1980 to December 31st of 2018. This multidimensional raster contains daily time slices for multiple variables, including maximum and minimum air temperature, precipitation, snow water equivalent, and more. Like the other tiled imagery layers we've examined, the image display options support client-side rendering, including stretch type, method, classify, color ramp, and dynamic range adjustment. Let's continue the streaming and rendering comparison, now with dynamic imagery layers. Back to the Spot 7 data. Unlike tiled imagery layer, the image is streamed from the server for the entire map extent of the request. Instead of having tiles streamed containing all bands, we get only the bands or bands requested from the client. In this case, a true color composite computed on the server. We can still observe the full bit depth for all bands with the Identify tool. And the ability for custom rendering is also found. The result takes a moment as it's processed on the server and delivered for the client area. And we can also select the stretch type. Next, let's return to the Colorado elevation mosaic, but this time as a dynamic imagery layer. The same visualization capabilities exist. For the elevation data, users can choose the shaded relief or the classify option specifying method and color ramp. Like the spot image comparison with respect to streaming, the main difference is in how the result is streamed to the client. It's important to mention now that one of the most powerful capabilities unique to dynamic imagery layers is on-the-fly analysis, which we'll cover later in the analysis demonstration. So far, we've been using a web map for visualization. The Scene Viewer is another way to visualize and stream hosted imagery layers. Here, I'm viewing one of my post-fire imagery layers draped over the 3D terrain. Visualization is also supported in web apps, notebooks, and even ArcGIS Pro. Back to you, Jay.
Thanks, Dave. Next thing we want to talk about is the powerful analytic capability offered by ArcGIS Imagery for ArcGIS Online. Now, you already know that ArcGIS is a powerful platform for image analysis. We already have a super rich set of analytic functionalities offered through our APIs, our desktop applications, such as image classifications, deep learnings, spectral analysis, suitability analysis, and terrain analysis, multidimensional analysis. Nowadays, we are bringing all these analytic capabilities into ArcGIS Online. In the upcoming ArcGIS Imagery for ArcGIS Online release, we'll have raster analytic capability in ArcGIS Online, which includes 27 ready-to-use tools under the analysis pane on our web app, and including the deep learning tools with GPU support. And we also have over 160 different analytic functions. And through the function editors, it allows you to use the built-in functions to combine and train custom analytic workflows. And all these workflows can support tile image layer and dynamic image layer as input. It can also support output to tile or dynamic image layers. And we also offer a preview capability to let you see the analytic result on the fly before you spend credits to run and generate persistent analytic output. And the credit consumption of analysis jobs can also be pre-estimated before you run the task. I'll hand it over to Dave again for him to show you the analytic capabilities that is offered by ArcGIS Imagery for ArcGIS Online.
Thanks again, Jay. Before diving into the analysis demonstrations, let's first consider two important terms in ArcGIS Image Online: on-the-fly analysis and raster analysis. On-the-fly analysis requires a dynamic imagery layer type. The analysis methods are defined inside of a raster function template from the Living Atlas, from your ArcGIS Online organization members, or custom built using a library of more than 160 fundamental system raster functions. On-the-fly analysis is a powerful technique for data exploration and model refinement to validate the output meets project goals. In contrast, raster analysis can be applied on either tiled imagery layer or dynamic imagery layer. Raster analysis persists its output as new hosted imagery layers, and users can choose tiled imagery or dynamic imagery layer type. Raster analysis also includes a powerful web-based raster function editor to customize your analysis, and a growing set of advanced image analysis tools that are ready to use on your imagery layers, all accessible from within a web map. Considering these two scenarios can be a helpful approach to understanding which hosted imagery layer type best supports your use cases. Let's return to the Cameron Peak fire scenario for some on-the-fly analysis using dynamic imagery layers. Within the image display options for the dynamic imagery layers, notice the blue Add button near the renderer control. This enables selection of a raster function template for on-the-fly analysis. I'd like to visualize both slope and aspect together using a template that's available in my organization. The function chain, which fully describes the processing, is sent to the server where the rendering takes place and the response sent back to the client. My layer is now dynamically processing all requests using this custom function chain. The result shows 8 different hues for the aspect direction, with color brightness increasing where slopes are greater. Raster functions can also be saved along with your dynamic imagery layer settings. Let's explore this capability using Sentinel-2 imagery for the post-fire conditions. Sentinel-2 imagery includes 12 separate bands, providing great diversity in image compositing and band indices through the visible red edge, near and short wave infrared spectrum. Using show item details, the layer's settings can be accessed, where raster function templates can be added. Thereafter, users of this layer will be able to quickly select and apply templates from the renderer control. Now let's explore raster analysis, which is truly a web-based image science laboratory to help you craft and evolve your analyses. The Perform Analysis button reveals the raster analysis capabilities, including 27 ready-to-use tools that deliver advanced analysis capabilities, including deep learning and multidimensional analysis. Raster analysis also includes the raster function editor, and 160 system raster functions that you can explore, add, configure, chain together, and save. Here, the raster function browser enables easy filtering and search for existing raster function templates. I'm loading into the editor a burn severity analysis that will use multiple bands from pre- and post-fire Sentinel-2 imagery to map out severity classes. I can explore the functions in use, verify that the necessary variables will be exposed in the dialog, and check my class names, values, and colors. After committing to the analysis, the dialog is presented, including the pre-fire and post-fire variables I made public. I provide an output layer name and choose a hosted imagery layer type for the result. But before running the entire layer, I can show preview to verify the expected result. I can also specify whether to constrain processing of the new layer to the current map extent or not, and even estimate the credits that this analysis will consume. I'm now ready to run this analysis. To save us a few minutes, I've skipped ahead to the processed result, a new tiled imagery layer with the burn severity classes applied across the entire fire area. I'm going to run a separate analysis to demonstrate the power of multidimensional data in ArcGIS Online. Returning to the DayMat layer, recall that we have daily slices spanning from 1980 to 2018. But as a part of fire recovery efforts, I'd like to have a precipitation forecast map for the coming months of rainfall. I'm loading another raster function template that makes use of the generate trend and predict using trend system functions to estimate precipitation through the end of 2021. I've set the necessary parameters and run the analysis. Fast forwarding to the result once again, I now have a monthly aggregate of precipitation statewide for the rest of the year. Having maps of burn severity and estimated rainfall over the fire area can help greatly in the recovery effort. An image science laboratory wouldn't be complete without Python notebooks. So let's add one more layer to the picture using the ArcGIS API for Python. We start by importing necessary libraries and packages, prompt the user for their credentials to authenticate with ArcGIS Online, and then load the dynamic imagery layer for elevation. Next, we'll construct the terrain ruggedness index model in code. Apply the color map values for visualization, and now display it on the fly. Finally, we can publish a new tiled imagery layer using code and load it in the notebook. Back to you, Jay.
Thanks, Dave, for the cool analytic demo. Next, I want to quickly go through additional client support and API enhancement for ArcGIS Imagery for ArcGIS Online. As I mentioned earlier, ArcGIS Pro from version 2.6 and up will support display and working with both types of image layer, including tile and dynamic. In addition to that, you can also directly launch image analysis task utilizing the built-in raster function user experience in Pro to ArcGIS Online and creating the result as a new tile or dynamic imagery layer. And we have also enhanced our ArcGIS API for Python to support layer creation workflow, visualization workflow, and analytic function construction and on-the-fly processing workflows. And you can also execute the image analysis task to generate persist output. And our ArcGIS notebook running ArcGIS Online also contains the up-to-date ArcGIS API, ArcGIS Python API for image analysis support. And the analytic result can directly be shared as hosted feature or imagery layers, both tile or dynamic out of box. Now we have covered all these capabilities offered by ArcGIS Imagery for ArcGIS Online. Next is to talk about how you can enable this capability. As of today, the ArcGIS Imagery for ArcGIS Online is only available on the 6 different regions in the globe. There are 4 regions in the United States, 1 in Europe, and 1 in Australia. In order to enable the ArcGIS Imagery for ArcGIS Online, you will need to acquire the ArcGIS Imagery for ArcGIS Online user extension license. And the user extension license also has to work with compatible user types. The user types are Creator, GIS Professional, Advanced, Basic, and Standard. And on top of the user type extension license, you need to grant privilege to the organization user in order for them to use the API and access the user experience on the web. The built-in user roles such as administrator, publisher, and facilitator will receive the privilege automatically. And if you want to create a custom roles, the privilege to grant to the user for create image collection is under the content settings group. For creating host or hosted tile or hosted dynamic image layer, there are separate privileges. And if you want to enable the image analysis for the user, you should turn on both the publish hosted layers, hosted feature layers privilege, and also the image analysis privilege under the premium contents settings group. And the cost for ArcGIS Imagery for ArcGIS Online is generated by these following items: the user type extension license, the compatible user types, and the image storage. The image storage is the image data stored in ArcGIS Online's hosted data store. And the capabilities additional capabilities offered by dynamic image layer is the cost of that is computed by a tier-based plan based on the image count on every dynamic imagery layers. For the usage of tile and dynamic image layer, there's no additional cost. And for the image analysis, the credit cost is computed per analysis request. And the organization administrator have access to the general cost through the organization status page. You can see the imagery storage cost credits on tile imagery layers based on the imagery file size that is referenced by the tile image layer, and also the dynamic imagery layers, the information about its imagery storage consumption, and also the image count per layers. And the same information is also available on each imagery layer items. And the image analysis cost is also metered. And the image analysis task, before it runs, it will compute the estimated credit cost based on the number of pixels processed, number of feature processed, and number of bands. Dimension slices are also the factors that will affect the cost of this particular analysis task, and also the complexity of an analytic function template. And last, let's look at all these different options you have to serve imagery data in ArcGIS. ArcGIS still offers the traditional approach for you to set up your own ArcGIS enterprise and image server clusters to support publishing of dynamic image services and perform parallel raster analytic tasks. Now, with the introduction of ArcGIS Imagery for ArcGIS Online, you have the option not to manage your own server cluster, but simply just upload your image data to ArcGIS Online to create imagery layers and utilize the imagery storage offered by ArcGIS Online and perform image analysis at scale. Alternatively to ArcGIS Imagery for ArcGIS Online, we also have another SaaS offering called the ArcGIS Image Dedicate. The ArcGIS Image Dedicate offers more control on the backend servers that supports Dynamic Image Server and perform raster analysis. And the services created by ArcGIS Imagery Dedicate can also be registered to ArcGIS Online and interact with ArcGIS Online services for image analysis. And we also committed to support open data standards. To learn more about ArcGIS Image for ArcGIS Online and ArcGIS Image Dedicated, please check out our product summary page. And there's also a lot of other imagery-related technical workshops available throughout the UC. Please check out these links for the topic that you're interested in. And thank you very much for your interest in attending our sessions. And if you want your feedback, please remember to submit the session surveys after the Q&A. Thank you very much, and we hope you're enjoying the user conference this year. Now let's move on to question and answer session.
Okay. All right, thanks everyone for joining us today. We have a lot of questions to get through, so I think we're just going to go ahead and jump right in and try and get through as much of this as we can in the next 15 minutes. So let's start with this question for, let's see here. Let's start with a question for Shay. Shay, an anonymous person asks, is there a data cap for how much imagery can be hosted?
So there is no data cap for the amount of imagery you host in ArcGIS Image for ArcGIS Online. However, you want to be cognizant of the the charges, the 1.2 gigabytes per credit per month for imagery storage. But we also recommend that if you have a massive amount of imagery data, let's say 5 to 10 terabytes. We have another product called ArcGIS Image Dedicated that is made for handling really, really large imagery collections. And that would be stored in the cloud. So it just seems to be more cost effective once you hit that point. So no data cap, but if you have a ton of data, there might be better options.
All right, great. Thanks, Jay. Okay, Dave, I'm going to jump into the question that seems to be on a lot of people's minds. Can you talk a little bit about the consumption of credits and how it can be estimated?
You bet. Great question. And as Shay mentioned, for tiled imagery layers and dynamic imagery layers, there's a fundamental hosting credit cost. That's 1.2 credits per gigabyte per month. So that's probably the simplest one to calculate out of the gate. Secondarily, with regard to dynamic imagery layers, there is an additional charge on that that's just based on the number of images. So it can go anywhere from 10 up to 160 credits per day. And that's really just based on the number of images that are available there to be processed on the server side. Finally, if image analysis is part of your set of use cases, there's a broad range of credit consumption that can come in from a very simple raster function chain to a complex one. And so some of the tools that we demonstrated today are your friend on that. You have the ability to constrain your analysis to a subset or look at the entire data set together and then estimate your credit consumption right in the app.
Great, thanks. All right, Shay, can you talk a little bit about how to go about getting ArcGIS image for ArcGIS Online? So is it included with your ArcGIS Online organization? Is it an additional license that's required?
So ArcGIS Image for ArcGIS Online will be an additional license you'll need to purchase. So you'll be able to purchase that license just like many other things in ArcGIS Online. But yes, it is an additional cost.
Great, okay. And then Jay, is downloadability going to be coming to ArcGIS Online, ArcGIS Image for ArcGIS Online?
So this is actually a frequent requested features for both tile and dynamic imagery layers. In the first release of ArcGIS Imagery for ArcGIS Online, which is where we are currently, Download capability is not supported yet, but this is definitely something that we want to work on and have available in the future releases.
Okay. And then I think similarly, are user-defined custom Python raster functions supported?
Yeah, also a very good question, and also frequent requested features. So some of you may be creating your own analytic algorithms utilizing custom Python raster functions, which you can upload in your enterprise environment and attach it to the image service or use it for raster analysis. So this is also something we want to work on for ArcGIS imagery, for ArcGIS Online. In the future releases, currently is not, there's no option for you to upload those functions and utilize them at the moment.
Something to look forward to. Okay, Shay, can ArcGIS Image for ArcGIS Online replace the need for utilizing image server in ArcGIS Enterprise?
That's a really good question, and I know that we've had a lot of questions surrounding that. So think of ArcGIS Image for ArcGIS Online as just a new way to work with imagery inside of ArcGIS. So it won't replace traditional image server, but it will be able to give you these capabilities within ArcGIS Online without having to set up infrastructure. So it really depends on your need. And then again, I've mentioned ArcGIS Image Dedicated. Is also a new product. And so really, if you're working in ArcGIS Online, you don't want to set up infrastructure and you just want to kind of work with some imagery, drag and drop into a browser, ArcGIS Image for ArcGIS Online is your best bet. But it won't replace, the bread and butter, image server capabilities on-prem that we have right now.
Great. Okay. Jay, let's see, are the imagery layers produced with ArcGIS Image for ArcGIS Online, will they work in a disconnected environment, like in field maps, or are they strictly ArcGIS Online?
That's actually a good question, but there's actually two parts in that question. One is whether the imagery layers you create in ArcGIS Online can be consumed by runtime-based apps, right? The answer is for that, if you have a live connection to these imagery layers to the internet, and the current runtime-based apps will be able to consume the dynamic imagery layer, but not yet the tile imagery layers. And on the other hand, if you want to bring those layers down for offline usage, this is also some new features we've been working on. Currently, it's not the runtime API itself does not support bring down the tile image layer or dynamic image layer for offline use yet. So it's something to look forward to as well. Yeah.
And while I've got you here, Christiane asks, can I upload a mosaic data set that's already been created instead of having ArcGIS Online create the mosaic from the individual rasters?
That's a great question. This is exactly something we are working on for the next upcoming release. So in the next release, you'll be able to just author your mosaic data sets in ArcGIS Pro, referencing the data as you have locally. And then through the Pro user experience, you can upload the mosaic data set itself with all the customization you made on the mosaic data sets, along with the data that it referenced to ArcGIS Online, and create a dynamic image layer out of that. And this is definitely something that we're actively working on, but currently it's not there yet. But just looking forward to the next release, you'll be available.
Great. All right, Shay, this user asks, can imagery from an AWS S3 bucket be used without having to download the imagery and then upload it to ArcGIS Online? So can you use imagery that's already in the cloud?
Yeah, I mentioned ArcGIS Image Dedicated earlier, and essentially that product has been created to work with your imagery that you have stored in AWS or Azure. So if you do have imagery stored in the cloud already, then ArcGIS Image for ArcGIS Online might not be your best bet, but we do have a product that will give you these same capabilities, similar to image server, that will be able to kind of connect with your imagery in the cloud that you already have stored.
Okay, great. All right, Dave, this user asks, can Python notebooks be used to load images, even cloud raster format images?
Thanks, Emily. Yeah, that's a great question. And using the ArcGIS API for Python, you can fully exercise these capabilities, not only loading and analyzing, but even hosting new imagery layers and conducting all of the same kinds of capabilities that we've demonstrated in the web maps.
Great, thanks, Dave. Okay, Jay, Azine asks, can we upload imagery to ArcGIS Online with a command line interface, so programmatically?
So this is actually already been answered by Dave. So we do have provide API, which is the ArcGIS API for Python, that allows you to exercise the like scripting or programmatic workflow to create hosted image layer, including upload data, right? But essentially, you can also utilize other tools through the our developer documentation and through the through some API that gets you the data store connection information, and use the native Azure upload tool to upload your data as well.
Great. Okay, let's see. Dave, after you create an image collection, can you add more images to it later?
That's going to be a great feature when we're able to add it. Today, once you've created a hosted imagery layer, it's immutable. So you're going to need to make change, you're going to need to republish.
Okay, that's good to know. Let's see, I guess this is for Jay. Is caching supported for dynamic image layers?
So the caching API was actually automatically enabled for dynamic image layers. So throughout the presentation, you may notice there are different ways to create your imagery layers. While you're looking at different mode to create a dynamic image layer, there's one image mode, one mosaic image collection, and batch publishing, right? Only except the image collection creation mode, all the other mode actually convert your data to what we call the cloud raster format. And with this format, the caching API for the dynamic image layer is automatically enabled. So only with the exception of the image collection creation mode.
Okay, great. Okay, another question for you, Jay. If we were to upload a DEM, could we apply on-the-fly processing to derive slope, aspect, and hillshade layers, and would those consume credits?
Definitely, you can. So we do have a additional UI options when after you create a dynamic image layer, where allows you to modify the settings of the imagery layers. One of the settings is to attach additional processing template, i.e. the raster functions, to the dynamic image layer. So you can definitely publish a DM dynamic image layer and create slope aspect functions template as the processing template of the dynamic image layer. And when you apply those on-the-fly processing template on the layer, it does not generate additional credit cost, right? On top of the storage cost that you should already consider for the dynamic image layer.
Great. Okay, let's see. Dave, do I need an ArcGIS image license to view imagery hosted in ArcGIS Online in dashboard or web apps?
No, viewing is not going to require the user type extension for ArcGIS Image Online. It's strictly for the creation of new hosted imagery layers or to conduct analysis in ArcGIS Online.
Okay, great. Okay, Jay, will the image collection support time sliders? So can it show 2018 imagery, 2019 imagery, then 2020 imagery, like a time-enabled feature layer?
The answer is yes. And not only the dynamic image layer that referencing an image collection can support time slider if the image collection has the time information, right? You can have multi-years, for example, you can have multi-years of Landsat data. When you create a image collection dynamic image layer, the time information is automatically put into the mosaic data set behind the scene. And therefore, the layer itself can support the time sliders. And not only that, but also you can create multi-dimensional raster, which has a time information as its multi-dimensional properties. And that with that kind of layers, even if it's tile image layers, you can also support time sliders.
Great. Okay, and then another question for you, Jay. Do you support the full capabilities of Mosaic data sets? So I would like a SaaS solution, but I also want the control that Mosaic data sets give to color balance and composite drone imagery with aerial photos.
Right now, I think this question is referring to full capability of all different kind of operations you can do with a Mosaic data set. If you're comparing with Pro today, ArcGIS Online actually doesn't provide all those different tools or user experience allow you to work with Mosaic data set. We do have a limited set of tools that allow us to perform color balancing, generating sim lines. But it is just a subset of what we can do with Pro, right? And but eventually, once we support publishing Mosaic dataset directly from Pro, you will have all this capability to do your customization in Pro and then publish the Mosaic dataset by uploading it to ArcGIS Online. Yeah.
Okay. And then let's see. One more for you, Jay. You mentioned a multitude of image formats are available in ArcGIS Image for ArcGIS Online. Is the imagery stored in their native formats as hosted tile image services or CRF?
Yeah, so again, it depends on what kind of creation mode you choose while you're creating your hosted imagery layers, right? With only one exception, which is when you're creating a dynamic image layer with image collection mode, we will preserve the original uploaded data format. All the other creation mode will actually converge your upload imagery data to our optimized cloud format, what we call the cloud raster format.
Great, okay. And here's one more question for Dave. How much does the CRF format compress? I assume it works with 3 and 4 band images.
Yes, so we can use 3 or 4 because CRF is going to encapsulate the entire data model. So we're also going to get all of the bit depth that's present within that input imagery. And as far as compression ratio, it really depends on the incoming raster content. So we can look to providing maybe some benchmarks around some well-known standards, like a striped TIFF, for example, and maybe a few other scenarios that could help gauge and understand the expected compression ratios.
Great. All right. Well, I think we're about out of time for questions. I know we didn't get to everything. We'll try and answer more if we can, just privately. And then if you still have a question, definitely reach out to any of the speakers or additional experts that are listed below the video by clicking on their tiles. We really appreciate your feedback. And we hope you'll complete the session survey via the link below this video window. The recording for the video should be available as soon as it's processed right back here. I think you can access it using the same URL you used to find this, this session. We really appreciate all of your attendance, and yeah, we look forward to talking with you more for UC. Thanks, everyone.
Thanks, everyone.
Thank you.
Group. When we talk about imagery, we're talking about it usually quite generally. Can you guys chime in on that?
You know, we
Maybe
do
Richard,
use
you could start us off.
Yeah, sure. We do use the term imagery fairly broadly at Esri because it really encompasses a fairly broad range of data types and collection platforms. So optical data like U.S. Forest Service presentation this morning from Landsat or Sentinel, or some of the commercial providers like Maxar or Airbus, but it can be spectral data or radar data, even video data. And then it can also be rasterized data like temperature and elevation or point clouds. And it's really taking us beyond just, historically what we've looked at as 2D imagery now to 3D and even 4D as we're able to add the time dimension, which Vinay will talk about. But it moves us from a static representation from a single point in time to really many representations across time. And that is really where time is starting to be defined more, even daily or even multiple times daily, depending on where that data is coming from, what platform it's coming from.
Richard, thank you so much. I love that. That was really descriptive, and it helped me a lot. So for those of you who are able to get to our poll, I want to review the poll results right now. So what exactly are we seeing in our poll? And you know what? We might just end up throwing it up in a few minutes. So in this way, I want to start us with another question. So thinking a lot about all of these things, I'm realizing the reason I probably haven't used a lot of imagery and AI is because I work on animal movement, as you guys know. And animal movement is often super dynamic, whereas imagery is quite static, right? It's a picture, essentially. But when I was a student, remote sensing was a separate subject with different software. I remember that as we had spatial analyst as a tool, which could do some suitability modeling and other raster analytics. But can you guys tell me, we'll start with you, Peter, what has changed?
Well, a lot has changed in the last 10 years. I mean, we realized that imagery was going to be the real next big data. And the volumes of imagery were increasing massively. So we focused initially on the server component, the image server, and the management and providing accessibility to the data. We then added ArcGIS Pro, when ArcGIS Pro came out, we added the image capability to process imagery and do analysis on the imagery. And then what became clear is that the volumes of data were still growing even more, and it was going to be impossible to actually visualize that data. So we really looked into adding deep learning capabilities and raster analytics and to sort of scale that up, and then also transitioning things into the cloud, moving this capability into the cloud. So now we really have highly scalable deployments both in ArcGIS desktop, in enterprise, and in online. So that's really enabling us to scale this up. And we also added dedicated, which is the ability to spin up this compute right next to storage, massive storage in the cloud, and then perform processing analysis. So we really got to the point that we're really integrating both the imagery and the raster data together to work really seamlessly together. So really, and scale that and make that really shareable.
I love that. Okay, so what I'm learning is that I have some options on how to manage and deploy. And so also in the plenary, I saw all different types of analyses. And so, could I use some of these to do biodiversity monitoring? And so, Vinay, I want to toss that one to you.
Yes, absolutely, Ray. Image analysis is really about extracting meaningful information from imagery so that you can make actionable decisions. So let's start with the work that you do, which conservationists do.
Great.
You need to perform landslide analysis or susceptibility analysis, identify areas that are susceptible to certain types of phenomena. You need to identify or perform suitability analysis, identify locations where certain types of habitats are most suitable to live in.
Exactly.
So for all of this, you need to work with imagery, different types of imagery, landscape layers, elevation layers, optical imagery, and more. There's a lot of imagery that you need to work with. Climatologists and ag experts, they're seeking to understand trends and perform predictive modeling. To do this, they need that additional dimension of time. You get that dimension of time through multi-dimensional data sets. So there's so much that you can do with imagery.
Sure.
In the plenary, the demos that you saw this morning, the first two demonstrations, the first one was the United States Forestry Services. They built this forest inventory from a temporal stack of images, from a temporal remote sensing record using machine learning algorithms. Super stoked about what I just saw there. The ArcGIS image presentation was automated feature extraction, which was a basis for everything that I just talked about.
Sure.
To perform workflows like urban planning, flood modeling, landslide susceptibility, and so much more. Now, what I'm really excited about is how that technology really scales, right? I do not have to worry about the infrastructure. You do not have to worry about the infrastructure.
Right.
As an analyst, as a user, and you as a scientist, all you need to focus on is the science and not the infrastructure.
That's fantastic. I love that. And I would love to loop Richard in on this conversation as well. Richard, what are your thoughts?
Well, I think as the guy on the business side of things, we're really seeing private organizations starting to look at ways to implement sustainability programs. And in boardrooms really around the world, we're seeing organizations start to recognize the threat of climate change to their long-term viability. And so they're implementing these sustainability programs, and they recognize that remote sensing data is going to be foundational to developing those programs, implementing them, and then monitoring them to make sure that they are having the intended effect. So it's really getting outside of just the science and research communities and into the boardrooms and management teams of corporations around the world. And it's really exciting to see that.
Oh, fantastic. Oh, I really love that. You all are giving me so much to think about. And it looks like I have a lot of learning to do as well, which is a bit intimidating. But I wanted to actually change the subject a little bit to drones. So one of the projects I was hoping to do was capture a detailed model of the topography of the landscape that I'm working in. And in the past, this would have been time-consuming. It would have been expensive, just a real to-do. But in the plenary, there was a presentation on something called site scan. So could I use that to monitor, for example, wildlife corridors on a landscape?
Yep.
So Richard, what do you think?
Absolutely. I think drones are the perfect tool for you because they're really democratizing access to imagery and LiDAR data in a way that you really can't replicate from an aircraft or a satellite collection. And they produce amazingly accurate ortho photos for those of you who are still working with 2D imagery, but also incredibly dense point clouds that you can perform analytics against, and 3D meshes that you can do incredible visualizations and immersive. If you saw the 3D demo this morning with Adrian, those meshes came from SiteScan. They were processed by SiteScan, and they created those immersive environments. But for you, and to your comment earlier about it being static, what drones really can give you are higher resolution data that you need to see what you need to see for your work, but also at a higher refresh rate. More frequent collects to allow you to get a more granular temporal view of the area that you're studying. And together these things create both a near real-time operational awareness kind of situation, but also a temporal data stack for analysis. And really SiteScan gives you the full end-to-end solution for that, to plan your flights, collect your data, manage your drone fleets, process that data, and then bring it into ArcGIS for your analysis.
Yeah. But Richard, really, we shouldn't really forget about the inspection workflows as well. I mean, really, many organizations are collecting imagery from drones, mobile, terrestrial sensors, including obliques, 360, and street side images. Really, they're using this not only to create 3D products like meshes and DTMs, a great example today with Telluride, but they're actually capturing this data as a snapshot in time to really use that to determine the assets today, or to collect the imagery to use later as change detection to see how things have changed. So this is really where the tools such as quick capture and oriented imagery really come into their own to support that different type of modality that most people don't really realize as well.
Yeah, I can tell you want to jump in as well.
Oh yeah, it's really, now based on what he said, it's exciting to see how all the imagery being collected is being used to perform trend analysis, identify trends, and predictive modeling. What really tickles my attention is how our AI has really evolved at Esri over the past couple of years. We started with integration with third-party modules. Then we've got tools, intuitive tools, which is developed in desktop and then in enterprise. And now at the plenary, you saw it, it's available in online as well. And now what we've introduced is pre-trained models. with pre-trained models, you no longer have to worry about infrastructure. You no longer have to worry about compute, and you don't need the expertise to train a deep learning model. You can use that pre-trained model directly with your data, right? And in fact, today, what I want to announce is we released 8 new models, deep learning models.
Oh, wow.
Pre-trained models. It's available on the Living Atlas.
That's a big deal.
Yeah, yeah. And in fact, the presentation that you saw this morning, the ArcGIS image presentation, they use these models to extract features. They extracted land cover map, they extracted building footprints, they extracted roads. Essentially, they created their geospatial, their foundational geospatial database ground up using raw imagery, right? So I am super stoked about what lies, moving forward, what's going to be there.
Yeah, well, now I'm, geeking out a bit about that because that makes me really excited. And speaking of the future of NA, I'm curious, and I'm sure so many of the users out there are curious, what does Esri have planned for the future? What's coming up next? Peter, can you tell us?
Well, I mean, we've really broken imagery out of its silo and integrated with all other forms of spatial data. And we really need to focus now on ramping that up, scaling both the imagery capabilities up. And much of the effort is also going into working with imagery partners. So these are providers that enable us to create integrated solutions with imagery and analysis that really enables anybody to access the imagery that they need and perform analytics. So this may be from archived imagery, but also other imagery that's new imagery and archived imagery. So we're really basically making imagery part of what I would refer to as the spatial information nervous system. It's just where we're really going to.
A spatial information nervous system. And Richard, I know that you could talk to us so much more about this as well. It is actually time for us to go back to talk to Nick. He's leading us into more tech sessions. And so for those of you who joined us for this conversation, I'd like to thank my guests so much. There is so much that I didn't realize was going on with imagery, so I have to get on it. I know my homework that I have to do. But heading back to Nick. Nick, please take us to whatever is next.
Thank you, Ray, and also thank you to Richard, Peter, and Vinay. That was a great conversation, and I hope just adds more excitement around imagery. Before we get into the last tech sessions, a couple of different things. I talked about the UC Run, Walk, and Bike, the virtual one. This is something that's available. You can find it on the homepage. And what we're trying to do, we can't get together as we always do, but get out there. We did this last year. Over 4,000 of you went out and did this last year. And we really want to just encourage you to get out this week, record your information anytime between now and July 18th. Log your trips. And we really have a goal again of like, can we log enough miles or kilometers to go around the world? Now, tech workshops. We're still having issues. We've got some good news, some in-between news. Some of them are working, so try them out. If there's no video, the team is still there and the chat will be working. So they're there to talk to you, even if the video is not running. And then also, again, all those videos will be published later. And the final thing today is as you poke around the 15 sessions, what you're going to find at this time slot, and hopefully they work, we've got a set of lightning talks from some of our partners. So if you want to give that a look, please do. Come back in an hour and see the gang at Mappy Hour.
These components include where services as well as data repositories.
with Experience Builder. You can select
Kubernetes is capable of providing high availability
maps. Next, GLTF and GLB are powerful file formats that can be consumed now by many tools in ArcGIS.
This can help guide you to select the one that best suits your organization's needs. Let's review in more detail the simple automation deployment tools that are currently available. We will first review the ArcGIS Enterprise Builder, then we will demo 2 cloud deployments, one using the AWS Cloud
The capability to render stylization of content as well has been added. The ability to render solid edges and also sketch edges. You can see an example of this in the center of the screen. And lastly, the capability to colorize last data. There's an example of this in the lower left hand of the slide. Additionally, extending or bridging ArcGIS with Unreal and Unity through the use of ArcGIS Maps SDK for game engines. This lets you merge your data and render it with all the fidelity of a game engine. And you can use things like physics, simulation, visual effects, and animation as well. The use of game engines opens doors to enable the creation of GIS for immersive technology. Technology like the Oculus, HoloLens, or other augmented reality capable devices. Let's go ahead and look over some of the options available when utilizing the game engines. First, the ArcGIS Maps SDK for game engines, specifically for the most popular game engines available today, Unity and Unreal Engine. This SDK enables you to leverage the full power of the game engine by streaming in tiles and features. And next, CityEngine workflows to cater and produce AR and VR content. CityEngine performs direct export of Datasmith and other file formats like FBX. These files can easily be consumed in Unreal Engine to further build out your experience. CityEngine also provides the use of ready-made templates that will enable you to quickly produce game engine-ready experiences. And let's look over some options in our platform to create one of these experiences. First, we have ArcGIS 360 VR. Some of its notable characteristics are it's very lightweight. It's easy as CityEngine's file export capabilities. So you can easily export this 360 VR experience. The web app has two modes. The first mode is an on-screen experience in the browser or preview mode. And the second mode can flip to a stereo mode for viewing in a VR headset. And lastly, it's all browser-based and runs in a mobile browser. Second, the CityEngine VR experience is a premium VR app for both HTC Vive and Oculus Rift. If you want, there's a couple links in the lower left-hand corner of the slide, and you can learn more about this at one of these links. These VR apps enable you to create an interactive tabletop experience using realistic effects, interactive tools like Measure, and even perform lighting analysis. And lastly, with ArcGIS Runtime, you can take advantage of device sensors, overlay on backgrounds, and even do stereo display. Being able to cater content using animation, such as keyframes and overlays, text and images, and even live data. All these things help you cater or create a story with your GIS content. Some of the highlights are being able to keyframe the camera, then enhance your story with triggered text and overlay elements. Things like dynamic text that is driven with data, descriptive images, and even shapes are all possible. Further storytelling of your data by animation and analysis tools like the View Dome, View Shed, and Line of Sight. And lastly, the ability to export animation as a movie or sequence of images to upload easily to YouTube, Twitter, or even share via email with an animated GIF. In fact, many of these images on this slide, actually all of them, were created with ArcGIS Pro and other tools across the ArcGIS platform. In the lower left-hand corner shows ArcGIS Earth's capability to animate exploratory analysis tools like Line of Sight. This is something Phil will show you later, and I think it's a really excellent feature.
Thank you, Steve. All right, so now we're going to move on to discuss some analysis capabilities. Now, just a disclaimer, this is by no means an exhaustive review of some of our 3D and analytical capabilities, but moreover, a bit of a broad overview and touching some of our recent improvements. That we actually have 2 3D analysis sessions here at this virtual UC, so I just urge you to search for 3D and analysis, and you'll find a workshop that'll walk a little bit more deeply through interactive analyses, and another that will be focused on LiDAR classification. So speaking of LiDAR, some of the things that you should be aware of is ArcGIS Pro actually has a great wizard for the classification of LiDAR, which is really useful in order to identify if a LiDAR is, if a point is specifically ground, building, overlap, noise, or you can classify vegetation by height. The video here on the top right is showing a profile view. And you can see I just drew a line, and in that line, what it's doing is creating a small subsection, a slice that you're able to cycle through horizontally in order to see really what that looks like in terms of a profile view. Other useful things, feature proximity, which is also useful for classification depending on how close things are to others, and then colorize last, which is just a beautiful tool for GIS organizations that may be sitting on some LiDAR that doesn't have RGB values. Well, now you can pair that up with an orthophoto and provide RGB values within your LAS and publish that as a colorized point cloud scene layer. And you can symbolize by those RGB values instead of just the elevation source. Something else that I want to bring your attention to is, you might have seen this in the plenary last year, but what this is highlighting is deep learning within point clouds. And so in this case, what we're identifying here are trees. And this is something that's been included, a workflow that's been included into the 3D base map solution. But this is also highlighting a workflow where you can utilize deep learning and machine learning workflows now with LiDAR. And I thought this was just a useful way in which to be able to represent that. And so now we can extract specific features, trees in this case, and display them here easily within the scene. Another utilization of deep learning and machine learning here is object detection. So this is an exploratory analysis tool that's now available in ArcGIS Pro. And what this does is we have a model that's trained to identify windows and doors. And what it's doing is taking the image of the screen space here and working through a bit of an object detection workflow where it is then able to specifically identify where those windows and doors are. So exploratory analysis tools as a part of 3D analysis is really, it's an interesting idea that ultimately a lot of your analysis is going to be something that where you're interacting with the scene, where you are asking questions of a scene within 3D. It's a little different way of thinking about it than 2D, and providing some of these tools here, line of sight, view dome, view shed, slice, cut and fill, elevation profile, or object detection, as we had just seen, is a great way to be able to understand a little bit more deeply what you might have in your scene. Information about elevation or data that you can possibly find about, how big is that hill there? How much debris would we have to move in a disaster response scenario? All of these things can be really useful ways in which to be able to answer questions. And Steve is going to present a demonstration that might help you to identify how you might incorporate these kinds of interactive exploratory analysis tools.
Once again, my name is Stephen Heidelberg. I'm going to be giving you a short demonstration on exploratory analysis tools. For the sake of time, I'm going to show you how to utilize the viewshed. Although many of the properties or capabilities with the viewshed is also configurable utilizing other exploratory analysis tools such as view dome and line of sight. So here we're looking at Midtown Manhattan. Specifically, the textured building in the center of the view is 432 Park Avenue. We're going to go ahead and utilize a viewshed to help us evaluate the cost of a view from one of these condominiums. The average price of each of these units is $18.4 million. Each floor has about 8,200 square feet of livable space, and many of these floors are broken up into 2 luxury apartments. There's 147 apartments total, 122 of these are luxury. I also want to point out this is the 3rd tallest residential skyscraper in the world. So the views from the top of this building are unobstructed. They're going to be very expensive. But some of the views from the lower floors or mid-level floors are going to have obstructed views. There's some buildings in front of them. And we can utilize a viewshed to determine how much of the view is obstructed. And the way we're going to do this is utilize observer from camera. So we place the camera in the point of the view or the window. We've created a viewshed. We're then going to change the maximum value to engulf Central Park. What we're seeing in green is the visible space, and in red is the obstructed view. So you immediately can tell that there's some problems in the front of Central Park. For example, if you are a fan of looking at the zoo, for instance, it's completely obstructed by the building in front of 432 Park Avenue. We can also go ahead back into properties, make adjustments, and immediately see the feedback. So everything is interactive as well. Next up, we're going to go ahead and take a look at utilizing viewsheds via layer. On this layer, there are 2 points. These points sit on traffic cameras in the intersection. Each of these points has associated inputs in a table, and these inputs help us configure the viewshed. So what we're going to do is we're going to select from layer, select the layer with the points on it, which happens to be camera viewsheds, click apply, and we immediately get the configured viewsheds. This means you can go ahead and share this layer and other people can come up with the same results or similar results of the viewsheds in their own project. We've also utilized the range slider to push a car through the intersection. What we're doing here is we're looking at what's visible and obstructed when this car passes through the intersection. The green, once again, is visible. The red is obstructed or not seen from the cameras. And then the small sliver in the center is overlapping views from these cameras. Once again, as I go ahead and modify these viewsheds, you'll notice that everything interactively or quickly updates. And the yellow now is showing what's overlapping. It's a larger space. We can play back the range slider, interactively see what's now obstructed or visible via the camera locations.
Okay. Now, I just want to round this conversation out with 3D analysis with an overview of, and to ultimately make this audience aware that we have a 3D solution set. And what these are task-based workflows in ArcGIS Pro that ultimately help you to either extract data, as is in the case of the 3D base map solution, or run very large analytical processes and help to automate them so that you have a distributable analytical result that you can then share. The 3D base map solution is one of our more popular solutions, and basically what it'll do is it'll walk you through the process of extracting buildings with appropriate roof heights from LiDAR data, as well as vegetation, ground, and other features. And it's a really great way, say, for a local government who's made the investment in LiDAR to really derive a lot more information and value from that LiDAR. 3D Tools for Power Lines brings in procedural rules packages in order to appropriately symbolize those power lines. And what you'll also find in that is the creation of where the line may sway. So that's really useful for vegetation encroachment workflows. 3D flood impact solution, of course, will help you to identify which buildings end up impacted in a potential flood event. And a visibility assessment solution is a section of those development impact tools that will help you to identify not only like a view shed, which will identify where a single observer can see a larger area and what it is that they can see, but it's more area to area with obstructions in between. And we've recently been able to incorporate integrated mesh into that workflow. All right, so voxels is kind of one of those that we placed in the analysis section this year, but I think next year we'll actually put it into data management. Because in this case, what it is it's a way to visualize large volumetric data. You can think of it ultimately as a 3D raster. You can apply transparency gradients to focus on specific data, to create multiple slices when moving or creating rotatable planes. You can cut and create isosurfaces of some specific areas. And you can also interpolate with 3D empirical Bayesian kriging and present that as a voxel, or space-time cubes can be presented as a voxel. So there's a lot of improvements that have been made recently with the Voxel layer. And this is a great time for Yvonne to walk you through some of the more recent improvements. So with that, here's Yvonne Seller with a presentation on voxels.
As Phil mentioned, there are many different phenomena that can be visualized as voxel layer. You can create voxel layers from regularly gridded NetSDF files like this one of the Atlantic Ocean. In this particular NetSDF file are variables like salinity or water temperature. You can choose water temperature as the default variable to visualize first when adding the layer. A new option in ArcGIS Pro 2.8 is to optimize for performance. If checked, the data will be cached at the same location as the NetSDF file, allowing for faster drawing performance. You can visually analyze specific temperatures at different times of the year using surfaces, like isosurfaces at the temperatures of 25 degrees Celsius. You can add an isosurface for 20 degrees. And an isosurface for 15 degrees Celsius. You can combine the isosurfaces with sections. Because this layer is time enabled, you can lock specific sections at a time, and when you run the time animation, this locked section will only show at the specific time that it was locked at. You can apply transparency to the different isosurfaces, so you can see the isosurfaces and the sections together. the voxel layer gives a better picture of the temperature distribution in the Atlantic Ocean. You can create animations to share with your audience. You can animate the data range, time captured in the voxel layer, or the time together with the slices and the movement of the slices. Also, geological models can be used as voxel layers, like visually analyze the underground of the historic village of Cameric in the Netherlands. The geological model of the Netherlands from TNO is freely available. It contains soil types as discrete voxel cubes. The underground of Cameric contains a lot of peat. Peat is an organic matter that expands and shrinks depending on the amount of water it absorbs, causing damage to the buildings. You can use the voxel layer to define an area of interest just for Cameric. You can slice the voxel layer to the extent of the village. If you're interested in a particular building, you can create a section underneath. And, for example, use the measure tool to measure the thickness of the peat layer. This scene can be used to create a layout and print it as a PDF, for example. You can create your own voxel layer using the geostatistical analyst. From a 3D point feature class, you can use the geostatistical wizard with 3D kriging interpolation and create a GA layer. You can convert the layer into a NetSDF file that then can be used as source for a voxel layer. By viewing the volume with semi-transparent symbology and the isosurfaces of the temperature, you can change the values of the isosurfaces and explore the changes of the temperature interactively. Other data you can visualize as voxel layers are spacetime cubes with fishnet geometry. You can change the symbology by defining data filter to only show some of the voxel cubes. Or apply transparency, for example, to emphasize on important values within the spacetime cube. You can also convert multidimensional raster into NetCDF files and use them as voxel layer data source. All examples I showed you today and many more you can find in our Learn lessons, and try working with voxel layers yourself. Thank you.
Thank you, Yvonne. All right, well, this next section is going to deal with 3D content creation, editing, and data management. This is a broad overview where we'll discuss scene layers, we'll discuss some more recent improvements that have occurred within ArcGIS, and first we'll begin with the point scene layer. Now, obviously here, what we're seeing are points. This is an example of a space-time cube that's showing monthly water consumption in the city of Redlands. And so in this, what we're seeing is the ability to style those using scene layer styling. It's a kind of a smart mapping, so there's an attribute within it that we're using that is representative of the amount of consumption per month water consumption, and we're able to utilize that styling in order to represent the information product that we like. And you can serve large volumes of points here performantly based off of this new 1.7 spec that we've just created. This is an example of the kind of performance that you can have there. Now these are points, 150,000 points that we derived from the 3D base map solution based off of LiDAR. And all of these, within this, we actually have that point as containing a height attribute that we're using to symbolize these trees we've identified the species, and we're utilizing a 3D web style here in order to visualize this large volume of point or web style symbolized points. And that's type of thing that you can do with a point scene layer. All right, the 3D object scene layer is a classic scene layer, one of the first ones that we came up with. What you're seeing here in this video is New York City, and not just Manhattan, but the 5 boroughs being streamed over the web to a browser, as well as all of the vegetation in New York City. We have styling that's associated with it. You can see outlines, or you can see sketch styles. And these 3D objects can also contain textures, so the images of the sides of the buildings can be joined here to it. And it's a great way to be able to serve large volumes of 3D content performantly, and to have some of the option of styling and symbology as well. All right, point cloud scene layer is a way in which we're able to serve large volumes of not only LiDAR data, but photogrammetrically derived point clouds. And in this case, we're serving a very large volume of LiDAR content for an entire state here, in this case, the state of Connecticut. And this is being served over the web. And as you zoom in, you can see multiple levels of detail showing, depending on how close it is to the area that we're trying to see. Point cloud scene layers can be symbolized by their color, by classification, by elevation, and also by intensity. The integrated mesh scene layer, we often think of this as the skin of the earth model here. It's a combination of the geometry and then the imagery that is then kind of applied to that geometry. Integrated mesh scene layers are typically derived from photogrammetric sources. So drone to map and site scan, for example, to drone-based mapping softwares will produce this kind of integrated mesh. We have partners that will produce large volumes of integrated mesh at the scale of the city, and we also have a software package that with N-Frames Sure that will process large volumes of will create photogrammetrically created integrated mesh here in order to provide a real accurate representation of an area that then can be used for other things. Like, for example, with this example here, it can be used for data management workflows so that we're able to incorporate a workflow now within ArcGIS Pro, which is called mesh modification. And what this allows us to do is to mask, clip, or replace integrated mesh so that we can then share this over the web for a very specific area of interest, or we can flatten. We can also flatten this using the replace command here, which what this will do will highlight a polygon area, and that will then flatten this so that it could then potentially be replaced by another design. So what if type of scenario if we were to remove this and replace it with a 3D object of a mock-up of another type of building, for example. So integrated mesh can also be used here in Scene Viewer with this is a stylization where we're able to drape 2D polygon content and points lines as well over integrated mesh. So these are parcels that have predicted energy use consumption placed or as attributes within that. So essentially what we're just doing here is highlighting those parcels and selecting parcels, and it really gives the feel of having selectable individual buildings here. But this is really just a combined visualization between that polygon layer and that integrated mesh layer. All right, building scene layer. So a building scene layer is ultimately that ability to consume Revit Autodesk as a data source. This is what architects use to design buildings and infrastructure, and then to consume that as a data source in ArcGIS Pro, and then publish that so it can be consumed on the web or by other clients like ArcGIS Pro. In this example, one of the recent improvements that we have is the ability now to search the building scene layer so that we can identify a specific field that we're looking for, and we can find searchable artifacts within this building scene layer. So you can identify rooms, floors, specific pieces of infrastructure, and really be able to comb through the detail of that building scene layer and more deeply understand some of the data that you're working with. Feature layers do also play a major role within 3D, and these are highlighting a couple of examples of smart mapping within Scene Viewer. So the bottom left, what you'll notice is that we have water styling that's associated with that. That's associated with just a simple 2D polygon feature layer. It's an option that you have within Scene Layer within Scene Viewer for how it is that you want to display those polygons. The top right, we're showing an extrusion styling. So there's an attribute within this polygon feature layer data set that will help for us to identify what the height is, that we can then extrude those footprints and build a very simple building model here and understand really with just some data that may be pretty common within your organization. And one other piece here is the ability to do line tubular extrusions here, so that if you are a utility, for example, or local government, in this case, storm drains, this is a data set that has been maintained for years that identifies some of the maintenance information, but also some of the physical structure here. What's the diameter? What's the size of these pipes here for storm drainage? Well, now you can take that 2D feature layer and extrude it by those attribute values and really have a great way of being able to symbolize some data that you may have had all along here in 2D. So feature layers are also really useful for real-time mapping. Using GeoEvent Server or Velocity, you can read streams of that data and have that influence and edit those feature layers. So in the case of interior positioning within a campus environment, we're able to display tracked entities within that campus environment. It's all a matter of setting that refresh interval within the item visualization tab. So another thing about feature layers is that they're ultimately very web configurable. You can configure these parameters in item visualization tab, just like you're used to working within ArcGIS Online all along here for 2D feature layers. Pop-ups, billboard symbologies are options. You can use multi-field filtering. You can modify that extent filtering and also set a refresh rate, just like you can using the same tools that you do within 2D GIS, that item visualization tab. That helps to really set what that polygon point or line is doing here in this case. So this is big news for us here. Editing in Scene Viewer, that's coming in this release, this UC release here. So now this is something that you're able to do directly within Scene Viewer. You can hit a feature edit template that you have defined, and now you can then use in feature snapping and snapping to other features in order to very quickly be able to draw point lines and polygons using feature layers. In the top left, you'll notice we're actually moving a point feature layer that is visualized by a web style, but we also have the option with those handles to resize this. So we think that presents a lot of opportunity for utilizing LiDAR as an asset collection mechanism. Here in this case, using that LiDAR data, we're just sizing those trees to be that appropriate size as a feature layer. And in the end, these are points, lines, and polygons, so that you can be aided by the context of 3D, but you could ultimately make a printable map with the data that's created from this that you can then share from 2D, even though this experience occurs within 3D. So we also have some scene layer data management improvements that are recent here since the last users conference that we just wanted to make you aware of. First, integrated mesh to multipatch will extract textured multipatches from photogrammetrically generated integrated mesh for individual feature management and more analysis options. You can't really use integrated mesh as an input for a lot of analysis options, but here in this case, you can extract using say a building footprint, for example, and create multi-patch from that integrated mesh so that you can then use it for a variety of analytical workflows. We also have an I3S update GP tool that you should definitely be aware of. So I3S is again the mechanism that we use, the specification, the open specification that helps to define how we're moving around large volumes of 3D content. And we upgrade that specification frequently. And in this case, it can dramatically improve the performance so that if you want to check to see that your scene layers and scene layer packages are at the most recent spec. And this tool will help you to convert that to the more recent spec. We're now able to clip scene layer packages. So this is one that's been frequently requested of us, and we can clip and easily distribute data, as we're seeing here in that in the image below, the video below. This is just an example where we're using a 2D polygon to identify the clipping area for that larger set of integrated mesh, so that we can just have a smaller scene layer package that we can distribute in a variety of different ways, kind of a clip and ship workflow, or it can be used for mobile devices, for example. And finally, project scene layer package. This is, frequently we have our customers have projection requirements. They're working within state plane or may require a different projection than what the data may come to from, say, drone to map or site scan. And now using the project tool, we're able to incorporate scene layer packages into that so that we can provide new projections and coordinate systems. Okay, we're near the end of our presentation, and ultimately I wanted to summarize by going over some of the products that in ArcGIS that support 3D workflows. So we've been talking about ArcGIS Pro, either if it's been Stephen describing some of the visual influences that are important and achievable through ArcGIS Pro, or Yvonne's demonstration of the Voxel Layer. ArcGIS Pro is the powerhouse desktop clients that's the origin of a lot of authoring experiences. There's other sessions here at UC that we urge you to go and check out. Also, CityEngine is the procedural engine that's used for entertainment purposes, for creating an entire city, or for development and for planners and developers. There's a lot of news with CityEngine that you can see here with this additional link. We have new plugins for Rhino, Unreal, and Maya, Houdini, and PyPRT. And we also have a ArcGIS 360 VR experience that can be launched from CityEngine. ArcGIS Earth is the desktop client and mobile client that's utilized in all the way from intel agencies to education in order to be able to consume I3S contents and web scenes, and also to be able to manipulate KML, or in this case recently with Earth Mobile, the ability to record GPS. A scene viewer is the authoring application, the scene authoring application and viewing package that's available in ArcGIS Online and Enterprise. And we've talked about a lot of great improvements about the ability to consume and edit layers just recently. And of course, there's a series of apps across the ArcGIS platform that either contribute to developing 3D data or consumes 3D data, content, and scenes to be able to produce distributable applications and experiences like story maps and experience builder, as well as instant apps recently released. ArcGIS Urban is a 3D application that's used to orchestrate urban development and planning workflows. It is a central portion of understanding where local governments grow from here, especially as they consider how zoning is impacted by 3D. And of course, we've got a lot of we have a lot of features that we've rolled out here this UC that you can see in the left list, and we also have some things to come. Notably, we are expecting to see a voxel scene layer for the web here in the not too long term in 2022, at the beginning of 2022, as well as the ability to edit and publish 3D object feature layers, which can contain material properties and have better support for that and other analytical purposes. So with that, we look forward to taking your questions. Thank you.
Hello, everyone. My name is Lindsay Weitz. I'm here along with Philip, Stephen, and Yvonne to answer some of your questions today. So we'll get started with a few questions that have been coming in through the presentation. First, I'll start with, where would be the best place to learn more about 3D capabilities in ArcGIS? Yvonne, do you want to take that one?
Yeah, there are multiple ways, of course, that you can learn about 3D, but one that we would recommend is that you go to our Learn lessons and you look for a specific one that you would like to have. For example, we have different ones for voxel layers, but also for BIM and for sharing a scene to the web, for example.
Yep, and also I'll add that, the help systems for Pro or any of our other applications are also a great place to start. Thanks.
It's learn.arcgis.com.
Yep. All right, is there a workflow to go from ArcGIS Pro to VR, or do you need CityEngine? Philip, do you want to take that one?
Sure. So CityEngine does have native application support that's shared over ArcGIS Online with it's ArcGIS 360 VR. That does require CityEngine to produce some of that visualization within that VR experience. We also have partners in this space where you can use ArcGIS Pro as a data management desktop application to both build and manage the data to then distribute over the web. So the one that comes to mind directly is ArcGIS. There's also VGIS, another partner solution that will enable these iPad-based VR types of activities so that you can see pipes underground. You can get a sense on the location of your network, for example.
Awesome, thank you. Next question. What types of data are typically required to make photorealistic scenes of cities? Stephen, do you want to try that one?
Sure. I think typically you need to use some type of I3S mesh, something that has a dense mesh that describes a city very well. Typically, it's going to be textured. Additionally, we have a lot of symbology capabilities, and you can plus the look of any type of city with symbology to add labeling, and then also more realistic, I guess, street furniture and so forth. Things like benches, cranes, and whatnot will, I guess, increase the photorealism of the environment as well.
Okay, great. Thank you. Next question, for 3D web scenes, will there be a possibility for integrating custom pop-up windows in either a configurable app or through web app builder? Who'd be best for this one?
Sure, I can take that one.
Sure.
So recently within Scene Viewer, in the last release, actually, the ability to author your own pop-ups directly within the Scene Viewer experience, both for feature layers and for scene layers. So those pop-ups also then are accessible through the applications that consume those scenes. Both Web App Builder and Experience Builder will honor those custom pop-ups that are created either in Scene Viewer or can be authored with ArcGIS Pro into the scene.
Great, thank you. When Voxel are going to be available to publish in Enterprise and ArcGIS Online? Yvonne, you want to take that one?
Sure. We are currently working on publishing voxel layers. We will follow the same pattern as we have done with other large 3D content. So it will be an I3S layer, a scene layer. The timeline is, as Philip mentioned, we are working on it right now. That is the ArcGIS Pro 2.9 release cycle to be able to create SLPKs and then also publish them. The earliest ArcGIS Online client could be 9.4 or 10.1 to consume it. And then, of course, Enterprise would be in that release cycle that comes after 10.9.1.
Great, thank you.
If everything works the way we want to.
Yep, got it. Okay, great, thanks. Can 3D scenes work with ArcGIS dashboards? Great question. Stephen, do you think you can handle that one?
I might have to hand that off to Phil.
Phil, okay.
Phil, do you know?
Yeah, no problem. So it's not an immediate plan for dashboard to support 3D scenes. However, we're getting a very dashboard-like experience now with Experience Builder. Recently, Experience Builder included the capability of charting on feature layers, which is a very similar type of experience that the users expect from dashboard in terms of understanding statistics and counts of features, using it for a variety of different purposes for a 3D common operating picture. So now is the time to really start to pick up Experience Builder and understand how it works so that you can consume those 3D scenes and over the web and be able to create distributable applications for your workflows.
Great, thank you. Next question, are there any go-to places to locate free publicly available city-state building data with z-values to extrude or similar data to what was used in the New York example? Philip, do you want to take that one too? Oh. Or Yvonne? Great, yeah. Anyone?
Sorry.
I'm just kind of, making sure we all share the wealth.
There are many open data initiatives. For example, here in Europe, one that I definitely want to mention is in the Netherlands, all the 3D buildings are actually available as for free. There are also some other cities in all over the world that are having this data available. And of course, there is OpenStreetMaps where we can also get additional data.
Great, thanks,
So
Yvonne.
I think just to follow up on that, to answer the question, where can I go to find 3D buildings that I can consume within a scene is actually ArcGIS Online. A lot of our cities and our users have shared their 3D content through ArcGIS Online, so that you could search, like New York City buildings, for example, and then you can filter the content in ArcGIS Online to show scene layers, and that'll give you a good opportunity to be able to really search for. Most urban areas actually have 3D buildings that are accessible in the U.S.
I know for me, oftentimes in ArcGIS Pro, I find it just by searching in Pro, you can look at the data. So that's a pretty easy way just to discover it as well.
Yeah, and you can also search for building footprints, and if you have LiDAR for them, you can create buildings from the footprints and the LiDAR data in Pro. It's another workflow.
All four of us had an answer for this.
There's lots of ways.
Teamwork. All right, let's see here. Is it possible to share a NetCDF file or a voxel in a web app? So we kind of talked about that already, didn't we, Yvonne?
So it will be an SLPK that you can upload and then consume.
Yep, great. Let's see. Is ArcGIS Pro capable to output to a 3D VR glasses, as well as to use the 3D shutter glasses?
I can answer this.
Talk about that. Okay.
You can render and output movies to 3D glasses. There's an option to go to 3D cyan red glasses for anaglyph, and then also 3D shutter glasses. That's available in ArcGIS Pro's options, display options, I think.
Okay, great. Thanks. Is it possible to generate a 3D mesh from a colorized glass? I can talk to this a little bit too. Not in ArcGIS Pro yet. We do have, there's a few applications that, what was it, Philip, that we recently?
Sure.
Is there, I can't remember the name, lost for the name of the application. Maybe you can mention it, but out of ArcGIS Pro, we don't have a way to generate a scene layer, right, Yvonne, maybe?
Integrated meshes integrated meshes currently, there are multiple ways to create it, be it via drone to map or site scan.
That's
also, Shore is another, Shore's N-frames is another way to create it. Currently, ArcGIS Pro itself doesn't have the
capabilities. Okay, great. When will we be able to export results of exploratory tools as raster layer features, like viewshed, line of sight? Stephen, you want to take that one?
Yeah, I'm not sure about exporting rasters. Although
Features.
you can export tables from the EAT tools or exploratory analysis tools. So those tools obviously have various attributes, and those can be exported and shared as a layer.
Okay, great. Will there be a way to use CityGML models without using FME?
So I have an answer for this one.
Okay, great.
And the answer is kind of. So we license FME as the data interoperability extension within ArcGIS Pro. And because of the need for interaction between CityGML and I3S, we have created working with Conterra, created a geoprocessing tool that utilizes FME in the back end, but it also keeps you from having to work through the FME configurations. You don't need to be an FME expert in order to convert CityGML to I3S content. And so that can be found. I'll leave a link for this on that question.
Okay, great. Excellent. Next one. You're about to deprecate the CityEngine web scene. What is the replacement option for it in the future?
Well, I'll take this one here too.
Sure.
So the CityEngine web scene viewer is intended to stream 3D content over the web that's generated from CityEngine. So CityEngine already can generate scene layers and other contents that's available through Scene Viewer. Scene Viewer is the mechanism that we're using to bring together I3S content and feature layers within ArcGIS Online, and then or Enterprise, and then to create a 3D experience that's over the web that can then be consumed downstream by 3D applications. So we are currently in the process of deprecating that CityEngine web viewer.
Okay. Are voxel layers available through standard ArcMap or only through Pro? Move on.
Only Pro. We have no plans of making this accessible in ArcMap, just because we will not have the technical abilities in ArcMap that we have with ArcGIS Pro. Also, we haven't mentioned. I'm not quite sure if we mentioned that in the presentation, but voxel layers are now available on a basic licensing. What is a great improvement, I think, for many of our users. They can now just use voxel layers without needing an advanced license.
Great. Next question. Can you process photogrammetric point clouds from standard non-drone aerial photography in ArcGIS Pro? I can take this and you all can add to it if you want. We can visualize and work with photogrammetric point clouds in Pro. Our geoprocessing tools work on them well, but keep in mind that they were designed and the algorithms are built for aerial LiDAR. So you might not get the results that you really want using these photogrammetric drive point clouds. But yes, we can work with them. Does anyone have anything to add on that? Good.
Yep.
Okay. Are there 3D capabilities in ArcGIS Pro planned to eventually replace any rendering software people already use for BIM?
Well, I think it supports the processing and the requirements that BIM viewers typically have. I think what a lot of what we've seen so far in the AEC industry is that Pro is used as a mechanism to consume the BIM data, either Revit or IFC as a data source, and then to share that as a building scene layer over the web. So you have all the functionality of filtering, level selection by being able to select the disciplines and categories. But what we've seen that's been really interesting is that the ability to bring together like 80 BIM models into the same scene that also contains a contextual GIS information. So it's really a useful way of being able to bring it all together into one place. There's plenty of approaches with visualizing BIM, but there is definitely an interchange between BIM in GIS that has been growing, and we've seen a lot of use, especially within 3D GIS.
Great, thanks. Does the building layer work with IFC? Yvonne, you want to take that one?
Yes, it does work. That was a quick one. Yes, we have added
We
this
have 1 minute.
capability in ArcGIS Pro 2.8.
Great. What we create 3D for ArcGIS Pro be available for use in story maps?
Absolutely. Story maps can consume scenes that are that utilize the data created in ArcGIS Pro and published to ArcGIS Online and Enterprise. And then you can use slides to mark through different points in your plot line in order to create a very, a fantastic experience for the end users and consumers of that 3D content.
Great, thanks. And does Clip Scene Layer package work with point clouds?
Yes. We are working on this right now. We hope to have it available for you in 2.9, clipping point cloud scene layers.
All right. Ooh, I think we have time maybe for one more. With 3D web scenes, will the ability to implement tables and related attribute data be implemented?
That's something that we're working on as well, through related tables that you can symbolize on the related tables. We don't have a immediate timeline yet, but it's always good to hear these requirements. And if you're the specific person that asked us, why don't you find us afterwards, as well as any of the additional expert that we have here for further conversation. We couldn't get to everybody's questions, but thank you for joining us.
Yeah, thank you, everyone.
Thank you.
Thank you.
Sort of better explain how the elevation actually works on such a flat island.
Yeah, he applied some humanness to it. Like, you got an idea, it's not just a bumpy map, but it actually, you can see how big a tree is or a person is. So that kind of really helps you understand that this is barely sticking out of the water.
Yeah, I remember last year Aaron did quite a small scale map of a large area, and he's kind of reversed the idea this year.
Yeah.
And done a wonderful job. I just really enjoyed the coherence of all of the elements, and everything seemed to be held together using this sort of coral pink color scheme.
Yeah.
So even though the map had a lot of green on it and it popped, everything else was subtly integrated. The title, the neat line around the edge, all of the sort of extra graphical stuff in that bottom left-hand corner, a lot of the labeling. I mean, I think that's just a wonderful little cartographic design touch.
It's like perfect color scheme for an island off the coast of Florida.
Yeah, no, I love the little transects on the side. It's kind of that Joy Division album cover vibe to it. The heartbeat of the elevation going across the island.
Showing your age there, Nathan.
Well,
Don't mind me saying so.
I can Google just as much as anybody. So just kind of gives you an idea of just how flat it is, but also where it is ridged. And the whole thing sort of streaks down, sort of wraps down and around. You see those ridge lines? Everything sort of just flows nicely.
Yeah.
And then he curved the title to match
that's the thing that grabbed me immediately, was that title.
Yeah.
In the Prisma font, which means you don't need to put Times New Roman or Arial on your maps. You can actually use something else. So who's going to say except Comic Sans? but mixing and matching some really cool fonts can actually also give a spark of interest. It makes people want to look at your map a little bit more.
Yeah.
Which one's next?
Next up.
Next up is the Weminuche Wilderness by Sterling Lutz. I hope I've pronounced your name correctly, Sterling. And this is just a wonderfully fresh looking representation of elevation. Topographic maps aren't all the same, you know, but there's an awful lot of material that you have to put in them, a lot of content. And if you can make your topographic map look vaguely fresh and different by just using slightly different shades for the tints for elevation, or a slightly different hill shade characteristic, they really do mark your map out as something slightly different. And in here, the amount of text that's on this map is quite phenomenal, with lots of different elements and colours and hierarchies built into it. So,
yeah,
I really like this map.
This is a really, I'd say, just an impressive example of a classic topographic map, you know, where the colors really work. The thing that really struck me about this map is how much annotation is on there. There's so much labeling information, but it's not overwhelming. You know, there's so many great choices in typography and color and balance that I just think he nailed it with
it's a great
the
job.
labeling.
Yeah.
Yeah, I mean, the whole thing's just really soothing. It's just like, it's got this
could go to
vibe.
sleep.
Yeah, well,
What are you
almost.
saying?
You know, like, it's just like come here and you'll have a really good time because it's just beautiful and green and everything's calm here. I Googled some images of this area and there's a lot of that green and grey sort of in that area, and it's kind of like, it helps bring that out. I think the lower areas and the high areas, the way those colours switch over. So I really like the vibe of this one. Worked well for me. The other thing I'm just going to mention is down the bottom is there's two, like a double header of scale maps. There's yes, it's in Colorado, and yes, here it is in Colorado. So instead of trying to put one tiny little dot, spread it out across two.
Yep.
Two little mini zooms in. I thought that was pretty cool.
Yeah, I've never heard a map called Soothing before. I'm going to write that down. Yeah.
All right, well, let's move to the next one. Ready for the third one?
Yep.
So this is walking during the pandemic. This is actually two maps. And this is by Barbara Kent. And she went walking a dog and did 600 miles. I really wish they'd done 500 miles. And then 500 more, just to be the man. And what they've done here that I really like is that they've broken what could have been hundreds of maps, or one map with too much on it, into two very simplistic maps. And they're things that matter to you when you're walking. You care about the terrain, the elevation, going up and down hill. And then you also care about crazy dogs that you meet along the way, especially if you're walking your own dogs. What do you think?
Yeah, I love this. I mean, if anybody knows my particular love for maps, it's mostly thematic maps, and I was really drawn to this for a lot of cartographic reasons, but also one other which I'll mention in a moment. I particularly like the inset in that bottom right-hand corner of the first map, because it showed the distance that they'd walked in total as a scale in terms of, you know, 2/3 of the way up California, which was a really nice way of representing the total mileage. And I like the north arrow as well, because it proves that you don't have to have north as up. They've rotated the geography and therefore rotated the north arrow as well. So if the map fits a different, you know, orientation, just move the map to the form rather than, you know, something else that's kind of crazy. But on a personal note, it seems that Barbara and I had exactly the same idea sort of a year and so ago. And along with my partner Linda and our dog Wisley, he gets a mention everywhere, doesn't he? We mapped his walks, or I've mapped his walks. And the interesting thing is it's using a completely different aesthetic than the one that Barbara chose. So you may be interested or not, but I'm going to be showing Wisley's walks Wednesday in the Map Wizardry session, and you can then see how I took a completely different approach to Barbara's. But I do really like the colour scheme and the way Barbara went about this map.
For me, you know what I really loved about these two maps is they totally work together, but they've got like the perfect color scheme. You know, there's the one that like my friend and I were walking our dog and it's sunny and it's great. We live in San Diego and everything's awesome. And then the other one is like, these dogs are like all over the place, and it's a little bit more ominous, you know, kind of grayish purple. The other thing about this one, the barking dogs, is it's sort of like the perfect example of an ordinal data set, you know? And I mean, when else do you get to see a map that goes from minor woofs all the way up to bonkers? Like that's
the scale.
That is the scale, and I just loved it. super loved it.
I think what it also proves is that your dog's fine, your own dog's fine, but any other dog in the neighbourhood, nope.
Yeah.
Nope, not interested.
Yeah.
So yeah, that's a lovely piece of work,
Yeah.
Barbara. Thank you.
And we've got one more quick one before we move away from the map gallery, right?
We do.
We've got Tree Canopy in Austin, Texas by Alan HOLTER. And this is a pretty simple map. It's just a single data set of points.
Yeah.
You know, what do you think about this?
And a title.
Well, and a title, yeah.
It's got a title. I mean, it's pretty important.
I know what I like about it, but what do you like about it?
I like the fact that these kind of maps are they're almost a whole genre in their own right. I mean, I kind of refer to them a little bit more as data art or data cart as opposed to a map.
Yep.
I mean, a map to me has other accoutrements. You know, it has a title, but there's other information that gives it context and makes it something, I guess, more cartographic. This to me is art, but it's no less great for it, which is why we're looking at it today.
To me, it's like sometimes where the data isn't, that's what tells the story.
Yeah.
You know, and this is a perfect example
You
of
can
that.
see the rivers and the coastline.
Yep.
That's the whole point, right?
Yeah, I like a lot of these kind of maps because you often find that they will take on the shape of whatever it is that's being, or the generic shape of whatever it is that's being mapped. You see a lot of world maps that use this kind of technique, and they pick out the shape of the continents, and they're just terrific. And I do like the colour scheme because it's not like there's a great contrast between the background and the green that's been used. It's actually quite subtle, and works really, really, really well.
Yeah, they decided what they wanted to show, and they showed it really well.
I think even you could make that.
It's possible. Let's not go too far.
So let's move on. We are going to talk about more maps tomorrow in Mappy Hour, but we have some other segments to get to, right?
Yep. Okay.
We are going
so we're going to go and talk to Ask a Cartographer. Okay, so Ask a Cartographer. So we need a cartographer. But before we get to that cartographer, I just want to set this up a little bit. A couple of weeks ago, that fantastic toy manufacturer Lego released the biggest map, or the biggest set, I should say, ever. And it happened to be a map. And of course, the cartographic world went bonkers, to use the correct word. And everybody I knew bought a copy of this set with 11,500 pieces in it. But of course, being cartographers, we've all turned them into something that they shouldn't have been. So for instance, I've turned some of my set into, part of the United Kingdom. It's actually the British Isles, if someone's going to correct me on that. And why not? Because that's what Lego's for, right? You can mess around with it in all sorts of different ways. And behind me, I also created a Spielhaus projection of the Earth's oceans. Now, why Lego, and why introduce this as Ask a Cartographer? Well, it turns out that Lego Group actually used a projection called Equal Earth as the basis for the design of their map. And we dug around a bit and got confirmation of this, and we thought, well, let's ask our good friend and colleague, Bojan Šaurić, onto the programme to talk about the Equal Earth projection, because he was involved in the creation of the Equal Earth projection. So Bojan, hello, where are you?
Hello guys. Hi.
Hello Bojan.
Hey Bojan.
So you're our projections expert. You're the guy we go to, right?
Yeah,
So
usually.
firstly, perhaps, tell us a little bit about your work as a map projections expert at Esri.
I'm actually part of a larger team. I'm not just the only one. We're a team of 6 domain experts working on coordinate systems and transformations and all the mathematics that is behind that, which includes also map projections. So we do a lot of research, but not just programming. And a lot of customers are coming to us asking questions as well as internally, like Ken, Edie, and Nathan. They come and ask questions, so we help them out. So we also do like a lot of education and trying to kind of help people to do the right thing.
That's cool, and we do come to you a lot. All sorts of math questions all go to Bojan. I was just going to ask, how did this Equal Earth projection come about? How did you get started on it, and why did you make it?
Well, the original idea for the projection was actually proposed by Tom Patterson. He used to work for U.S. National Park Service. Now he's retired, and he invited me and Bernhard Tieni from Monash University to collaborate on this project. It came just out of frustration that like we really need some good equal area projection that would kind of represent the whole world. So we choose the cylindrical one, like you guys see in the screen, and we also make sure that it's equal area. So basically projection works perfectly for world maps, but not just any world maps, also like thematic world maps specifically. Tom also created a series of wall maps in equal area projection, and I think right now they're translated in 12 different languages, which is pretty.
Yeah, they look amazing. So do you have a favorite map projection? Are you willing to tell us what that might be?
I would probably say natural Earth projection. But I don't have any good reason. Like it's more personal because this is the projection that I first work on, and so it kind of has a
sentimental favorite.
Yeah.
That's okay. You're allowed to have one of those.
So can I ask the counter question, which is, do you have a projection you don't particularly like, and why?
Yes, I do have one, and it is true that I'm not a very big fan of WebMercator.
Yeah, you've only got 1 minute to talk about this, Bojan.
Yeah, I was short. But like just to clarify, like it's nothing wrong with WebMercator directly. And like every map projection, even Equal Earth or WebMercator, they come with certain trade-offs. And when we're using them for making a map, we have to be aware of them. And when we're selecting a projection, we have to make sure that like we take that into account. A lot of times, actually, we can also take the advantage of them. Like in case in Equal Earth, like it has a nice rounded shape and equal area property, which makes perfect for thematic mapping. But the issue with WebMercator is that it's so widely misused across the board that sometimes becomes really annoying.
Does it ever work?
So Bojan, like, what would you tell people who are trying to learn more about what makes sense, what projections they should use? Like, have you got any advice for people who are just getting started with map projections and coordinate systems?
I would basically guide people into the direction that like whatever they're doing, they have to consider it. So like. Map projection is not the one that like you select one and you use for completely everything, whatever you want. Right. Everything is case by case basis. So like you really have to think before, you know what your project is, but before you start, like make sure that like you really select the right one for the purpose of whatever your project is.
Great. I think that's great advice.
Yeah, that's great. Thanks, Bojan. Thanks very much for coming on the show and telling us a little bit about projections.
Super to see you.
Hope to see you in real life soon.
Yeah, hope to.
Thanks, Bojan.
Bye.
Thanks, Bojan.
Okay, right. Well, after Bojan,
we gotta move on.
I'm afraid we're going to go downhill because we're going to invite John Nelson on. So next segment is Nelson's Nuggets of Knowledge.
John Nelson.
Hello.
Coming from his shed.
Yes. Hi, everybody.
Hey, John.
There he is.
John, hi.
Shed X.
Yeah, hi. It's good to see you. I miss you. Someday we'll again.
Who paid you to say that?
Yeah, we miss you too, John.
We're here to pick your brain. What do you know? What do you have? What are you going to tell us? You're going to show us something cool?
What I don't know.
Yeah.
So,
hey, John, what we were hoping was you would show us one of your cool maps, and we kind of talk about some of the techniques you used on that.
Okay, I'll show you a map. Yeah, so let's talk about the Appalachian Trail map, a journal atop trail map that's intended to be like this long thing that a hiker would sketch on. Do you want to know the backstory?
I do,
Sure.
John, because I love this map. I'm familiar with it.
See it right here. It's a big old tall map, and it's this thing in a like a bifold cardboard cover, really kind of field notes aesthetic. I was going for that all the way, and it's like this 6 foot tall accordion folded map. And one day, a colleague of ours, Eric Rainville, and I were just geeking out over these beautiful trail journals that people keep. And it's a work of art, all these, pressed flowers and notes and sketches that they keep. And I thought, it'd be great to have that, but with a little embedded map behind the pages, and you could write little notes along your journey and just keep it with you and fold it out to the right page. And so this is what came out of it.
Just like that.
Just like that. It took out. It fell right out.
Oh, good. So, I think we're getting a close-up of it now.
Touch and you can feel, and I'm lying. I'm just kidding. This is all digital. But the whole point of it was to make it look very realistic and tactile and something that you could actually scratch.
Which totally does.
And fold up and stick in your backpack. Thank you. Yeah, so I faked you out because it's all digital. It's just pixels. It's never been printed. But it was a lot of fun to make. And there's a couple cool, interesting things that I learned along the way and tried out. And like any map, it was an opportunity to experiment.
I just love how it's oriented to the trail, the whole thing. It's obviously a big, long, skinny map, but it's oriented to the trail, and you help your hiker map reader with those little the little squiggly guides down the side. So you have the overview of the entire trail, and then a little rectangle showing you where that page is. And I thought that was just genius. Do you want to talk about that for a sec?
Yeah, thanks. Sure.
We might have an image of that.
Using this would be somebody would fold this to the right page and just kind of keep it there for while they hike that section. And so it's like, it's the only map I've ever made that has like 6 inset maps, like you are here maps, but that's what it is. It's this big, tall sheet. It was created in ArcGIS Pro. You can have a 6-foot tall layout in ArcGIS Pro, and it's just a photograph of some paper that I dropped in the background, and it's an equidistant projection. Speaking of projections, Dr. Schauerich would be proud of me. I chose an equidistant projection because that's the phenomenon that we're talking about.
You're mapping distance.
You definitely care about what the distance is that you're hiking.
Yeah. Well, I love that shout out that, your layout does not have to be a square or, a regular. I think that's pretty cool.
There's a lot of there's a lot of history in long maps. You've got Travis White's Rivers Atlas, and all the way back to historic medieval times travel atlases that were really long, kind of scrolling maps.
Yeah. Like this. It's a little bit like the John Ogilvy strip maps, right?
Yeah.
Those old travel maps. So I'm guessing, John, because you're very good at doing research for your maps. So I presume you hiked the trail, did you? Just to get all of that first-hand knowledge?
I have hiked across the Appalachian Trail.
So transects.
It was easy.
I
transected the Appalachian Trail, no problem. I don't know what the big deal is.
Wow, did you bring snacks for that?
I didn't have to hike very far.
So I really like the fact that it's in one color as well, pretty much. One color palette. Yeah.
Thanks. It's monochromatic. It's all everything's blue. The hill shade is blue, which came from Living Atlas. And the boundaries are blue. The little grid overlay is a bunch of blue dots.
Tell us more about that grid overlay.
Oh, sure. Yeah, so like I said, I was looking for the field notes, that gorgeous, simple throwback vintage Americana aesthetic of field notes. And sometimes instead of lines in their notebooks, they have gridded, and I love gridded paper. And they'll sometimes do dotted grid. And I thought, how do I get that aesthetic into this map? But have it actually serve a purpose. I don't want to just lob something in there because it's fun looking. And so I thought, hey, let's use it as a scale. So every dot is a 5-mile distance. So you've got 5 miles, 5 miles, 5 miles. And so there is no scale bar on this map. The grid is your scale bar. There's a little note on the back cover saying you can use this grid as a scale bar. A diagonal one would actually be about 7 miles. Instead of 5.
Yeah, that is pretty cool. That's pretty cool. I love that little triangle. It's kind of like your scale bar, but.
So don't let this go to your head, John. But what I like about a lot of your work is the attention to detail, and that kind of, it helps lift the map, above the ordinary. I'll deny ever saying that, by the way.
I wish I was recording. Dang it.
Yeah. If only there would be a recording.
Yeah, thank you very much. It's hard to know when to stop. You know what I mean? You're working on a map, and it's fun. We get paid to play at making maps, and we're geographers, and who's got it better than than GIS
Yeah.
folks.
You make a good point though about when to stop, right? There's always got to be some place to stop, because you could just keep iterating, right?
Yeah.
Yeah. I think you could sell that
When I
map,
know when
though.
to stop, when I think I just can't wait to show this to somebody, I got to show this to Boyan. Then I'm like, okay, it's time to stop. I got to get this out the door and work on something else.
Yeah.
Yeah, it's lovely work, John. I want to scroll it up like an actual scroll. That's actually how I want to. I'm looking for you to print some of these so we can have them. That would be lovely. And you're coming back another next 2 days as well, right?
Yep.
I'll be back. I'm sorry. I'll be back tomorrow.
We'll have an editorial meeting about that, but other than that, yeah.
All right.
Yeah.
Thanks, John.
Thanks, John.
John, it's good to see you.
Yeah, always good to see you.
Thanks, John.
So let's move to the next section, curiosities.
Yeah, we've got one more guest.
Yes.
Okay, cartographic curiosities. It is my pleasure to introduce our last guest of today's Mappy Hour, which is a good friend of mine, Heather Smith, who is not only an excellent cartographer, but really accomplished artist.
Really?
Yeah.
Double really.
Heather, hi.
Hello. Hi, Heather.
How's it going?
Great.
Hey, welcome.
guys.
Welcome to Mappy Hour. It's good to see you. Heather, I was hoping that you could start out and just tell us a little bit about yourself and what you do at Esri.
Sure. I'm a content engineer and a cartographer on the Learn ArcGIS team. So that means I write and edit the lessons that are available for free at learn.arcgis.com. And there's a lot of people on that team. So I also assist some of the other people with cartographic reviews for the lessons they're developing.
Cool.
And you've recently got a new course, right? What's that all about? Should we be interested?
Of course.
Tell us.
Yeah, I've been working on this cartography course. It's called How to Make a Map. And you guys have been helping me with it as well as a bunch of other people at Esri. So it's curated, it's a self-guided course, there's videos, there's lessons, there's articles, all about thematic mapping. So if you're thinking, I want to make my maps better, I don't know where to start, this is what I would recommend. Go there, check out the essential lessons, check out all the other recommended resources. I've tried to kind of curate this set to just help people who are already making maps learn how to make them better, learn how to enjoy it more. The other cool thing is that this course, you can do the whole thing in ArcGIS Pro or ArcGIS Online. I've got resources for both, or you can do it in both. I hope you try out all of the resources. And if you're used to using Pro, this is a great way to figure out how to do those same cartographic things in online or vice versa.
I think that's the real beauty of this course that you've written, is that, like you said, it's on both platforms. So if you're familiar on the other, or just learn both, or learn one. I also love that you really did pull out the essentials in the course. So maybe you don't have time to do everything in there, but you can hit the highlights. And I think you did a fantastic job.
Yeah. Have you done the course? I haven't done the course.
I've done a lot of the course, yes.
Have you done the course?
I have not yet taken the course. I probably should.
Yeah, I could learn something.
I probably could.
Heather, you are also a very accomplished artist, and we were going to take a look at some of your work because there's a real geography component to what you do. Can you tell us a bit more about that? Maybe tell us about one of your pieces?
Sure. Yeah, I do a lot of different things in art, but landscape would really be at the core of that practice. And I think landscape, a lot of the times people consider it kind of a boring form of art. It's just pretty pictures that sell well. But, as I'm sure all of you geographers can appreciate that actually landscape is very exciting. It's really fascinating subject matter. And since becoming a cartographer and learning more geography and geology and ecology and GIS, I think that has allowed me to justify this a bit more as landscape is actually really important and it's really interesting.
Yeah.
That's especially, not boring.
Yeah.
What's that?
It's
that's
gorgeous.
Not boring. That's gorgeous.
So to me, that looks like a classic old Heinrich Beran panorama, and he was a great panoramist who did all sorts of maps, particularly for ski resorts and landscapes. I mean, did you think about that specifically, or is that just my take on it?
I'm very flattered by your take. Yeah. I wasn't thinking about him specifically, but I was thinking a bit about mapping there where the hills in that painting are a little bit squished. They're a little bit vertically exaggerated, which is a trick that I really like to use in 3D mapping as well.
But we do that in cartography all the time, right? We generalize, we tweak, we move things around just to make things clear for the map reader.
Hey, before we let you go, Heather, have you got any advice for the budding artist cartographer? What's your final tip?
I can share I think it's a pretty practical tip that I find really helpful for myself when I'm stuck, is to make the whole map in black and white. Just throw out all the color, just do the whole thing in black and white. That way you really will nail down your composition. You'll be forced to make symbols that just work no matter what. And then when you finish, when you finish it, in this case, I decided I didn't need any color, but usually you get to the end, you're like, okay, now I know where the color is going to go. Now I'm going to add the color in purposefully. Color is really hard to do. So I find if I don't have to think about it for the first whole part of the process, I just make a better map. It's the same with the painting. If I'm going to make a big, colorful painting, I'm not going to start with a paintbrush. I'm just going to start with a pencil. I'm going to make a sketch.
Yeah. What a great tip.
Yeah, and I like that tip, particularly that last point that you made about just getting a piece of paper out and sketching something.
Yep.
Just see what falls out of your head onto the paper, and that's often a really good place to start with making a map.
Yeah.
So thanks, Heather.
Heather,
that was great.
That was really awesome
Amazing.
to learn about that.
Cool.
Thank you.
So we've got one very final little segment, which we've called Final Tips.
Final tips. Yeah, we asked our guests to give out final tips. Now it's time for us to fess up on ours.
Yeah.
Yeah.
Okay, so really quick fire, final tips. I'll go first. There are very few rules in cartography, okay? Very few. I mean, there's one or two.
There's one or two.
There's one or two.
Yeah,
but there's generally very few. But there's a lot of best practices. And my top tip is try to get familiar with some of those best practices, because if you do, you'll then know how to break them. And that is what creates the magic in some original cartography.
Yeah.
And have fun.
Have fun.
Have fun. Yeah. For me, my tip comes a lot from kind of what Heather was just saying. Just gather inspiration for your maps from all sorts of art and design forms, architecture, ceramics, painting. There's so much inspiration that can be found there, and just different ways to convey line, color. You know, it all applies to mapping.
Yeah, absolutely. And I'm just going to, yeah, I'll just say that I think it's all about having a vision, that you're going to make a map. You're doing it for a reason, have a purpose, maybe even write it down and keep coming back to it. Because sometimes you get diverted and you do the wrong thing. So have a vision and stick to it. That's what it's all about.
Cool. Thank you.
Love it.
Yeah.
Thank you.
Thanks to everyone for joining us. Hopefully you'll come back tomorrow, please.
We'll some more Mappy Hour.
Hey, thanks to our guests too.
Fantastic. Thank you very much.
Thank you. See you all tomorrow.
Bye.
Have a good Mappy Hour.
Thank you, gang. That was amazing. Looking forward to tomorrow's show. Thanks so much for entertaining everyone for the last hour. And to our users, thank you so much, especially those of you on the East Coast and in Europe. It is late, we know. Thank you for spending all day with us. It was a great day, though we do apologize for the tech workshop pieces. We're pretty sure we have those figured out. So we should be good to go tomorrow. I'll have an update in the morning. And actually, speaking tomorrow morning, Brady, got a little something?
Yeah, I look forward to seeing everybody back first thing in the morning, 7 a.m. Pacific time, and there will be a noticeable change. We will have a special guest starting us off in the morning, and we will be filming from a secret location. So I'm going to give you a little wink to see if you can figure out where we are. So looking forward to day 2 of Esri's UC, and we will see you then.
Yes. So again, everyone have a good evening, good morning, good night. We'll see you bright and early West Coast time. And if you stick on for a few more minutes, we're going to post-production piece. Thank you so much. We'll see you tomorrow.
Take care.
identified the outbreak with an artificial intelligence surveillance system days before official reports. A first-year PhD student at Johns Hopkins set up an online dashboard in a day that now gives billions actionable insight in real time. Red dots appeared on the map and grew larger. It became clear no country would be spared. COVID-19 was highly transmittable and spreading fast. In the dark spaces on the map where data had been withheld, satellites revealed the deadly impact officials had been hiding. In the United States, early warnings went unheeded. From one Florida beach, cell phone data visualization showed the consequences of large social gatherings as spring breakers brought the virus home. What is the map out of this mess? How do we maintain a level of intensity necessary to mobilize a response? How do we move from data to insight to action? What tools will protect us from the next pandemic? This summer on the Geospatial Revolution.